Now in this session, we are going to start with a package or a library in Python. Python has a support of several libraries which helps us to work on additional data structures, additional way of doing different activities. Python is universally used for different activities, okay. So that is the reason it is much more approachable by everyone. And to start with doing any kind of analysis over data or doing any numerical computation, we will require a package that is NumPy. NumPy is a package which helps us to work on data and process the data faster way. So let us understand this package in detail. So at the end of the session, you will understand what is NumPy, what is a NumPy array, how to create a NumPy array attributes, methods, and how to slice an array, index an array, and then doing different operations using arrays. At the same time, at iteration through arrays. So how we can iterate through an array in a NumPy data. So NumPy, as I told, is a package. We have several packages in Python actually. These all packages helps us to work on. We have several packages in Python. These all packages helps us to work on different level of data, different types of information, or do a certain set of tasks. So NumPy is one such package which will allow us to work on data in a very efficient way. It will also allow us to work on arrays in a very efficient way. Talking about NumPy, so as the name NumPy, it is broken down into two parts, that is numerical Python. So Python is a programming language, as we discussed. Python is a programming language, as we discussed, and that is the reason it has its own limitation. It is powerful enough to do different kind of activities over data, different kind of loop structures, different level of engagement over data, program your style of execution. So it has all that flexibility, but it is not flexible enough to handle a large proportion of data. So in order to make it more efficient, we have NumPy. So NumPy allows us to handle large proportion of data, and it is not possible to have a lot of libraries or lot of computational functions inside Python by itself. Because if we do it, if the developers do it, so Python itself will become very heavy. And as I told that Python is a multifunctional programming toolkit. So it is essential that it has its core version, and if you want to do data analytics, if you want to do data related operations, so you need a specialized package for it. So suppose you don't want to do data related operation, you want to do network related operation. In that case, you do not have to work, or you do not have to have a software which already has data related operation. So the developers of Python have not used or does not have data specific kind of packages or data specific kind of functionalities. It has a core version of Python, a programming language which can help you to work on any kind of cross functional activities, be it developer activities, be it data related activities, be it as network related activities, any kind of stuff you can do it with Python. So that is why the core version of Python does not have this kind of functionalities of handling data. And here in Python we have something called as NumPy. So NumPy has this functionality. It is an additional package which is an open source package developed by community of Python developers or NumPy developers. This is an open source community. People go and give their suggestions, and when it is globally accepted, it is kind of embedded into the NumPy application. We see a progressive growth in NumPy as well from a time to time being. So NumPy is a package which will help you to do numerical activities when it comes to Python. So if you want to do numerical activities, any algebraic calculation, any mathematical computation, any matrix level computation, so we have numerical Python or NumPy for it. Okay, so it is used for mathematical and scientific calculations, as we discussed right now. Mathematical, all possible mathematical computation we can do over arrays of data, over set of data. It is not essential that you do it over arrays. It can be done over certain input data or certain individual level data, but array is the basic data structure for NumPy. Okay, so it allows so it allows us to do mathematical computation and scientific calculations. It also provides linear algebra module, which contains functions like det, eig, nom, norm to apply linear algebra on NumPy arrays. So basically, we as we are working on developing a solution, okay, if it is a scientific or AI related solution, you require to implement certain set of mathematical calculations like derivatives, integrations, then eigenvalue transformation, breaking down the array into a different level of data like eigenvalue, eigenvectors, and you also need to normalize your data to some extent. So when we have such kind of things in our area of analysis, if you are developing a new algorithm, if you require these calculations to be done, so Python doesn't solely will be help you, like Python solely will not be able to help you out. So we require NumPy, which will which will allow you to work on solely on all these operations. So derivative, integration, eigenvalue, eigenvectors, these all are already there into NumPy. So it makes it more powerful, it gives you more power to do computation. Most of the algorithms, if you find it, like machine learning algorithms or deep learning algorithms, they use NumPy as their framework of data. They accept the NumPy data only for pre-processing, because they are somewhere using this NumPy calculation matrix transformations to do calculations within that set of algorithms. So NumPy is a core of any kind of algorithm or data related algorithms for handling the data and doing some computation. Now NumPy array is one of the most widely used library, okay, because as I told you that everything uses the basic component, as we discussed, as Python, and if I want to implement any algorithm, so I will require the basic component will be always the Python, but I will also require some computation. Okay, so NumPy basically gives you that kind of computations, and that is why it is most widely used. Like almost in every linear algorithm or any machine learning algorithm, you will be using NumPy. Okay, so that's the introduction of NumPy. It is an open source library in Python that allows you to do linear, mathematical and different algebraic level calculations. Now let's understand how to get started with NumPy. First of all, so we need to do an installation of NumPy if you are not using it on Anaconda Studio. If you are using only Python, if you are doing a developer related activity, if you are developing some web application or something, if you are developing an API or something, like if you are developing something on a remote or on another studio or another IDE, or if you are using core python.py, so you need to install NumPy. Okay, if you do not install it, it will not enable, like it will not be enabled, you cannot work on it. Okay, so the first part of the installation is first part of using NumPy is to install it, because it is an external library, it is not an Python core library. So to install it, we use the code pip install NumPy. You can directly use this in your command prompt when you activate your Python. Okay, so if you are activating your Python, you can directly write it there in your command prompt or in your MacBook terminal. If you are using MacBook, so in terminal you can directly type Python 3 environment will get activated. Once the Python 3 environment gets activated, you can directly write pip install NumPy, and automatically it will install NumPy. Okay. If you are doing it on Jupyter Notebook, so in the Jupyter Notebook environment, you have to type factorial symbol before it or exclamation mark before it, like exclamation pip install NumPy. So if you do it and if you run it using shift and enter, it will directly install NumPy into your core Python based environment, and then you can use it anywhere, anytime, whenever you need it. Okay. So that is the best part of using NumPy. You can install it very easily with a single line of code. You don't have to go on any website. While you're doing the installation, while you run this, you need to make sure that your internet is constantly active. If your internet is not active, you cannot install it, because it has to be imported from internet only. So make sure that internet is active. It will download the NumPy first, and then slowly it will start installing it. Now to start with NumPy, so as we discussed, it is an external library. So even if you have installed it in your Python is not overloaded. It is an external library which is present along with your Python module. Python base environment, along with the base environment, you have an external module which is installed. This doesn't makes your Python heavy. Your Python will work in the same efficient way, same way which it was working earlier. It will not go slow. So that is the best part, because it is an additional library. So if you want to run Python, so you can simply call it import NumPy with an alias. Okay, if you import NumPy, then only that NumPy will now be integrated with your Python. You have called NumPy here, and now you can work on it. Even though if you have called, it will not make it slow, because externally it is on a different module you are working out. Okay, even though you are working in Python, you are using Python as a language to interact with NumPy module. So we import using this common syntax, which is already there on their official website as well, like on the NumPy website. If you go the official documentation, you can find it, import NumPy as NP. Now we will talk about NumPy arrays. So the basic component of keeping the data intact in machine or in your NumPy, in a NumPy module, is arrays. You can store the data in NumPy in the form of array. So arrays is the basic data structure of NumPy. So NumPy array looks similar to a list in Python. So the way we have seen list, it is in the same way. The NumPy array is in the same way. It is a grid of values indexed by positive integers. You can use positive integers to keep the index values of that particular, like the way we have indexed in list, the same way of indexing you use in NumPy. It generally contains numeric values, and sometimes it can also contain strings. It is, although, like as I told, it is NumPy, it is a numerical Python. Numerical operations can be done on it, but you can store string values also, like you can store string values in your NumPy array. NumPy array works faster than list because it is homogeneous in nature. Because homogeneous means the NumPy arrays will have continuous set of homogeneous values, because the way you have the same set of data, you can keep it in a NumPy array. It can be multi-dimensional. You can have n-dimensional NumPy array to store data in different level of detail. Like if you want row column way of handling the data, you can have n number of rows, n number of columns. If you have any more dimension, z dimension also, you can have it. So let's understand about one-dimensional NumPy array. So one-dimensional NumPy array contains elements only in a single dimension or in a single list. It appears like a complete list. It is also contains only single shape. The shape, it basically represents the number of rows into it. So a NumPy array, which is one dimensional, will contain a set of values in a form of singular in a form of data, which is like a tuple or a list. Two-dimensional NumPy array, on the other hand, is an array with an array. Like if you have an array Within that array, if you have an array that is two-dimensional NumPy array, the way we have seen in list, nested list and two-dimensional like NumPy array, kind of same. The position of an data element is referred by two indices instead of one indice. So as we see that NumPy array, which is two-dimensional in nature, it cannot be only discussed, or it cannot be only indexed only based on one single level of data or one single array. It is two-dimensional in nature in the form of row and columns. Various on three-dimensional NumPy array, it involves three nested level of arrays. So you will find the third dimension as well. So if you talk about a NumPy array with third dimension, so basically the first two dimensions or the first two parts are rows and columns, and third dimension basically represents a new set of two-dimensional array itself. So as you can see here, it is actually a new set of two-dimensional array at every level. So this is my x, this is my y, and if I talk about z, z basically represent the third axis, which is how many different arrays of similar structures are there within this NumPy array. Now let's understand how do you create a NumPy array, because this is a basic structure of NumPy. Like if you want to work on NumPy, you need to understand NumPy array in a detailed way, and also need to understand how can you create a NumPy array. So let's try to understand. In order to create a NumPy array, you can use np.array. This is the first method. You can use np.array to create a NumPy array. You have to pass in iterable within that np.array. So you can pass a list into it, and it will create a NumPy array with the values which you have mentioned in the list, and it will be called as nd array. The type of the data will be nd array or n-dimensional array. You can keep different level of data. You can keep string data as well. If you are creating a NumPy array, all you need to do is pass the string values into a list, and automatically it will create it, as you can see on the screen. We'll try to discuss this with the help of a code in a Jupyter notebook. And then if you want to create it, you have another method by using random numbers. So if you want to create random arrays of certain value, like say if you want to create random arrays of size 20, you can simply just type np.random.random and np.random.random. We will talk about this later on when we are doing implementation. What we will try to understand is the size is equal to 20. It will allow you to create 20 random numbers in a NumPy array. So you can see the 20 random numbers are created here. So the random method returns random numbers over the half open interval, which means 0 to 1. It will take all the values from 0 to 1. So you need to specify the size parameter if you want to create a NumPy array of randomly distributed value between 0 to 1. Now we also have np.rand, which is also used to create a NumPy array. So rand method basically creates a NumPy array of the given shape, and between 0 to 1 it again creates the same, but the dimensions of the returned array should all be positive, and like it will all be positive. And if argument is given, a single Python float is returned. So basically what if you are not given any argument, it will create a single Python floating point number. If you do not specify, you can create NP array of random size here. So let's talk about these all parameters, and let's try to understand how we can work on NumPy actually in your Jupyter notebook. So this is our Jupyter notebook, fresh one that we have created. You all know how to work on Jupyter notebook, how to create it. The first part that we will discuss is installation part of NumPy array. We have to type the factorial and then pip install NumPy. Now see what is this exclamation mark basically indicating. So the exclamation mark indicates that whatever you are writing after it, it is not going to get run onto your Python or Jupyter notebook console. It is skipped by Python and it is running on your terminal. Okay, if you run this, whatever output it is shown here, it will be your terminal output or command prompt output. So let's try running it, and it is saying that requirement already satisfied and error parsing dependencies of text rack. So basically there is an update in NumPy because NumPy keeps on updating on a continuous basis. So it is because of that. So it is a warning, actually it is not an error also, so we can basically ignore it. If it was an error, it would have come in red and this would have been not executed correctly, so it is not an error. So text-ract is something which is actually messed around by my system. Okay, so I'm using an older version. Maybe in your version you will not find this error. This is how. So already I have installed NumPy, so you don't like if you run it, if it is not installed, it will install it. The best part of using Anaconda Studio, I have already discussed earlier when we installed Anaconda. So you do not have to manually install NumPy or any data related libraries directly. It is already pre-installed. You don't have to work on it. If you want to see which all libraries are pre-installed, you can click on help here and you can see all different set of libraries which are necessary for working on data or developer related activities is already there. So you can see Python already there. You can see the Python reference manual here, IPy reference, NumPy reference is also there. So it is showing because already NumPy is installed into it. So you don't have to install if you're working on Jupyter Notebook for Python. So that is our NumPy installation. And then if you want to start with NumPy first of all, so NumPy is an external library, as I discussed. It is an external thing. This is my core Python environment. Even if I have installed it, it doesn't mean that it is there in Python. Python doesn't have it right now. So you can import NumPy by simply calling import NumPy. Okay, with this also I can work on NumPy. Okay, or if you want to, like if I write it like this, import NumPy, so every time I want to use NumPy, say I want to create a NumPy array, so NumPy dot array I have to type every time. Okay, if I have to work on NumPy, I have to write NumPy, and then if I want to create an array, so NumPy dot array I have to write, and I have to do something. So basically it is asking some positional values. I'm passing an empty list. So basically if I want to create a NumPy array, so NumPy array basically it will require a argument that is list. I have passed an empty list. I'm creating a NumPy array. So I can basically write it like this, import NumPy, and then keep on working on it. But the problem is basically it will require me to put some more efforts in writing NumPy all the time. So I don't want to put that much effort while working on NumPy. So what I would do here is I will simply import NumPy as an alias. You can put any alias name here like NP, FP, RP, NA, whatever, N, T, A, whatever you put it, it will be an alias of NumPy, basically representing NumPy here. Okay, so importing NumPy as NP will put the NumPy data into NP, and when I run it, so you can see now I do not have to type NumPy all the time. I have to just type np.array and it will work. Okay, now NP was not initially present in my workbook. You can see it is imported along with NumPy. So NumPy, whatever functionalities are there of NumPy now will be represented by NP. So this becomes good. Like if I am a developer, I do not have to write continuously in NumPy. I can simply use NP and my work is done. I can use all functionalities of NumPy using NP. So that is the best part of NumPy array. Then we will talk about the one-dimensional NumPy array generation. So for that I will first create an array1, as this is my first array, so I'll call it as array1, and I will create a NumPy array np.array, and inside it, as I mentioned, I have to pass a list of values. So I'll pass some data points. Okay, and when I run it, it will allow me to create an array, which is a NumPy array with certain set of values from like 6 values are there in my NumPy array. And this is how it actually basically looks like your list only. There is no difference, you cannot tell any difference here. Okay, whatever values you are putting here, all these values will be actually there if you are creating a NumPy array. This is my NumPy array 1. I will create a NumPy array 2, which is similar to this only, but the values I will put it something different. So I'll be putting say so I'm putting a set of values which are string in nature. So if I run it, and if you see this array 2, so array 2 basically is an string array. Okay, so D type you can see it is less than U5, and if you see array 1, the D type is not mentioned. Okay, we will see what is this D type and everything in detail in the upcoming part. So let's first understand only what we can create. So this is how we can create a basic NumPy array. This is the first way of creating a NumPy array, and the best part is it will basically, you have to just simply pass your values here. Okay, and it will create a NumPy array. Okay, now let us understand some more things about creating array in a different way. So suppose I want to create a array 3, and now I want to create an array 3 which is having some data randomly. Okay, so we can use np dot, you can see np dot, if I put and press tab, I see some suggestions. So I want to use random. Okay, but random cannot be directly used. If I want to, like if I use C, if I use parenthesis, there is no there is no function. Random is not a function, it is a module within the NumPy package. So there is no, it is not a function, there is no syntax for it, like you cannot put anything into it. So random is a module, it is not a it is not a function. So within the NumPy random module, I need some other function. So I want to use np dot random. So np dot random dot, I can use int or random. So this random, if I put 20 values, so it is going to create array 3 with 20 values, as we have seen this in our presentation as well. So these are our 20 random values that we can create using this np.random. Now let us try to understand in detail of this np.random.random function. So np.random.random function, basically if you want to understand it in detail, so basically as you are in library, you have not learned more about this library. This is your maybe this is your first time you're interacting with a library, so you need to have a support over that library, how to use it, how I can not use it. So for that I can use shift tab. I have to come over here within the parenthesis. I can press shift tab, and you can see the official documentation opens here, and you can scroll over it. I'll just open it in detail. I want to read it in detail, so I'll press it here, and it is gone. So basically if you want to read in detail about that NumPy package, so you can see the functionality over here. So random basically requires only one argument, that is size, and you can create a NumPy array using this NumPy random function. So this allows us to create a NumPy array with any random number. So you put 10, it will create 10. If you put 2, it will create 2 values only. So it is creating an array. So this is also a method of creating an array in NumPy. So these are the two methods by which we can create. We also have another method to create. Let us create an array 4. So I'll just put 4 over here, and instead of random I'm just using rand. Okay, and I am mentioning that I want 2 values only. So rand function also helps us to create random numbers. The best part of random function is you can create n-dimensional NumPy array. So I'm creating 2-dimensional NumPy array of size 2 by 3, which means 2 rows will be there and there will be 3 columns. So there are 3 columns and 2 rows in this NumPy array. So this also helps us to create n-dimensional, 2-dimensional NumPy array along with it. and you can put like it will create the same way it is creating a NumPy random values. Now let's understand what is this set of what kind of random values it is creating. So it is creating random values from 0 to 1 only. Okay, you can see it is always in float, and you have values in float only. So this allows you to create random values between 0 to 1. Now we will try to understand one more method of creating NumPy array, array 5. So we also have a function called as np.random.randint, and randint function allows you to create a NumPy array like this, and you can see the official documentation which we opened a minute ago. It is down here. I will minimize my Python area and we can remove it. And this is np.random.randint. And now in my randint function, let's understand what this random int function is doing. This randint function requires some argument, that is low, high, size, and d type is equal to integer. So let's understand it in better way. So if we talk about it, you can see the np.random.randint, the official documentation is here. Let's understand what does this each of the component of this randint function actually indicate. So low, okay, low basically indicates integer or row like of integers. So lowest letter integers to be drawn from the distribution. Basically, what is the lowest value that you want to extract or randomly create as an integer. Okay, this is an integer random number generator. High basically tells us what is the maximum value that you want to create. Size indicates what is the size of array, like how much values you want to create. And d type basically indicates what kind of data type you want to set here. So here is a demonstration also. You can see np.random.randint 5 it is putting, so it was going to create 5 values of size is equal to 2,4. 5 basically indicates maximum value here, like it cannot go beyond 5. Sometimes you can mention np.random.randint, if you are putting 1 here, 3, 5, 10 are the values. So if you are putting 3, 5, 10, so it is creating a array of 1 by 3 array with 3 different upper bounds. So there are 3 different upper bounds. You are putting the first upper bound is 3, second upper bound is 5, and third upper bound as 10. You can have multiple upper bounds to generate multiple values here for different set of data. Here 1 by 3 array with 3 different lower bounds. So here there are 3 different lower bounds. So lower values like 1, 5, 7. These all things we can definitely create, okay, and maximum value is 10. So basically it will create lower values in the first iteration or the first data which is generated. It can have minimum value as 1, like it cannot go below 1, it cannot be 0. The second minimum value can be here, it is below, like it cannot go below 5 because the lower bound is 5. And here 7 is the lower boundary, so it is not going to go below 7 while creating this random integer values. So you can create integer values, you can create floating point number, whatever you want to type, whatever values you want to create, you can create it. So with different levels of lower and upper bounds, we'll try to understand and create a normal function. So you can see a detailed documentation also. You just have to come here, press shift enter, and you can find a detailed documentation to understand more about this function. Okay, so it depends on how and what kind of use case you are into, you can create it. So this is our array 5. Right now I am not passing anything, so it is asking, okay, give me some at least one positional argument. So I'll put 1. So if I put 1, so it is going to create 0. If I run it again, it is going to create 0. If I run it again, it is going to create 0, because I am saying you have to create an array of lower bound like the value as 1, it is higher bound or the upper bound value as 1. So this is mandatory. If I put upper bound as say 5, so it will create a NumPy array of value 5. So every time I run, it will create random numbers from 0 to 5. If I mention I want lower bound as low is equal to say 1 and high is equal to 5, if I mentioning it, so it is creating any number between 1 to 5. If I am putting lower bound as 11 and higher bound as 15. So it is going to create number between 11 to 15 only. It will not create any other number. Suppose I want to give some size of the array. So if I mention size is equal to say 10, so it will create a NumPy array of size 10 also. Okay, so that is the speciality of this random int. Now a random int function allows you to create random numbers from 11 to 15. We are creating 10 and it is an integer number generation, whereas random and rand will allow you to create only floating point or basically numbers between 0 to 1. So it depends on your use case, what values you have to create randomly. It will allow you to create that random numbers. So we have seen random, we have seen rand, we have seen random rand int functions to create random numbers. These are different ways you can create an array. The first method that we discussed was our np.array method that will allow you to create np.array. You have to pass in your own list and you can directly create an array. So that is one. Second part is you want to create it using randomly, like you can use random number generator, np.random.randint, rand or random. It will allow you to create different levels of random numbers based on whatever value size you are specifying into it. So these are the two methods that we have created. We have one more function, that is randn, and randn returns a set of values from the standard normal distribution. So here we need to understand it is going to use the standard normal distribution to create this random numbers. The dimension of the return array should all will be positive. It has to be positive whatever you dimension you are specifying, and if no argument is given, a single Python float is returned. So it will create a single Python floating point number. We discuss random int, so we will first see what is randn and how does this actually work. So we are going to create random arrays using randn. So we do not have these special like this expressions. So for randn you have to specify d0, d1, dn, and we need to understand what exactly this represents. So if we talk about arguments, so np.random.rand, and it will create a random numbers between with mean as mu and sigma square. So it is going to create a random numbers of this order. So it will create randomly any number of which is generated in a NumPy random value generation using normal distribution. So if you want to create it, you can simply pass in the number, and based on that number it will create or calculate the random numbers for that number. So let us create it. We have seen the docstring and we'll just pass in any number. So I'll pass say 2 and it is creating random numbers around 2. So array5 basically creates random number around, like it is creating 2 random numbers. If I mention it again, it is creating 2 random numbers. Now these numbers which it is creating, it is also negative and positive. So if we talk about a normal distribution curve, so this is a normal distribution curve. So in a normal distribution, this is a standard normal distribution, assuming this to be a standard normal distribution perfectly. So the mean is always at 0, and this is a negative part, this is the positive part, and it will always create number between negative values to positive values based on the standard normal distribution values. So that is what is happening in random n. So random n, if you specify 20, 30, so it will accordingly create random numbers whatever you mention here. So this is one more method of randomly creating values. Then we will talk about random function, which we discussed. Random function returns random integers from low inclusive and high exclusive values, which means it will create, suppose if I am mentioning 2 to 10, it will create all numbers from 2 to 9, not 10. Okay, it will not consider 10. If you want to create random numbers between 10 to 99, you have to specify 10, 100. It will create 10 random numbers from 10, 99 only. So it will include 99 as well. if you are putting whatever value you are putting at the second argument, it will not consider that value, that is the max value, and it will not be considered. So it follows the standard Python procedure of indexing. The way Python is working, it ignores the last value. So that is what we are using random.randint. We have already worked on randint, so we will move forward. Now the last or one more method of creating a NumPy array is by using the NumPy.arange function or np.arange function. Now it is a very interesting serial number generator. Okay, so what does this do? It will create a list of or array of numbers for which I have to specify the starting point and stopping point and the step size. If I specify the step size, it will accordingly create the NumPy array of that order. So here if I put 1 and if I put 10, so it will create NumPy arrays from 1 to 10 if the step size is 1. So it will create values 1, 2, 3, 4, 5, 6, 7, 8, 9. It will not include 10. As we discussed, it is not including the highest index value in Python. So the number generator have the same difference, and the function generates as many possible numbers in the given range. Whatever numbers we have specified, it will create that many numbers of values. So here is the syntax of creating a NumPy value or NumPy array. So NumPy array, we are using np.arange function to create it. Starting point is 10 and stopping point is 100. So it will create numbers from 10 to 99, and step size is 2, which means it will ignore 2 numbers at a time. So if first number is 10, so systematically it is going to create 10, 12, 14, 16, 18, like that. It will create a set of values, and it is very useful to create sampling of data based on equal distribution of values. So it helps us to create series indexes of data. So we can use NumPy array to do it, arange function to do it. Let's try to implement this over our Python Jupyter notebook, a very interesting one. So array 5 will use array 6, and in array 6 we are using np.arange directly. It is called arange, not arrange, so we have to make sure we are using the proper spelling, arange. If you use arrange, so it will not help you out. You have to mention like from where to where. So if I want to create values from 1 to 20, so it will allow me. If I am not mentioning any step size, okay, it is returning array 5, I want array 6. If you do not mention any step size, so it is by default taking 1 as a step size, which means it is incrementing value as 1. If I mention the step size as 2, so it will take only numbers after 2 intervals, like after 1 it is going to skip 2 and it will take 3, after 3 it is going to skip 4, it is going to take 5, after 5 it is going to skip 6 and it is going to take 7, and like that continuously it is going to generate values from 1 to 20. So this is the one such way of creating arrays using arange function, and it is a very interesting function because it allows us to create integer values from certain set of data. Like it is we need to only specify how many values from where to where we have to create. If you put 11 to 201, it will systematically create numbers from 11 to 201, and in a very easier way. The way like if you are doing it on Python directly using for loop or something, you do need to write a lot of code to create sequential numbers. So you need to write while loop, for loop, whatever loop you want to switch in, you can use it. But using arrays in a single line, you can do it, and you don't have to put any efforts over here. Now we will talk about linspace. Linspace is an function in NumPy which allows us to generate a specified number of values in specified range. Okay, so the start of the interval you have to specify, stop of the interval you have to specify, the number of values which is required in the interval you have to specify, and data type. So linspace is one such method to create values in array. So we'll talk about it. So suppose we are going to create a number of arrays between 1 and 100. So you have to specify start is equal to 1, stop is equal to 100, and num is equal to 10, which means you have to create 10 values, and you can see it is creating 10 values from starting from 1 to 100. So this is how we can use linspace. It is similar to the one that we have used in arrange, but the difference is we are actually using a method which will generate values starting from 1 to 100, and it is going to use like if we are mentioning 10 values, so automatically it is taking some linear space. So automatically it is going to take some line spaces. One after 1 it is going to take 12, after 12 it is going to take 23, after 23 it is going to take 34, after 34 it is going to take 45. Likewise it keeps on generating numbers after 45, 56. A difference of 10 it is actually assuming here, 10 to 11 difference it is actually assuming here, and it is generating the number. So we'll talk about it in our Python NumPy notebook. So we'll use np.linspace. So I'm talking about the 7th way of creating a NumPy array, np. Okay, linspace if we are using, so linearly it is going to create this numbers. If we talk about 1 to 10 or 1 to 100, so it will create 1 to 110 numbers, and if I put 10, so as you can see it is creating a set of numbers starting from 1, it is taking 1 to 11, the second number is 12. If we add 11 to 12, it is going to be 11 plus 12, which is 23. If we add 23 plus 11, it is going to 23 plus 11, it is going to be 34. 34 plus 11, it is 45, 45 plus 56. So it is linearly, it is a linear spacing. If you want to do a linear spacing, you can use it. Okay, we can talk and discuss about it in detail by just running this shift enter and try to understand what exactly this function actually talks about. So linear space is an function which will accept an argument start, stop, start to mention how many values, like starting from where I have to create these numbers, then stopping point, how many number of values we have to create, end point, RET step, which is false. So it returns evenly spaced numbers over a specified interval. Returns number evenly spaced samples calculated over the interval starting and stop. The endpoint of this interval can optionally be excluded, like you can exclude it, and if you talk about it, the starting point, everything is mentioned here. Now if you see it, it is not creating values, like if I'm mentioning 2.0, 3.0, num is equal to 5, so it will create evenly spaced number from 2 to 3. Okay, of size of numerical size is equal to 5, which means 5 numbers it is going to generate. We'll talk about the calculation part here. If you see it, from 1, if I'm mentioning 1 to 100, actually I'm talking about 1 to 99. So 1 to 99, the difference actually comes out to be 11. If I want to develop 10 values, so evenly distributed 10 values from 1 to 100 it has to create. So it is going to take a difference of 11 units to create this evenly spaced number. If we mention 1 to say 10, and if I'm mentioning 10, let's see, so it is going to create evenly spaced number 1, after that it is going to take 2. If I mention 11, it is going to use 1, then 1.9, 2.8, evenly spaced number. Lean space actually allows to have a common difference between, like the difference between the two numbers has to be common. I'll close this out. So that is one such function that we have used, that is linspace, to create NumPy arrays. You can create NumPy arrays by using multiple other functions. If you want to create a NumPy arrays to have only zeros, you can use zeros function. If you want to create a NumPy arrays of having only ones, you can use np.ones. So these are two special functions like np.zeros and np.ones to create NumPy arrays of zeros and ones. So we'll talk about these two first in detail, and then we will talk about the other. Let's talk about np array 8 is equal to np dot zeros. If it talk, let's run it. So it requires a positional argument, say 1 if I mention. So array 8 is creating NumPy array 0, like with a value 0 point something, which means 0. If I mention 4, it will create NumPy array of size. It will create NumPy array with the value 0 or 4 NumPy arrays of values 0 only. Okay. We'll talk about this NumPy array in detail, understanding the syntax part of np.zeros, because most of the time it is used in doing some algebraic calculation in certain algorithms, and somewhere you are finding it becomes difficult to understand it clearly. So let's talk about it. So np.zeros, it requires the shape of an array, the data type of an array, that is float, order is equal to C it says, and star basically representing other arguments, and like is equal to none. So shape of an array can be 2, 3 or 2, or whatever shape you want to create, you can put that shape here. If you do not mention any shape, if you mention only 5 as a number, so it will just create a NumPy array of 5 values. If you put 5 2, 1, it will create NumPy array of 2 rows and 1 column with zeros only. Similarly 2, 2, it will create 2 arrays, like it will create a 2-dimensional array of 2 rows and 2 columns, which will 2 rows and 2 columns which will have zeros only. So this is the general syntax of NumPy np.zeros to create NumPy arrays. So that is the eighth method by which you can create it. If you mention, say if I mention 4, 3, it will allow me to create 4, 3. Okay. So if I put np.zeros 4, 3, I have to mention shape actually like this. So shape is equal to 4, 3. It is going to create an array with 4 rows and 3 columns of value zeros. Okay. So that this is first way of creating NumPy arrays of having only zeros. We'll talk about array 9, which will create an array of ones. Okay. So we'll talk about array of size ones. So if we talk about it, it will have only value 1, as we see. It uses the same syntax as we had in zeros, nothing different. Only difference is the value will be 1, which is inside my np.ones, like inside my array. So all the values will be 1. If I want to create 2, 3 array, 2 rows and 3 columns, so that is also fine. It will allow us to create it. Now we will talk about a function in array, NumPy array. So np.empty returns the matrix with arbitrary values of any shape that you are passing it. Now what is arbitrary values? These are randomly generated values. So np.empty allows you to create it. If you mention d type is equal to integer, so let's do it. We will create array 10 now. So we have created 10 methods. We know the 10 methods of creating an array, and empty basically creates NumPy array of shape 2, 3 we are saying here, and we have to mention d type is equal to integer also, so that we will do. So if I am talking about creating an arbitrary value of NumPy array, so it allows me to create NumPy array with some arbitrary values, indicating an empty array. So this is an empty array with some arbitrary values into it. Now we will talk about np.full. np.full returns the matrix of given shape with value set by fill value parameter. So this will create a set of values in your NumPy array. So we'll talk about it. np.full. So the way we have done it for np.empty, we have something which is opposite of it, which is full, and we have to mention what value we have to pass in. So if I mention fill, okay, need to understand what is the argument. If you don't remember it, press shift tab. So if you mention shape, we have mentioned fill value, we need it, we cannot use fill. So fill value, if I mention 11, so it will create an NP array of size 2, 3. This is the 11th array we are talking about. So an array of 2, 3 with values 11, and this is my array 10, which is creating randomly array 10, which is arbitrarily creating values of shape 2, 3, where d type is integer. If I run it again, you can see the value is 10, and here the value is 11. So it is going to create an empty array of 2, 3 arbitrary, and here NP array of 2, 3 with values whatever we are mentioning. We need to understand in detail what is the functionality. We can talk about it here. So fill value is equal to scalar or array like fill value. So shape of the value we have to mention how many rows and how many columns you want. What is the data type you want to put, you can put it here. Order is equal to C and F, which is an optional parameter to store multidimensional data. C or Fortran contiguous row like data. So that is a method of storing the data in a contiguous memory location. Array like options. So like is whether it is an array like or optional, if you can keep it. What I was bothered about is I wanted to see what all set of filled value I can put here. So np.infinity, if you are putting, it will put infinite values into it. If you put 10, it will put 10, and if you put an array like this, so it will randomly put array of that essence over here. So we'll try to create or we will try to fill out randomly packed, or will pass on an array size over here. So I'm creating 2, 3. So I will pass a value 11, 12. Let's see, it is saying error because the shape of the array is 2 rows and 3 columns. So I need to pass in one more value here like 54 or something, and now it is going to create all sub arrays within this array, within this main array with values 11, 12 and 54. So that is the best part of fill value. It is going to just whatever array value you are passing, it will allow you to create the same array. Now we will talk about the identity function. So basically NumPy is more specific towards two-dimensional data and doing some linear calculation. So it has some more special functionalities, like it can create a identity matrix as well. So if you have known your matrix calculation or matrix, so identity matrix is one such thing that your NumPy array can create. So let's talk about it. So using array np.identity, let's talk about creating NumPy array of size say 3. So it will create an identity matrix of size 3 by 3. This is the 12th array. So 3 by 3, which is an identity matrix. So what is an identity matrix? Identity matrix has the diagonal elements as 1 and rest other values are going to be 0, which means if I solve this differential, or if we talk this, if I solve this identity matrix, the value is going to be 1 itself. So that is why it is an identity matrix. So this is a special functionality in arrays or NumPy arrays, because it allows you to create identity matrix as well. Then we'll talk about a function called as, then we'll talk about np.I. np.I is a matrix which will create n into m matrix, with values 1 on the kth diagonal element. So whatever k you are going to specify at that particular diagonal position, it is going to keep 1 as the value. If k is greater than 0, it represents upper diagonal element, and if it is less than 0, it is lower diagonal element. We'll try to understand what does this value basically, or what does this array basically we are going to use. We are going to use it to create a NumPy array. So let us use it here, and we are going to use np.I. We'll talk about it. So np.I. So np.I, it requires two. It requires two arguments, that is n and m. N can be none, okay, if you want to create like one dimensional array, but n is specified, it needs to be there. So suppose I am mentioning 4, 5 array, and I just run it. So it is going to create a NumPy array with k is equal to 0 or diagonal element is equal to 0. If I am putting it starts from the 0th element, and diagonally it will place everything as 1. If we put if I put comma, and then if I specify say 2, so it will create a NumPy array of where the diagonal elements are 1, but in the upper half. Okay, so here, so if I am putting, this is my 0, this is my 1, and if I am putting 2, so 2 basically from here the diagonal element will start. If I am putting -2, okay, if I put -2, so my diagonal elements will go from here to here, it will try to be here. So we'll try to create it by putting -2, and let's see what is the change we are going to get. So if we put -2, as I discussed, it is going to be here. So these are the methods by which we can definitely create a NumPy array of with using an I method. So if you want to place diagonal element as 1 on a specific location, you can definitely put it by mentioning -2, +2, or 0 or +1, whatever value you are putting, and understanding the fact that this is your 0 point, this is your -1. If you go below it, it is -2. If you want to put it above it from here in the upper triangle, that is going to be positive. So make sure that 0 indicates the first or the diagonal element at the first instance itself, and +1 basically the above this diagonal element, and -1, like minus, basically indicates the below one. Okay. So that's all in our NumPy array creation part. So we have seen like there are 12 methods actually, like we have seen 13 methods actually to create NumPy arrays. Very interesting way to create an arrays, but we hardly use any of it, like we hardly use 2 to 3 of it. There are instances if you are doing some calculation, algebraic expression, something like that. So in that instances you may be requiring some other additional methods such as np.identity or np.empty or whatever, like np.zeros, np.ones. These all things can be required in certain instances. These are very basically easy. You don't have to memorize this. All you need to memorize is first few methods, which is np.arange, np.random.randint, np.array. So these are basically the core methods of creating an array, and this is what is used usually. You don't have to memorize all of these methodologies, like it is not required to memorize all of it. If you know 3 to 4 of it, it is more than sufficient for you to work on NumPy arrays. Now we will talk about some NumPy array attributes. Array attributes are certain functions that allow us to understand more about arrays in detail. So here we can see some basic key attributes that helps us recognize or understand more about the data, that is shape, then we have size, then we have dtype and ndim. So shape, basically shape is used to help us understand what is the shape of an array. Size basically tells us what is the size of an array. Dtype will tell you what kind of data is there in that array, and ndim tells us what is the dimension of an array. So we will try to understand each of this in details. Now when we talk about attributes, attributes do not have parentheses, okay, following them. These are not actually methods, these are objects, you can call it, which gives us information about your NumPy array. So it holds information, it is an object actually, not an function. So suppose we have an array here, books is equal to np.array, and if you can see that this books array has two parts. First is the string part, where you have placed learn Python, data science general, and scale of for data science. So these are all data related array. Now 20, 23 and 18, these are numbers. So when we talk about this array, it is actually a two-dimensional array with two instances, two things into it. First is a list which is an outer list, and within that outer list we have two tuples, so it becomes a two-dimensional array. We'll try to create similar array into our Jupyter notebook and try to understand what is shape. So this gives us the shape of an array because it has two components, first tuple and second tuple. That's why it is two-dimensional. Two parts are there, which is two rows, and each of the part basically indicates a rows, and each part has three values. Okay, so if you see, first tuple has three values, that's why the number of columns is 3. So it creates an array of shape 2, 3. Similarly, size tells us what is the total number of elements inside this array. So if we talk about this size of this array, the same array, the size is given as 6. So it tells us that there are total 6 elements in this array. Then we talk about d type. So if we mention weight age dot d type, it will tell us that okay, the float type is, the data is in float type. So why it is giving float type? Because the information inside it is in float format. So this is one such method of understanding what kind of information is there. And finally ndim. So ndim tells us how many dimensions of data is there. So dimension basically tells us in the context of row, columns, and if we have any other third dimension over there or fourth dimension over there, it tells us the n dimensional proponent of it, like what is the number of dimension of this data. So we will try to discuss this in detail in our Jupyter notebook, try to understand of it, and I'll call array 1. So understanding this, so we are going to understand what is this array 1. So array 1 has certain elements, there are certain 6 elements, and these are 1, 4, 2, 5, 8, 2. This is an array which we have created. Now we will try to understand the shape of an array. So shape of an array is 6, which tells us that there are 6 elements, there are 6 rows into it. Then if we talk about array, this is a shape, it is 6, 1. If I talk about array 1 dot, and if I press dot, there are different attributes it basically tells me. So if I want to understand what is the size of an array, so I can directly put, it is giving me size of an array as 6. If I put array 1 dot, we discuss about the shape, we discuss about the size, and if we talk about ndim, what is the dimension of this array? This is a one-dimensional array. So these are basic data about our array and tells us more about the array. We have seen n dimensional, and we will talk about the d type also. So d type tells us array 1 dot d type. It will tell us like the data inside my array is integer in nature. If you have So if you can see this array 1, the data inside it is entirely integer in nature. There is an integer data, so integer 64 is the data into it. Array 1 dot shape, array 1 dot size, array 1 dot ndim, array 1 dot d type. We'll talk about array 2. Let's see what is array 2. I want a two-dimensional array, so this is an array 2. What I will do is we will create a 14th array, array 14. This array will have np dot array, and this array will have a list of 2 values. Okay, and another list of values, say so it has 2 parts. I have to create a 2-dimensional array like this, and if I put it, this is my array 14. Array 14 has elements, these are the first set of elements, these are the second set of elements. Now by default I have given the first value, I have given it as an integer, the second value I have given it as an float, but if I create this array, automatically all the values are becoming float. Okay, now we will try to understand different attributes of this array 14. So I'll call it out as array 14.shape, and if you can see, the array 14.shape has the shape of 2 rows and 4 columns, which means there are two rows. If we talk about array 14 dot size, so 2 comma 4, which means 2 4s are 8, the size is going to be 8 here, and we can see verified that the size is also 8 here. If we talk about the D type, so it will tell me that the data type is float 64, because this is integer, this is a float, so the combination is going to be float. And if I talk about array 14 dot endim, now endim tells me that this is a 2-dimensional array. Why 2-dimensional array? Because the data is represented in the form of rows and columns. Okay, that is why it is telling 2-dimensional array. Now I'll create an array to understand more about the endim part, to give you more context on it. So array 15 will create using np dot random dot randint. We are going to create an array of 15 where we specify the 12 as the value. So lower limit, the upper limit is 12. I'll put 2 comma 8 as the value, set of values. So it is going to create an array of 2 comma 8 random values. Okay, size I will mention, or shape. Let's see what is the argument into it. Size it is given as none. We will try to understand the more detail about it. So here is a part where we can create n-dimensional array. So here the lower limit is given as 1357, and then this is the size of an array, the values of an upper limit values of an array. So 10 and 20 as the upper limit values of an array. Size, let us create 20. Let me put it here. So the lower limit values is 2 comma 8. So I'll do what? I will create an array of values 2 comma 8, 10 comma 20. So this array is creating values between 10 comma 20. I want 4 values, so it is creating 4 values. Let me specify an array of 4 by 4. So it is going to create an array of 4 by 4 with certain set of values. If I mention 4 by 4 by 3, let's say, so it is going to create 3 arrays of 4 by 4. So first array 4 by 4, second array 4 by 4, third array 4 by 4, fourth array 4 by 4. So this 4 by 4 array, there are 3 arrays basically it is going to create. It is a 3-dimensional data now. Now for this 3-dimensional data, let us try to understand array 15 dot shape. Okay, so if I talk about shape of this array, it is saying 4 by 4 by 3, which we have which we can clearly see here while creating. We have mentioned 4 by 4 by 3. If I talk about array 15 dot size, which means 4 into 4, 16 3s are. So let's see what is the size. It is 48. So 16 3s are 48. So now this is how array 15 actually tells us, like we can store multiple value of array. Now array 15 dot d type, we will try to see what is the d type of it. It says integer 64. So there is it is an integer data type, and array 15 dot if we mention array 15 dot ndim. So ndim tells us what is the dimension. It is telling that 3-dimensional. Now let's understand what is the 3-dimensional NumPy array. I told you that NumPy array, we are creating a 4x4 NumPy array, but the dimension is 3, where we are talking there are 4 NumPy arrays, and each NumPy array of size 4x3 is there. So 4 rows and 3 columns. So a 4x3 NumPy array 4 times we have created. So this is how we can create and for like n-dimensional NumPy array. If you keep on specifying more and more dimension, like it will keep on creating arrays like this. So you can see 4x4. So 3x2 array, it is going to create 3 rows and 2 columns, where it will have 4 sets, and the number of sets of 4 sets, it is going to be increasing. So if you see the shape, it is 4-dimensional NumPy array. The size 4 into 4, 16 3s are 48 2s are 96 values it is going to create. And if you put d type, it is integer, dimension it is 4. So this is n-dimensional or 4th dimensional NumPy array. Hardly we are using more than 3 dimension, because the calculation are going to be in that sort only for each and every set of data. So this is one such way by which you can create or you can explore more about your NumPy array. So NDIMs, as we discussed, here is a very systematic way of understanding NDIM. So if it is a 1-dimensional array, it looks like this as a vector. We call it as a vector also. If it is a 2-dimensional array, it becomes like a matrix form or a tabular structure. If it is a 3-dimensional array, it creates n 2-dimensional arrays. It will create n 2-dimensional arrays along with our array. So this is how we can create n-dimensional array using ndim here. Now we have seen how to create array, how to explore more about array, understand that array. Sometimes you get an result as an array when you are doing some calculations, you are doing some algorithms or something. So you get an end result as an array. So you have to inspect that array. So the methods that we have seen, array.shape, size, d type, as well as ndim, this all basically tells us more about your output array or whatever array that you have received from anyone or any program or function or any output. Okay, so that is the method of exploring. Now we will try to understand what are different methods or functions that will help you in array to do certain processing in arrays. So methods are objects that are similar to functions that takes parameters in parentheses and returns modified objects. So it is like a function, normal function. It takes some input and modifies it and gives you the output. So we'll talk about some array functions or methods. So the first function that we are going to talk about is reshape. Now it is a very important function. Okay, it allows to mold your data in a very systematic way, even if it is not that much aligned properly or the way it is not arranged properly. Reshape can definitely help you out to arrange the data in a proper structured way in the number of dimension that you want to specify. Okay, all you have to do is you have to understand what is the current shape of your data or what is the size of your data. Is it possible to break down your data into a 2-dimensional unit or 3-dimensional unit? If you want to do it, you have to make sure that it can be broken down in the number of rows and columns. We will try to see it in detail here. So let's try to understand with the help of our array 1. I'm calling in our array 1, and this array 1 basically, this array 1 is an 1-dimensional array. The shape of an array we have already known, or shape of an array, if you see array 1, shape of this array is 6 comma something, so which means it has 6 attributes over it. We'll talk about this array 1 and if I use dot reshape, okay, I have reshape, and let's try to understand what is the parent, like what all parameters are there in reshape. It is not giving because it is a very common function. It requires how many rows and how many columns you have to create. Okay, I am telling that in my array I have 1 4 2 5 8 2 6 values into it. So if I want to break it down, either it can be 2 rows or 3 columns. It can be 2 rows 3 columns, it can be 3 rows 2 columns. Okay, right now it is 6 rows and 1 columns, so I can have 1 rows and 6 columns as well. Okay, so the same data can be arranged in this order, or this order. Let's try to arrange it in all possible orders which we can do, because there are 6 elements and it can be arranged in 2 comma 3 3 comma 2 1 comma 6 or 6 comma 1 only. Already I have 6 comma 1, which means 6 rows and 1 columns. So I will do what? I will do 2 comma 3. So if I do 2 comma 3, it is going to give me 2 rows and 3 columns for the same set of data. Same data I am getting 2 rows and 3 columns. If I do it for say 1 comma 3, let me try 1 comma 3. So it is giving me error. Why? Because I have 6 values. I have to unpack 6 values and restructure it as while restructuring it, I want 6 values only. If I am putting 1 comma 3, how will other values be fitted? It will give me 1 4 2, but where will the other values go? There will be a data loss. So reshape doesn't allow this data loss. So whatever number of values is there in your NumPy array, make sure that in the same order it can be arranged. If I am putting 1 comma 3, how will 6 values be fitted? So that is the problem. So I have to mention 1 comma 3. I can mention 3 comma 2 as well, because if I run 3 comma 2, it will return 6 values. So it can arrange 3 comma 2. You can see 1 4, then 2 5, then 8 2. The same set of values are kind of arranged in 2 comma 3 fashion. We can use array.reshape 1 comma 6 as well. Like I want 1 column and 6 1 row and 6 column. That is also quite possible, but the problem here is if you do it, you can see it is creating a single nested array within your array. So whatever is your array, within it is creating a sub array. So that is actually not going to be suiting well. Like it is going to create, it will put all the values here in a nested internal array. So here if you see the shape of this array, you will get that it is 1 comma 6 only. Like in the one row it has 6 columns. So this is, and there is one more method. Let's try it out if it works on this data. There is 1 comma minus 1, and it is also going to give you the shape same as what we have seen here. 1 comma minus 1 is going to give you the shape of 1 comma 6 as only. Let's try out minus 1 comma 1, and minus 1 comma 1, it is going to create an array of shape like this, which is going to create every element as single element into this array. If I put minus 1 comma 2, let's see, it is going to create an array shape of 3 by 2 like this, like the way we had 3 by 2. If I put minus 1 comma 1, it is going to create 6 by 1. Let's see what is the shape of this array. I'll store it into A, and this is my array A, and A dot shape, let's try to understand. So it is 6 comma 1. So original array, it was 6. Okay, it has 6 elements and no columns, like each and every element acted as an element of an vector. Later on, when we used minus 1 comma 1, it will create an array of shape 6 comma 1. So there is a difference, minus 1 comma 1 and 1 comma 1. So minus 1 comma 1 will create 6 by 1 ka shape of your array. You do not have to mention what is the size of an array. Now minus 1 comma 1 is quite possible with any kind of array that you are passing, like whatever array is there, you can do it. Let us try this out on array 15, which we have created. This is our array 15, and let's try it out certain reshaping things. So first of all, let's understand what is the shape of array 15. So array 15 has 96 elements. So let's array 15 has 96 elements. So 96 elements, we'll try to break it down into 48 comma 2. Let's do it. So it can break down the elements into 48 comma 2. If I want to break it if I want to break it out into 16 by 6, so that also is possible, 16 by 6. If I put minus 1 comma 1 minus 1, it is going to create an array with single dimension. If I put minus 1 comma 1, it is going to create an array with each element, so all 96 elements as a single unit values will be there. So reshape is a very powerful function. It actually allows you to reshape and mold any kind of NumPy array in a desired way of arrangement of data. So that is part of NumPy array. We have discussed this. Reshape. Now why we are understanding reshape? Because it is a very essential part when you are doing, if you are arranging the data for machine learning, model building or anything, so it will definitely help you out. So if you are familiar, it is fine, like it will help you out. It is not that difficult to understand, very simple syntax. So we have discussed reshaping the data. Then we will talk about array indexing. Now we will discuss about array indexing. Indexing we have seen in list, we have seen a tuple, dictionary. This is a method of extracting information, or this is a method of getting some information or putting data in a structured way. So array also supports indexing. Now array indexing is a little bit different from your list indexing, like it is similar to some extent, but as we have multi-dimensional array, so the way the array has been indexed, it is going to be different from the regular way of indexing. So the element in the array can be accessed by positional index of that element. So the index for an array starts from 0, and the last elements basically it is always negatively indexed. So we can index it negatively by using -1. The way we have done it list, in the same way we can do it for arrays as well. Like so, here we have a NumPy array, np.array with certain values, Charles 18, Logan 20, Jessica 34. It is a mixed array of two data types, string as well as integer both. And if we talk about retrieving a certain set of information from this array, so if you want to retrieve it, we can retrieve it by using indexing of array. So let's try to understand this indexing with the help of our Python Jupyter notebook. So I'll create an array 16 with a mixed set of values, np.array, and in it I will pass on two list. First is to put some name, and here I will pass some values, assuming these to be ages of these people, and put it into a sub array. This is my array 16. Okay, now this array 16 is a mix of data types. So the data type it is coming as less than U21, which means it's a mixed data type including string. So considering everything as string only, so this is a string data type. Now by default it will override whatever data type you are passing. So string can override your number, but number cannot override on string. You cannot convert 7 into number, but you can convert 20 into string 20. So that is how it works. This is an array 16 of shape. Let's understand the shape of this array. Whenever you get an array, let's please try running through this basic checks of this array. Array.shape, array.say size. So size is 6. Array 16.size. So array 16.size is 6. If I put array 16.endim, and it is 2, and data type, let's understand data type. Now it is interesting to note that by default the data type has become U21, which is basically for string data types. So this is our array, and we got a bit of understanding of our array. Now we are going to talk about indexing information from an array. Okay, so this is an array which is two-dimensional in nature, and if it is a two-dimensional array, we need to we need to understand how we can extract a certain information. So if I want to extract only win, okay, or if I want to extract the first row, so what I can do is array 16 and square bracket, if I put 0, so I can extract first row. I will add one more list into it and I'll put some values. Certain values I have specified. So it is an two-dimensional array of size 3 by 3, of shapes 3 by 3 and 9 elements. And now if I'm extracting the first values, you can see Sam, Win and Carl has been extracted. So Sam, so it is giving me the first sub array within my array, first set of row within my array. If I put array 1, it is going to give me second sub array. So it is going to give me second sub array within my array. So this is my second sub array. And if we talk about array 16 square bracket 2, it is going to give me third sub array within my array. Now what if I want only win, okay, if I want only win information, so what I will do, array win, okay, I want win only, so array 16. So where is win placed, in which sub array? This is the first sub array, this is the second sub array and this is the third sub array. So array, the value win is placed inside the first sub array. So what I have to do is I have to put 0 first here. So if I put 0, it is giving me a sub array Sam, Win and Carl. Now if I put Sam, Win and Carl over here, I want win only, okay. So win is at, if I talk about only this array, win is at position number 0, 1 and 2. It is at 1 position. So if I put square bracket 1, so it is giving me win. So win actually is my value, so that is what I wanted to extract. So if you want to extract a particular value, you can use this method. Now we'll try to do it in a way that array square bracket, and I'm talking about the 0th array. So 0th array is this, and I'm talking about the first value in the 0th array, which is 0, 1 and 2. If I put 1, so here is the same way of indexing the data. So you can use either this method, you can use either this method to get an array. This is a way you can extract a particular information from an array. So this is all about indexing. Indexing an array is very easy. You can do with the help of both the methods. Now you need to understand array indexing starts with negative as well. So if you are putting -1, so if I put -1 over here, if I put -1 over here, so it will give me the last array, not -11, -1. So it is going to give me last value for 0. So if I run this, the actual value is Sam, Win and Carl, but if I want last value, I have to put -1 for Carl. So it will return Carl. Similarly here also, if I put -1, it is going to give me Carl only. If I put, instead of 0, if I put -1, which means now it is going to consider the last row. So last row, last value, -1, -1. If you want to compare, see, this is the last row and last column. Array 16, if you want to compare, last row, last column, the value is 125. So you can use negative indexing also to index the data. It supports both positive as well as negative indexing, the one which we have used in Python. Now we will discuss about slicing an array. Slicing is a method by which you can get sub array of your continuous array. So if you don't want all the data, if you want only a particular proportion of an array, you can use slicing method. So here we can see different expression for slicing. The first 3 by 3 array is here, and the shaded part, if you want only the shaded part from your sub array. So there are two expression, like you can see here is one expression which we can help out. What I want is, I want from second row onwards all the data. I don't want 0th row. I want row number 1 and row number 2. I want these two data. So when I want these two data, I will use from 1 onwards. This is the syntax to include 1 onwards, which means I want all the values from 1 onwards. And then I want how many rows I want? I want only this and this row. So which are these two rows? These are only two rows. Okay, from starting I want only first two rows. That's why I'm putting nothing is to 2, which means 0 is to 2. If I put 0 is to 2, which means it will take all the columns like this, and from here till here it will take all the rows. So the shape is coming out to be 2 by 2 for the extracted array, and this is the value that you are going to get if you are using it. Okay, what if you want to extract? We have seen the extraction method by indexing method. So if I want only not the first value, if I want only the second value or the second list, this shaded part, so I can use array 1 like this, and array 1 will also give me a sub array of 50, 40, 50 and 60, and I can also use 1 is to 2. So 1 is to 2 means I want all the rows starting from 1 till 2, but it will always ignore the last number. So it is ignoring 2. If I am putting 1 is to 2, it is going to ignore the last number, which is 2, and it will put only this array of index 1, the starting index value, and I want all the values from it. So I want all the rows. I don't want only a specific rows columns. I want all the rows. So I can put double is to here, which means it will give all the rows. Okay, so this is another way of slicing an array. Now third method of slicing a 3 by 3 array is here. So this is a 3 by 3 array, and what if I want only 2 columns like this and no other values, like 2 columns, and from the first row only these 2 parts are my area of concern. I am not bothered about the unshaded part. So I want the first row, so I have to put 0 here. Okay, I want first row, the 0 I have to put. You can put 0, you can put 0 is to 1, and you want all the columns starting from index position 1. So this is a column index 0, this is a column index 1, and this is the column index 2. So I want all the values from column index 1 onwards. So if I talk about 1 onwards, so I can use this 1 is to, and it will give me the necessary value. So this is important. Okay, this will decide how many, like from where to where value you want. From 1 onwards I want all the values, it will give me all the values. If I put and also the 0, if I mention instead of 0, if I mention 1, so it will take these 2 values. Instead of 1, if I take 2, it will show these 2 values. So it depends what value you want to extract. Okay, so that is this is how the slicing approach actually works in Python. So you can use the slicing for a NumPy array, a single dimensional NumPy array. The way we have used in list, we can use it. This is the first slicing using 1D array. We'll discuss it. Let's see the discussion for slicing for 2D array as well in Python Jupyter Notebook. So let's so let us first create a 2-dimensional array. I already have one array 16. So array 16 is a 2-dimensional array of values. You can see with certain values. This is the 0th, this is the first, and this is the second. Now for this 2-dimensional array, if we talk about this 2-dimensional array, we need to see that what kind of information we want. We are talking about slicing now. Indexing is done, we are talking about slicing. I want specific values. I want, suppose the first, I'll just give some name. So this is the name of the first row indicates name, second row indicates age, assuming the age, and third row basically indicates daily wages or salary or something. So daily wages for these 3 people. Okay, so first for Sam the age is 20, and it is the value that is we are going to extract is 50. For Win it is 12, and for like the salary is 203, Carl it is 23, the ages, and 120. I'm just taking some random numbers, not going by literal sense. Okay, so I want to index certain specific portion. Suppose I want to index only the age for Win and Carl, or maybe I want only the salary for Sam and Carl, or something like that. So before starting into indexing a multi-dimensional array, we'll talk about indexing a single dimensional array. So I'll talk about array 1, and array 1 is a very best example to index certain things out of it. So if I want all the values, if I put double colons, it will give me all the values. If I want values from the first index position or the second index position, which means 0, 1 and 2. So I want values from 2 to all of the values, I can use 2 is 2. It will give me all the values from 2 is 2. Okay. So this is our array 1, and this is the method of indexing values from array 1. If I want -1, if I put here -1, it is giving me all the values except the last values. Okay. I want suppose values from -3 is to -1. So if I put -3 is to -1, it is taking, this is a -3 value, this is minus, it should be -1, this is -2 and this is -1. So it is not going to give me -2 because it is going to ignore the last index always, as we do in the normal way of handling the data. So this is with this we can get only the data like 2, 5 and 8. So this is negative indexing. Now we talk about one more method of indexing. Say if I want only, okay, if I want only values 1, 2 and 8. So here I can use double colons, 2 is 2 if I want only the 1, 2 and 8. If I want to start it from 1 onwards, so I can put like this. So it will give me values 4, 5 and 2. So it can give me values from 4, 5 and 2 in the index part. So this is how we can index specific information from your array. If you have understood this, we will move forward into the next part, that is array 16. Now we will try to understand array 16. If this is clear, we can use array 16 indexes. So suppose I want only the names. So if I want only the names, so I can simply use array 16 0. It will give me only names. If I want only ages, I have to put 1 year. If I want only the salaries, I have to put 2 year. If I want only the last row, if I put -1, it will give me the last row. If I want second last row, if I put -2, it will give me second last row. Like this, I have the data with me and I can do positive, negative indexes. Now let's try to extract some specific information. Suppose I want these two parts. Okay. So if I want only these two parts, the method for indexing is, I want the age for Vin and Carl. Okay. So if I want the age for Vin and Carl, so the method for indexing is, I want age. So age is present in the second column. So that's why I have to put here 1. So age I have got. I want it for Vin and Carl. So I can use square bracket here and I can put 1 is 2 and it will give me for Vin and Carl. I have to understand where is this positioned. Okay, if I don't know what is the age, where is Vin position, what is the index of Vin, what is the index of Carl, otherwise I cannot do it. Okay, I need to understand where these things are positioned. So this is the first part of indexing. You can do the same thing in a way like this, age for Vin and Carl if you want. So 1 is 2 if I put, it will give me age, and comma I will put 1 is 2, comma 1 is 2. It will also give me the age for Vin and Carl. So these are the two methods by which I can do indexing. Now we'll try to understand, what if I want certain values if I want information for only Vin. I want all the information about Vin. Okay, so let me write the problem statement here. I want all the information for Vin, age, all information for Vin, all info. Okay, all information for Vin and Carl. Let's see. I want all information for Vin and Carl, both of them. So first of all, I want name also, I want everything. Okay, so array 16, I'll put it here. So it gives me all the details for Vin, all of it. I want for Vin as well as Carl. So the index for Vin and Carl is square bracket, say, or the win and call index is 2 is 2. Okay, so it will give me detail about 2 is 2 all the information. So it is giving me all the information for call. I want it for win as well. So if I put 1 is 2, so what is happening here? I want, if I talk about this data, I want from this index onwards all of the information, all of the rows. So I am saying that give me all rows starting from columns 1 is 2, which means column 1 is win, and from there onwards I want all the values. So win and call, both the values I can see 1 is 2, all the values are given here. Okay. So this is the method by which you can do indexing for specific detail. If I want only for say call, okay, only for call I want, so 1 is 2, instead of 1 is 2 I have to put directly 2 or -1, it will give me detail of call only. Okay. If I put I want 1 is 2 for all of it, like win and call it is giving. What if I want for Sam and call? So I can do what? I can put remove it. Okay, let me try 1 and 0th index and 2nd index. If I put it, so you can see it is giving me for Sam and Carl. So this is one method, and another method that we can see here is the way which we have done here. So 0 is to 2 if we put it, this also can help us to, if I do it. So in this method also we can get it. What is this method? Okay, what is happening is I'm taking all the rows starting from the 0th row, all the row, and I want to skip it by 2 units. So it will skip the second wala and it will take the next wala element. So it is going to take Sam and then it will take Carl. So like that it is going to take or get index from informations along with the specific information that you are specifying. So indexing and slicing are the most crucial part of handling data or NumPy array. Here it is quite simple because we are using 2-dimensional NumPy array, but we need to practice a lot on this indexing part so as to understand multidimensional indexing, and that we can do definitely with practice, with more and more examples. You can definitely learn it out how you can do multidimensional indexing over this data. So this is one thing. Suppose I want the name and age only for Sam and Carl. Okay, I want name and age only for Sam and Carl. So I'll paste here. I want name and age for Win and Carl. Sorry, it's for Sam and Carl. This is for Sam and Carl. Sam. Okay. Here also I want name and age for Sam and Carl. So now if you see, I have Sam and Carl ka all information. This if I run this, it will give me all information for Sam and Carl. I want name and age, which means the first 2 rows I want. So I have to put here 0:2, and it will give me only the name and age for Sam and Carl. What if I want name and salary or wages for Sam and Carl? So if I run this, it is giving me all details. I've just copied it. I'll just remove it. If I run this, it will give me all details for Sam and Carl. I want name as well as wages for Sam and Carl. So for that I have to put double colons here, and here I can put 2, and it will give me name as well as age of or name as well as wages of Sam and Carl. So this method can definitely help you extract specific proportion of data using. So it is a bit easy. You just have to just go through it slowly and slowly first index a particular set of data, then index a value that you are concerned about. Directly if you go and do it using your own method, it will be difficult. Go it slowly. First extract which column you want, then extract which row you want, and then specify, keep on specifying. You have to do multiple times. So slowly you will learn more about indexing properly from an 2-dimensional array. So we have seen how to create an array, what is an array, NumPy array, how we can decide about certain attributes, what are different array methods. We have seen about shape, reshaping an array. We've seen slicing an array and indexing also, like how you can slice and index an array and get specific information from an array, get a sub array of your array. So these are different ways of extraction of data. Now we will talk about different array operation to understand more about array, how we can do different operation in array. So here we have an example of additional operation, that is arithmetic operation of addition. In arithmetic addition operation, it is all simple. We simply create two arrays of same size, and we simply create, we'll take sum of it or we'll take subtraction of it, and it will give you the element wise addition and subtraction of this NumPy array. So we'll talk about it, addition element, and then multiplying an array with a scalar value. We can also talk about element wise multiplication of a two arrays. We'll try to understand this method, that is Hadamard product, which is element wise multiplication of array. And we can also see here dot product of array, also like how we can get a dot product of an array. So we will see this basic operations, addition, subtraction and multiplications of an array. So for that I need to create two arrays of same size and same data types. So let me create ARR1. ARR1 is a NumPy array of values, some values I'm putting intentionally simple values so that it is easy to do some calculation. And this is the first array, and this is the second array. So here we have array 1, array 2 with certain values. Now what we will do, array 3 is equal to array 1 plus array 2. If we do it, if we talk about array 3, so if we do addition, it is going to simply add element wise all the elements of an array, like 2 plus 20 will become 22, 4 plus 40 will become 44, 1 plus 10 will become 11, and likewise. This is an element wise addition operation which is happening. We can also do multiplication, so I'll call it as added. This is added value, and we will create sub, and we'll use minus here, so it will do element wise subtraction. So 2 minus 20, which is minus 18, 4 minus 36, which is 4 minus 40, which is 30 minus 36, 1 minus 10 is equal to minus 9. That is why we are getting minus values, because we are subtracting it from 2, the bigger value, so we are getting negative values. So this is basic level mathematical operation that we have seen, arithmetic addition and subtraction. Now we'll try to understand multiplication as well. Let's take array 1 into 5. If I put array 1 into 5 or 4, so you can see array 1, the value was 2, 4, 1, 3, 2, 5, and if I multiply it, the value becomes 2 4s are 8, 4 4s are 16, 1 4s are 4, 4 3s are 12, 4 2s are 8, 4 5s are 20, and that's how I get that's how we get different set of values from array by doing this array multiplication part. So this is how we can get it. Array multiplication, this is a scalar array multiplication. Now let's try out array 1 into array 2. Okay, so if we do array 1 into array 2, what is the value that we are going to get? So let's understand what is array 1. Array 1, the value is 2, and array 2, the first value is 20. 2 into 20 we are getting 40, 4 into 40 we are getting 160, 1 into 10 we are getting 10, 3 into 30 we are getting 90, 2 into 20 we are getting 40, 5 into 50 we are getting 250. So these are different set of values that we can get using array multiplication. So these are very basic array multiplication operation you can implement. So we have seen multiplication of array with respect to 2 by 2 with respect to a element wise multiplication. Now we will discuss about dot multiplication. So what is a dot multiplication? It will multiply the array element wise. For example, this is my first row. This first row will multiply with the first, it will multiply with this, and then when it multiplies, it gives me this particular value. Then this value will multiply with this and it will give me this 8 number. Okay, how does this multiplication happen? Let's understand. 1 into say if I talk about 6, let me take 6 as a value. So 1 into, or let me take the given value that which is there. So 1 into 0, which will give me 1 plus 0 into 3 plus 2 into 4. So 1 into 0, 0 into 3 and 2 into 4. If I add it, the value is going to be 8, and that is why we are getting 8 here. Similarly, all other values are computed with respect to the respective rows and column position. Now we have to understand, if you have to do the dot multiplication, so the output will be based on the input arrays. Okay, so this is my first input array or matrix, this is a second input array or matrix. So we have to make sure that the number of columns over here are equivalent to number of rows in the second array. Okay, so this is my first array and this is my second array. The output or the second the number of columns in the first array will be equal to number of rows in the first array. Then only this multiplication will happen. Otherwise it is difficult, it may throw error to you. So let's understand it with the help of our Jupyter notebook. So this is our array 2. Let me talk about array 2, array 1, and if we talk about shape of array 1 dot shape, array 2 dot shape. Okay, if you see this array 1 dot shape and array 2 dot shape, the size and dimension is same. So addition and all those operations can happen. Let's try out the multiplication dot operation. Okay, so array 1 dot operation, array 2. Let's try it out. It is showing that the compatibility issue, because array 2 should have the same number of columns as we have in array 1. Okay, array 1 rows. Okay, so the number of rows for array 2 and number of columns of array 1 should be same. So dimension is not matching, because here we have 3 and here we have 2. So 3 is not equal to 2. So this is the error it is throwing. So we will do what? We will first of all create a array 2, or we will reshape the array 2 with 3, 2. So for that let us do it. So this is my array 2, this is my original array 2, this is my second array 1, and I will reshape my array 2. So here I will reshape my array 1. So array 2 is equal to array 2 dot reshape. Now originally the shape of my array 2 is 2, 3. I have to make it as 3, 2. So if I do it now, the new shape of array 2 is 3, 2. And now if I do the multiplication, it will allow and do the multiplication. If you see this array 2 and array 1 structure, to understand it better, if you see the structure of array 2 and array 1, array 1 the shape is 2, 3, array 2 the shape is 3, 2. Let's see what is array 2 and array 1. This is array 1, and below it I will just add array 2. So you can see the structure of array 2 and array 1. So this is array 2, array 1. I'll just remove it. And let's try to understand in detail about array 1 and array 2 ka multiplication with dot product. Now if you see this, 2, 4, 1 are the values as row, Okay, there are 2 rows and 3 columns, and here we have 3 rows and 2 columns. So this multiplication is possible, and we are going to get, as it is 2 by 3 and this is 3 by 2, so our end output will be 2 by 2. So that is why the end output we are getting is 2 by 2. Now let's understand the calculation which has happened. So this element is multiplied with this element. So 2 into 20, which is 40, plus 4 into 10, which is again 40, plus 1 into 20, which is 20 again, which is 100. So 100 is the first row which we are getting. So we are getting 100 as a value. Secondly, I am multiplying this with this and I will get 250. Let's verify it. 2 into 40, which is going to be 80, 4 into 30, which is 120, and plus 1 into 50, which is 50. So the total value that we are getting is 250. 250 is the total set of values we are getting. The 250 is the value we are getting. So this is how the calculation of this array happens, and this is how we can get a certain output. Similarly, if I multiply, let's do the verification for all of it. So if I multiply 3 by 2 by this particular value, let's see, 3 into 20 we are getting 60, plus 2 into 10 I am getting 20, plus 5 into 20 I am getting 100. So if you see, 60 plus 20 plus 100, which is 180, and similarly we are getting the last value as well, multiplying this row with this column. So this is a typical mathematical multiplication, dot multiplication, matrix multiplication we can say, using NumPy arrays dot method. Now we will talk about arithmetic functions, some important ones, aggregators, that is minimum and maximum. So these are very interesting actually, which helps us a lot when we are doing some kind of calculation, some charts we want to create, we want to present information in front of anyone. So these are min and max. Min and max you can find it in most of the data structures, like you can find it in Pandas, you can find it in NumPy, you can find it in the Python based version as well. We have this provision of getting min and max. So very essential. NumPy also provides it. It has its own version. Then we have .var and std. These are ways of arranging the data called as variance and standard deviation. We'll try to understand what is variance and standard deviation in detail, and we'll try to discuss these two first. We'll talk about min max and then variance and standard deviation in detail. So first of all, let's come over here. And let's talk about array 1. Okay, array 1 is my array, and if I use dot and if I try max, mean and min, if I use min, it will give me minimum of array 1. Okay, so the minimum value of array 1 is 1. Let's verify, it is 1. Okay, so array 1 dot min, it is giving 1. If I talk about array 1 dot max, it is going to give me max value. So max value is going to be 8 out of this array. It can be any array. If I am using array 16 or 14, if you remember, this is array 15. I'll remember we have a long array 16, 15. Yeah, this is my array 15. And in this long array also, if I want array 15 ka minimum value and then array 15 ka maximum value, then also it is possible. I don't have to go through each and every values. It will directly return that values, array like minimum and maximum values of this arrays. So that is the best part of array, array minimum and maximum values of an array. Now we'll try to understand with respect to array 1. This is my array 1. This is my array 1 and these are certain values. We'll try to understand variance and standard deviation of a data first of all. and then we'll try to calculate it using NumPy array. Okay, so what is variance and standard deviation? So first of all, I will calculate the average of this data. Okay, what is average? Average is when I add all these values and divided by total number of values. So if I add it, 4 plus 1 5, 5 plus 2 7, 7 plus 5 12, 12 plus 8 is 12 plus 8 is 20, and 20 divided by 2 it's just 22. So if you want to verify it, then you can take sum also, array 1 dot sum. Okay, I think we have 22, and we divided by a number of items. So we have the length of array 1, or we can also use size here, but I'll use length. So length of array 1, which is coming out to be 3.66. Now what we will do is I will store this value as average. Okay, this is my average data, average. Although I have function of calculating average, but I want you to understand how this calculation actually internally works out. The formula part, this is our average value. Now we are going to talk about variance. Variance basically tells us how far my each and every observation or each and every value is from the mean position. It is a measure of spread of data to understand how well or how spread this data is from the mean value. So so first of all, I'll subtract my array 1 with the mean value or average. Okay, so if I subtract my average mean array 1 with average, these are the values that I'm getting. So these are my, I'll call it as residuals, or I'll call it as difference. Okay, this is my residual values. Now what I will do is I will take square of this value. So if I talk about squaring these values, so squaring is to remove this negativity as well as increasing the order of this data. And when I take square, so I'll call it as square of data. So this is my square of data. So these are the squares, and now of these squares I will take sum of this square. So you know that what is the function to use sum. So square dot sum. Okay, square dot sum I need to calculate, which is 33.33, and I want to calculate variance. So variance is equal to square of sum divided by length of square. Okay, whatever is the square. So length is 6. So variance is coming out to be 5.55. So what is the variance? Variance tells me on an average how far the data is spread on a squared basis. Okay, how far is this data, or what is the sum of squares, or what is the average squares of data from the mean position or the mean value. So I am getting 5.55 as my variance. If you want to verify it, let's verify it with the help of say I am taking my array. I have calculated the variance of my array using this method. Now I will use array 1 dot variance. So we have var method, and if I do it using var method, it is giving me the same exact value. So variance basically tells us how far is the data, or what is the squared distances, what is the average square distances from each data point, what is the average square distances of spread from that data. Now this is our variance. When I talk about standard deviation now, so standard deviation is the square root of variance. So I will call it standard deviation of this data. So for standard deviation, I'll use standard deviation function, and standard deviation is the square root of variance. So I can use square root function np dot let's see if we have np dot square root. I want square root of my variance value. So this is my variance value that I have calculated. So square root of variance is my standard deviation, and if I put it, so standard deviation is 2.35. I will tell you what is the physical meaning of this data also. So 2.35 is my data, and this is my standard deviation of the data. If you want to verify it, you can verify it directly. We can calculate array 1 dot if I put std like this, it will give me the same value, 2.3507. So standard deviation and variance are very key important features to understand the spread and distribution of data among itself. And what does this indicate actually? If I talk about my array 1, so if I talk about array 1, So if this is my array 1, so how far each data is away from the central tendency or the mean value. So mean value was coming out to be, if you remember the mean value or average value. So average value is 3.66. So each data point from this average, how well or what is the average difference of these data points. So the average differences of each. So the average distance from each point, okay, the difference or the spread of data from each point is 2.35 from for this array. So if we talk about standard deviation, it indicates what is the spread of data from each point, what is the average spread of data considering a normal figure, a figure which can indicate the average spread of data from the average value or the mean value. So this is our minimum, maximum, variance and standard deviation part. Now we will talk about some other additional function. We have discussed one such function, that is square root. Now we will talk about square function, power function, why we are using it. Okay, we'll use it, square function, power function. We'll also talk about transpose function in array. So we will do the transpose as well. And there are some more functions such as concatenates. We will discuss it later. First we will talk about square, power, transpose, and we'll see if there are any other transposition of data. So array 15 I will take, or array 1 let us take, or array 16, let me take array 16. This is my array 16. We'll talk about transpose first. So array 16, you can see the data is arranged where I am getting the first row of my data basically represents name. So ideally it should not be the case, because when we are representing the data, when we are trying to represent the data, so names should come in a single row, and then I should have age, and then I should have say what is this, salary or wages, whatever it is. So this is how the structure of data should be all the time, but it is not happening because this is not a readable version of data. So we can do it with the help of a transpose function. Transpose function basically helps me out to understand the data in a more efficient way. Clearly I can indicate what does this each value indicate or relate to. So we'll use array 16 dot, if you remember transpose, we can use transpose, and we'll just run it, and you can see the data is transformed into a transposed version. Now what does this transposed version actually do? It has just shifted the rows to columns and columns to row. We are getting Sam, Vin and Carl as the row values, and 20, 12 and 23 as like all these different set of values we are going to get. So transpose is used to transpose the data into multiple versions, or do the shift of data as the rows, or whatever is the rows, it will become columns, all the rows will become columns. So that is what in the transpose function. Now we'll talk about some additional function as we discussed. So I'm using array, let me take array 2 or array 5 or something. This is my array 5. I'll take 6, no, I'll take 10. 15, 14. Okay, array 14, I'll take array 14. We have created a lot of arrays like 16, 15, 16 arrays we have created. I'll take array 15, 14. Now on array 14, we can use squared operation like np dot squared. I can use np dot square, and I can pass in my array 14 into it directly, and it will give me square of values, whatever values are there. I'll get the square of values. So 1 will become 1, 5 will become 25, 7 will become 41, 49, and likewise different values will get different, it will get squared actually. This is a squared function. You also have square root, which we have just now used. So we can use sqrt, which we have used. So this will give me the square root of values. Then we have np dot power function. So power function will give me power of values. So here we need to understand first what is the power that I want to raise to. So let us take, if I take power 2, it will give me square values. If I put power 3, it will give me cube values. Okay, so 1 ka cube is 1 only, 5, the cube of 5 is 125, the cube of 7 is 343, cube of 1 is 1. So we are getting this values, power, square and all, to get power of values or square of number. So basically these are some additional functions in Python. You may find more functions in NumPy based on your requirement. So it depends on what kind of calculation we are doing. So these are some of the basic ones that we have discussed. Now we have also discussed transpose. Now we will discuss about concatenating a one-dimensional array. Now this is a very important part, concatenation of array. Now when we are working in real world data, at that time we do not have like all the time we will not have the same flow of data, or maybe we want to attach the data in a way that sometimes I want to attach row wise data, sometimes I want to attach column wise data, and these operations are very oftenly done in, like even in data science, machine learning, all these places these operations are continuously used. So we need to understand different operations such as concatenate first. So let's concatenate. Let me take ARR1 which is one dimensional array. So I'll reshape, and RS1 I will call it because it is reshape. So ARR1 dot reshape, okay, and I'm just putting say 6 values are there, 6 comma, so it will create, and then this is my RS1 which is a one dimensional array, and I will create RS2 which will be again two dimensional array. Okay, RS2 again it has 6 elements. So these are the two arrays that we are having, array 1 and array 2, RS1 and RS2. From array 1 and array 2, I have just used the old arrays and I have reshaped it. Okay, so let us understand the concatenation part of an array. What is an concatenation? Now if you see this concatenation, so concatenation is to add two arrays together. So let us talk about np.concatenate function in detail. Now what is this concatenate function? Concatenate function is used to concatenate different arrays. You have to pass in these arrays as sequence of elements in a kind of parenthesis or something, and axis you have to specify at 0 and casting is equal to same kind, which means whatever is the type of data you will use the same kind of casting of data, type casting. So we will talk about different concatenation methods. We also see that there are a lot of different functions such as split, hsplit, vsplit, dsplit, stack, hstack, vstack, dstack. All different kind of optional methods are there. You can definitely explore it. So we are going to concatenate two methods, that is rs1 and rs2. I am concatenating two arrays, rs1 and rs2. So if I do it, you can see 2, 4, 1, 3, 2, 5, this is the first array, and these are the same value that I am getting here. After that I am getting 20, 40, 10 and all those values, and the array size is increasing. So this is the first way of concatenating an array. I have added two arrays one over each other, and if you don't specify the axis, so axis is equal to by default 0. Even if you do not specify, it will concatenate and give you the same output. Now let me try it with axis equal to 1, which means I want to do column wise concatenation, which means I want to add array 1 array 2 below my array 1. So if this is my array 1 and this is my array 2, I want to first put this value, and below it I want to put this value. So let us concatenate. So np.concatenate axis equal to 1. So axis is 1 is out of bounds for array of dimension 1, because array of dimension 1 has only rows, it doesn't have columns, so it is not allowing me to concatenate column wise. So I will rechange the axis by 6:1 and 6:1. So now this has become an array like this, this has become an array like this. Now if I want to concatenate these two arrays, okay, now if I concatenate axis wise, so this is my axis equal to 0, so it is just extending my array. And now if I concatenate with axis equal to 1, so this is the method by which it is extending the number of columns. So if this is my original array 1, this is my original array 2, so array 1 and array 2 are concatenated like this. So first set of columns, second set of columns. So this is x is equal to 1. If I do x is equal to 0, all it is doing is it is just adding one more set of arrays below it, like it is extending my original array. So this is the method of doing concatenation of an array. So we have to be very much clear how we have to add. If I am putting access, if I have already structure of data like this, these are the two arrays. So if I am putting x is equal to 0, so the second array will go below here, okay, the first array. So this is my first array and the second arrow will get concatenated here, okay, if x is equal to 0. If x is equal to 1, if the x is equal to 1, so this is my first 0 array and this is my first array. So the column wise it is going to get added, okay. The column is going to get added when the x is equal to 1 is specified. So we have seen both the methods of concatenation using x is equal to 0 and x is equal to 1. Here also we have done the same thing. We have an array of data scientists and consultants and we are doing concatenation. So if you do the concatenation of this array np.concatenate, you specify the name of it. You can see this is the 0 axis concatenation which is happening here, one below the other. We are just adding all the values, but if you do x is equal to 1, it is not going to allow, because sometimes if you do not specify also directly it takes x is equal to 1, it will add the values accordingly. By default it is going to take x is equal to 0. Here it is throwing error. Why? Because if you see array, we are adding an NP array with 23,45 as the size, and here we have array with size, the shape of array is different, like 2D array, this is also a 2D array, this is also this is a 1D array and this is a 2D array, and we are trying to concatenate a 1D array with 2D array with different size also. The size is also not same, so it is difficult, it cannot concatenate because the size is different and the proportionate representation of data is also not adequate. So it will throw an error if in case we are kind of concatenating arrays like this. Now we will talk about flattening an array. So this is a very important function when it comes to if you are building a complex deep learning model or something. So flattening an array is also an essential part of creating an array. It is like it is creating single dimensional array only. So if you see, if you have this array 1 array which is here, which is a 2-dimensional array with first dimension 1 3 5 7 and second dimension having, or second row having 2 4 6 8. So if you see this original array, this is the original version of array, but if you use the flattened array, so this is the flattened version of array. Flattened version of array will do what? It will just add up or it will just change the dimension of data to one dimension data. So that is a flattened array, and it is very essential. We use it most of the time in our deep learning because deep learning accepts one dimensional array only. So we'll discuss about flattened array. We have discussed about reshaping of array. Reshaping of an array, already we have discussed how we can reshape an array, and we will discuss about the S stack and V stack in detail. First we will discuss about the flattening part, understanding what is the level of flattening. So I will take array say 15 or something. This is our 15 array. Now if you talk about the shape of this array, the shape of the array is very complex. 4 4 3 2 is the shape of the array, and now as this is a complex array, so we will use np dot. So we do not see np dot flatten over here, so we will do what? Np dot, or we will do what? Array 15 dot flatten. Array 15 dot flatten, if we are using it, and you can see earlier the shape of the array was 4 4 3 2, and flattened array, if you see, the flattened array is not going to have the same shape. It is going to have Okay, the shape of flattened array is 96 comma, which means it is a single dimension array. Now array 15, earlier it was a very high dimensional data, now we have converted using flatten in a single dimensional data as a vector. So this is the possibility of creating an array of different shape. Now we will talk about reshaping. We have already discussed reshaping. Reshaping is used to change the shape of an array. How to change the shape of an array and increase or decrease the dimension, add more dimensionality to your array. So we have discussed it already. The array 15 is an output of the same possible approach that we have done. Now we will talk about H-stack and V-stack methods. H-stack which is horizontal stacking of data, and V-stack is the vertical stacking of data, which means if you use the concatenate is equal to 0, you are doing vertical stacking. If you are using concatenate is equal to 1, you are using horizontal stacking, which means if you want to increase the number of rows below your data, you are doing vertical stacking. So it is very simple. You can take two arrays with certain set of values, and if you used V stack, it will stack one over the other two arrays. So let me take two array rs1 and rs2. This is our rs1. I will take rs2 as the two array, and if I use np dot h stack, if you see that v stack, so np dot v stack, I am mentioning rs1 comma rs2, so I have to specify this into square brackets. What is happening is it is just stacking one below the other. If this is my first set of values in first array, so below this array it will just add the new values, which is 20, 40 and all these values are getting added one below the other. So this is rs1 and rs2 as the values in sp v stack and h stack. Now we will talk about arrays. Now we will talk about arrays in rs. We will talk about v stack. V stack is similar to np.concatenate. If you remember, np.concatenate x is equal to 0. It is giving the same values. If you see this, np.vstack and concatenate will give you the same set of values that you are going to get. It is a kind of it is similar to concatenate only, but concatenate sometimes becomes confusing what to put, 0 or 1. So people prefer v stack over it. Similar to v stack, we have h stack. So h stack will do what? I do not have to mention x is equal to 0, 1 here. I directly, if I run it, I will get concatenation done in an column wise manner. So which means to my existing set of values, I will get a new column basically. This basically helps us out to get a new set of columns. Like if I want to add column wise, I will use h stack, and if I want to use row wise, if I want to stack row wise, I can use v stack. So these are the two things similar to what we have discussed in concatenate function. And now we will start discussion about iterating through arrays. So we can use for loops over iterating in any array. So you can use for loops. It is very simple. You can use for loop to iterate over an array, but we have to understand what we are iterating through. If you are using single for loop, it will iterate. If it is a two-dimensional array, a single for loop will iterate over the external elements or the list, and it will not give you the detail about your internal array. If you are using two for loops, it will iterate over the internal elements as well. So let us try to understand it with the help of, okay, we can see here. So we'll try to compare the two approaches as well. So first of all, let's try to let me create an, or let me show you an ARR1. This is my ARR1 or array 15. Let me take array 15. This is our array 15. I'll reshape it. So it was 96. So I'll take 16,6. Let me take 16,6. Let's see. Okay, and I will put array reshape array I'm just giving some random names, array modified. Um, Now let's see this array modified. This is our array modified. Now you can use for loop to iterate over an array. So I can use for loop. So for I in ARR modified. I'll give a shorter name actually. I'll give ARR. I'll just put ARR. Okay. So for I in ARR, if I put and if I print I, so you can see that it will just give me all the values. Okay, all the values one by one, first array, then second array, and so on. So it will give me one by one array. If you want to see how it works, so for every iteration I will just pass 0 0 0 something like that to give some spacing. So first array, sub array, first sub array is this, and then this is the second sub array, this is the third sub array, fourth sub array, and so on. As I said, if it is a two-dimensional array, if you use a single for loop, this is how you will get the things iterated. Okay. Now if you talk about two-dimensional array, and if you want to iterate through all the values also, okay, not just one value, you want to iterate through all the values also. So in that case, what you have to use is, you have to use for j. I'm just creating a new loop out here. So for j in I, and we will print j here. Okay, so let's try to do it. Okay, so see what happens. First it will print all the elements in j. It will take the jth or the first row. So for the first row, all the element it will print. For first I, this I represents the first row. For the first row, it is going to print all the values. So j represents all the values one by one. So all the j's are getting printed, and then it will print star or 0 or whatever pattern just I'm trying to show you. Star is just to isolate things out. Okay, so after that printing is done, then it will print the second row, and then it will keep on printing third row. So iterating over these arrays is a bit easy using for loop also, but yeah, sometimes people get confused with for loop, so they don't prefer it. So you can extract all set of values using loops also. You can use loops. Okay, now we'll understand about this array and how NumPy arrays are faster than using list. Okay, I wanted to compare this very desperately, the comparison between the array list as well as array NumPy arrays. So first we will import NumPy, we will import time, we will seize the size as something of arrays, and we'll take first list. First we will create a list, and we'll do what, we will create a resultant list which is a into b for a comma b in zip numList1 numList2, and here what we are doing is we are creating a two-dimensional list actually. And to create this two-dimensional list, we will initialize time.taken, like we will initialize the initial time, and we will initialize the final time, and we will print the distance or the difference between the time taken to create this list. Okay, which is coming to be 0.249 seconds for the first part, and secondly we will do it for the array operation as well, and we will see what kind of comparison we are getting. So I will just mimic the same thing in my Jupyter notebook to understand it better. So for what I will do is I will import, right now I don't need NumPy here, so I will just simply do it without NumPy. So let us create a list of range. Okay, I'm creating a bigger list. L1 is equal to, and I'm creating L2 is equal to list range. Okay, that's what we want. We want two lists of a certain size, and I'll import time. I'm not running it. If I run it, it will create a sachet of something. So I'll import time, and I have imported list. And what I want here is I want initializing time Okay, so right now I'll take initialize time. So initial is equal to time dot time. This will store the current time, and below it I will specify the resultant zip file. So what I will do is resultant is equal to square bracket square bracket, it is a multiplication of p comma q for p comma q in zipped version of L1 and L2. So this is my L1 list, L2 list. Okay, and I will also take the out time. So resultant is for a comma b, p comma q in a zip something something. I'm zipping these two lists and multiplying each and every element, and I will take the differences between the time. So I will take time difference is equal to time dot time minus init. Okay, and I will print time difference. So let's try to run it. This will create a list of values from range something something and see how much time it is taking. Meanwhile, we will do an operation over the same thing. We'll create a NumPy array of the same size. Okay, it has taken 8.03 seconds, and I will create a NumPy array of the same size a1 a2 is equal to np dot a range. I'll use the, because list function is also going to create a list of 0 to whatever number I have specified, and this also going to do the same thing. So same operation I am doing it, I will get possibly the same output also, and I will use the same thing. Instead of that, instead of using this approach, what I will do is I will use the NumPy multiplication part. So I am taking initialize time as it is, and I will take NumPy a1 into a2. Okay, and I'll do the operation and I'll store it in resultant 2. Okay, what basically is happening is I'm just creating a normal list of values from 0 to whatever value I have specified minus 1, n minus 1. In both the cases, two arrays I am creating, n minus 1, and I am multiplying the element wise multiplication for each and every element in this array by the normal method, and here I am doing with the array method. This is a direct array multiplication, this is a normal multiplication. So that's what we are doing, and we will try to print out what is the time lag between each of these two. So if I run it, let's see what is the difference between the time. Here it has taken 8.03 seconds, but when I am using NumPy, it is taking 5.24 seconds. So NumPy arrays are always faster than the list method. So here we have used list actually to do the processing of data, but here we are using NumPy matrix multiplication. So there is a difference when we use list and when we use array. So arrays are comparatively faster than the Python list. So we have seen NumPy as an additional library which can help us to work on two-dimensional data sets, one-dimensional data sets. Now we will talk about one more additional package or library which helps us to work on data more efficiently, and also it helps us to clean the data more efficiently. So the library that we are going to talk about is Pandas. So Pandas is a library which is an additional library which helps us to work on data set, two-dimensional data set, one-dimensional data set. It has more functionality and it gives us very much easier way of handling data files, handling different versions of data. So let's try to understand Pandas. So in this session, we will be learning about what is Pandas first. We will learn about series, how to create Pandas series, access series elements, filter a Pandas series, what are different arithmetic operations, how we can rank a series and sorting the data, checking null values and concatenation of a series. So let us begin with it. So as I told, Pandas is an additional library to handle data which is 2-dimensional or 1-dimensional, and it helps us to do the data cleaning in a more efficient and very easier way. So Pandas, as we discussed, is an open source library in Python. So it is an open source library. We do not have to pay much for using Pandas. It is used in data manipulation and analysis of data, and it is very much fast compared to, like, it is fast, flexible and expressive data structure designed to make working with structured tabular data in a very efficient way. So we can handle different data, Pandas data, which is in a more structured way. The information is arranged. We can handle heterogeneous form of data. We can handle data which can have multiple values into it. So lot of different data manipulation can be done easily using Pandas, and it is also well suited for time series data analysis. So as Pandas helps us to handle the data well. The use case of Pandas is very wide. It is used in statistics for computation of mathematical algorithm, data analysis, sampling of data. It is used in natural language processing to process the vast amount of data into machine readable language. It is also used in recommendation engine. It can be used as a source for big data. It is used in stock prediction, analytical, creating analytical dashboard. It is also used most widely in data science, as it handles data more efficiently compared to most of the other libraries, if you can see. So Pandas library is built on top of NumPy library, okay, because it provides high performance, easy to use data structure and data analysis tool for the Python programming language. So as I told you, if you want to start with anything in data analysis or something, you have to start with NumPy. NumPy serves as a foundation for most of the complex data handling libraries, such as we can see right now here in Pandas as well. It is used, also it is used as a base data source for different mathematical algorithms. So it is actually built on top of NumPy. Pandas is actually built on top of NumPy to provide highly efficient and performance enhancing data manipulation. So let us compare Pandas and NumPy. So Pandas, it provides some powerful objects like data frames and series, but NumPy on the other hand, it provides us with a very powerful object known as array. The problem with an array is we cannot identify what information is there in a particular sequence of data, but in Pandas we can easily do it in a Pandas data frame, because we are already aware what kind of column name it actually holds. Pandas is more streamlined handling of tabular data structure and rich time series functionality. So it is enriched with time series functionality. It is the special part is it is streamlined. It is very streamlined in organizing data tabularly and structured way. It is handled, and it is very much compatible for time series. It supports fast mathematical, like NumPy actually supports mathematical, all the mathematical and numerical calculation computation part. In Python can be done well in NumPy. So it is very fast NumPy. Pandas is easy to handle, like it can be simply handled by simple indexing. The approach of using it is very simple. There are a lot of different functionalities like missing data, cleaning, how you can clean missing data, how you can align data, group by, merge and join methods. A wide range of mathematical array operations can be done using NumPy. Algebraic calculation can be done on NumPy. all different matrix transformations can be done on NumPy. So that is the difference in Pandas and NumPy. Now we'll begin with understanding how to start with Pandas. So as I told you, if you are working on Jupyter Notebook or Anaconda Studio, so if you're using Anaconda Studio or Jupyter Notebook, you don't have to install Pandas because by default it is installed. But if you are using Pandas over some other tool, like for example, if you are using on VS Code, okay, so directly if you try to access Pandas, if you directly try to import Pandas, it will not work because it needs to be installed along with your Python base package. So it will not allow you to work on it. But when you are working on Jupyter Notebook Colab, it is actually fine. It is pre-installed kind of it. But when we talk about using it on a newer kind of software, you use the install command, that is pip install pandas. That will install your pandas in your system or your console area. You can use it whenever you want by calling out the import command. So you can use import pandas as pd. If you remember, in NumPy we have used NumPy as NP. So similar way, Pandas can be used as PD. Whatever name alias you want to give, you can give it. So here by default, even the developers of Pandas, they are also using Pandas as PD only. Now we will talk about different components of Pandas data frame or Pandas library. So there are two ways of handling data. First is one-dimensional Pandas data, and then we have multi-dimensional Pandas data. So if it is one-dimensional, we have series, and if it is multi-dimensional, we have data frame and panel data. Now let's talk about Pandas series. So when we talk about NumPy, if it is a single dimensional data, we call it as a NumPy array, single dimensional, one dimensional NumPy array or something. But when we talk about series, okay, series is a different data structure. It is not like when we talk about NumPy array, you can create NumPy array using a single array function np.array, or you can use any function and you can reshape your data to get a single dimensional NumPy array. So it was of the ND array type only. The type of the data is also ND array. But here in Pandas, we have a specific data structure called as series. If you want to store data only in single dimension in a vector form, you have to use series only. Now a Pandas series is a one-dimensional data array of indexed data. So the series actually should have data into it. You have to specify the index if you want, and the data type of the data, and to copy the data you can use copy. So if you want to literally try to understand what is a series, so series can be considered as a single column into your Pandas. Like if you are referring to an Excel file, so Pandas series can be a single column from a Pandas or an Excel file. Now we will understand about how to create Pandas series. So creating Pandas series is a very important part because it is not similar to the way we have done. We have 10, 20 methods, 15 methods to create a NumPy array. We did it, but here we have a single approach. We can create it using a Python list or any iterable that we have, or we can any iterable value or data structure. If you remember the derived data structure or the collection data structure, you can use it for creating a series. But you can also create a series using NumPy array, but you cannot use some multiple other methods to do it. So as discussed, NumPy is going to be the base method to help you out with numbers and handling the data, and you can use both the method using a Python list, and you can also use it creating a NumPy array. So let's try to understand how to create a Pandas series over Jupyter Notebook. So this is our Jupyter Notebook on which we are going to write our code. This is our Pandas Jupyter Notebook, and first of all let's import. So first of all let's start the installation. Pip Now, as I discussed earlier also, this exclamation marks drags everything that I run over here over my terminal. So it will run in my command prompt, it will not run in my Jupyter notebook. So this exclamation marks skips this line of code and puts it on the terminal or your command prompt. So when I run it, so it is saying that a requirement already satisfied, and it is giving a warning error parsing dependencies of text rack. So that is an warning basically. So we have already installed, so I have already installed. So if you are using Anaconda's this requirements or this requirement already satisfied message and warning will be given to you directly, so you don't have to bother much about it. We will talk about how to start working on it. So in order to start working on it, we can use import pandas as PD, and if I do it, the pandas module will get imported now. Now compared to NumPy, pandas is a little bit heavy to process the data, because NumPy uses core matrix transformation. NumPy uses core matrix transformation, or core NumPy is a very core version of data. It is even lighter than your list, but pandas uses NumPy, and there are some additional aesthetic elements added into pandas as well. So that is the reason sometimes you may find that pandas is going a bit slow, but it is more powerful. Even if it is slow, it has more power to handle large volume of data. So now let's talk about creating pandas series first. So for that, what we will do, we will create a series S1, okay, and this series we will create by using pd.series function. So you have to make sure that S is capital while creating this function or using this series function. And the first method, as I told, that it is by using a list. Okay, I am just creating a series. Okay, let's run it, and S1 is my series. If you want to see the series, it looks like this. This is our series S1, and now we can definitely use this series for handling the data. You can use the information into it. Okay, now there are two parts which are viewed here, which are visible here. The first part is, as you can see, 0 1 2 3 4 5. These are index of numbers. So these are indexes basically, and the second part is values. So there are two parts, index as well as values in a series, pandas series. Now we will talk about the second method of creating a series, and that is by NumPy array. So it is the same approach, only difference is whatever I have inserted inside it, I have to just remove it, and I can just simply call np dot, I'm just creating random numbers, random dot random. Okay, I'm just creating random numbers between 20 to say 45, 10 numbers I'm trying to create, and I'll call the series as S2. I'll call this series as S2, and now it is throwing an error, NP is not defined. So why it is throwing an error? Because I have not yet called the NumPy. So I will also call NumPy, import NumPy as NP. If I run it, so you can see it is allowing me now. No error is here, like we cannot see any error because NumPy have already called in. So you make sure if you are using NumPy, you have to call it, like you have to bring that library here. Okay, so this is my series which has 10 numbers into it, and these numbers are ranging from 20 to 45. All these different numbers are present here. So these are the two methods by which you can create a NumPy pandas series, one with the method of list and the second with the method of array. Now we can also set specific numeric values as index while creating a series. So as we have created a series by our own set of numbers, and you don't like the series that is, or the indexes which is assigned to it, so you can use your own set of indexes that you want, and you can use NumPy also for creating this indexes. Now what is this indexes? This indexes, if you see, this 0 1 2 3, these are index values. Okay, now there are 17 data points over here, so you can create 17 indexes. So let us recreate S1. I will just recreate S1 here with index values. Okay, so what I will do is I will just create indexes first. So indexes, and I want to give indexes from, I want to create indexes from 1001 to 1017. Okay, I want to create 17 values, 1001 to 1018 I'll take. So indexes basically, I'll do one thing, I'll remove it, okay, Control Z, I'll do one thing, I'll take it, I'll paste it here. Let's see what is this indexes. Indexes are numbers from 1 to, okay, it has created only one number. So np.a range, it is, I have to specify start and stop step. So I will just specify start and stop. So I have created numbers from 1001 to 1017. So I can use this index in my NumPy array also. So I can call index function here. If you want to see how to create index function, you can see index is equal to indexes. Now I can pass in the same indexes over here, and it will so it will just if you see the previous version of S1, it had number 0, 1, 2, 3 as indexes, but now if I run this, I will have different indexes because I have already redefined my indexes from 1000 to 1017. So this is one approach to create a very neat and clean version of data in using Pandas series. You can also specify a particular series as alphabetical value. You can specify it in Pandas. So to do it, what we will do is we will definitely create a S2 which is having different series. This is our S2. So S2 requires has series 0 to 9 suppose. So what I will do is I will change, I will create reindexes. I will create indexes new, okay, for S2. So for S2 the indexes that I want to give is I will create my own customized way of indexes. So A and then B, and then I can give C, I'll give D, E, F, G, H, I. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I need one more value. So now S2 has index 0 to 9, which means it has 10 values basically. So indexes, now I will change the index to the indexes that we have just developed. So this is the indexes that we have just developed, and if I run this S2, now S2 the indexes is from A to G. So this is also one method of creating indexes. You can have your either numeric indexes as we have done here, or you can have your categorical or alphabetical numbers as indexes. Sometimes we require alphabetical values to be indexed, so that also is possible using Pandas indexing method. So we can also create a series by help of a dictionary data structure. So we have seen it with the help of list, we have seen it with the help of NumPy array. Now we will discuss about creating a series using dictionary data structure. So let's understand what is a dictionary first of all. What kind of dictionary we require it here. So the dictionary that we require is it should have one key and one value. So the key basically can go as an index, and value basically goes as a value in that series. So I have created a series, or I have created a dictionary like this, and you can see I have given some random values. So these are my series, and we can do what? We can simply use pd dot series, and inside it I can pass d1, and you can see a series can be created like this as well by using the alphabetic. I'll call this series as s3 is equal to, so this is a series by using dictionary. So dictionary also can be utilized, and only thing that we have to consider is that this series should have one key and the value. Now we will see how we can access a series element. So if you want to access a series element, consider a series here given as emp array with certain values. Now this series has values a101, 102 and so on, and this series has certain numbers. Okay, so these numbers basically represents indexes of the series, and if you want to add this series, or if you want to extract certain values in a series, we can use the square bracket indexing, and within that we can use the way we have indexing in Python list. The same method we can use to index a particular element in a series. We can also see a negative series indexing. So if you want to do negative indexing, you can use the same method. We can like for the same series, you can use -5 s2 in the square bracket itself, and it will give you the negative index value, or which means the last 5 values for this series. And we can also use access series elements using this dictionary. Suppose if we have created a dictionary, and the indexes are basically not numbers, or say if it is an alphabet, so then also we can definitely use the same approach, like we can use square bracket, and inside it I can specify which particular index I am talking about. So it will give me the same set of values whenever I am trying to use it. So we will try to use this particular approach of doing it. We can also using series we can also get multiple values for our data. So that also we will try to see in Jupyter Notebook. So let's consider our series S1 with certain values. Say I want to extract a individual element. So if I want only, suppose the element at index 10, so I can simply put the index value over here, and it will give me that value. So the value at index 10 is 12. So it is simply like we have used our normal method. Say if I want the first 5 values from the series, so if I use S1, so this is the method to get only one value. This is suppose my series S1, and I want only the first 5 values, so I can put S1 square bracket is to 5. It will give me the first 5 values. What if I want the last 5 values? So I can use S1 say -5 is 2, and this will give me the last 5 entries of this series. So these are the methods of indexing elements of series. So we can extract information from series like this. The sub part of series, we can call it as indexing or slicing. I'll take series S2 where the data is in a different way, where we do not have a numeric representation. Say if I want the first element, I have to specify A, and then only I can get this element. If you want to index it using square bracket 0, it is still able to give me, but the only thing is 0 is a numeric representation. A basically stands out for the exact value if you want to search. If you want to search what is the value of E, you don't know what is the index position of E, that also is fine. You just have to specify the value of that in the index value of that particular element in square bracket, and it will tell you what is the value of that particular element. If you want multiple things together, so you can use say F, suppose E, and say B if you want. So then also you can see it is throwing error because it is using multiple index, and we can do what? We can use square bracket. Let's see, if I mention 2 square brackets, it is telling me okay, E is 41 and B is 44. If you want to verify it, we can verify it like this, and that is also quite possible in Pandas series. So Pandas series has a very easy approach of indexing elements. It gives us more flexibility to index element. Let us try out if whether it is able to index values from suppose B to C. If we want B to C, Let's see if it is able to do. So it is able to give me B and C. Suppose if I mention B to G or B to F, so it is able to give me values from B to F. So that is the best part of Pandas series. If you want values from a certain range of values to certain other range of value, you can use Pandas series for it, and it will definitely give you the same outcome. So these are the methods of indexing elements of a Pandas series. Now we will discuss about filtering a data in a series, how to filter Pandas series. So the filtering process is quite easy. We can use conditional filters also to get the data based on a certain condition. So let us consider a Pandas series. I will create a new Pandas series here, S4 say. Now what I want is, I want to create a series of certain values, say I am just assigning some numbers randomly. Okay, so this is my series S4, and there are 7 values, 8 values into this series. What I will do is, I will create indexes up to 8. Now I will use np.arange, and I will create indexes from 1 to 9 say. Let's see. And now the indexes has been changed from 0 to 7, now it is 1 to 8. So this is my original series. This is my series with values 1 to 8, and these are different, this is my series with indexes 1 to 8, and these are different values into it. Now let's try to understand how we can extract information from this series, how we can filter this series based on a certain condition. Say if I want values above 400 from my series. So first of all, what I have to do is, I have to create a mask of it. I will create a mask, and in mask I will find out which all elements are greater than S4. So I will put S4 greater than say 400. And if you want to see what is this mask going to represent, this mask represent the truth value of this condition. So it will compare S4, each value of S4 with 400, and say that if it is greater than true or not, 400 or not. If it is greater than 400, it will return true, otherwise it is going to return false. So 100 is compared with 400, it is greater than 400, it is false. Again 200 is compared, 124 is compared, 432 is compared. So 432, it is an index position 4, and we are able to get that index position now as true. So wherever we see the value which is greater than 400, the index value is returned as, or the comparison output is returned as true for that particular operation or that particular series value. So we are able to get this indexes as true and false for wherever the values are greater than 400. Now I want information from S4 wherever I am getting true. So I will just use mask, and wherever mask is true, that particular value will be shown as an output, otherwise not. So if mask is true, it is going to represent that value or show me. So if I talk about S4, this is our S4, and if I run it, so 4, 5, 6 and 8, if you talk about 4, 5, 6 and 8, these are the instances only when my values are greater than 400. You can see that the values are greater than 400 here. So you can also add multiple conditions here and get more information from that mask condition. So we can use conditional filtering over here. So let's try to see one example. Let's try to see one example of multiple conditions. Say if I want to have values which are greater than 400 but less than 600. Okay, I want values which are greater than 400 but less than 800. So I will use multiple conditions. So I can use and along with my current existing condition, and then S4 greater than 400 and S4 less than, I want both the conditions to be true. So S4 should be less than 800. If both the conditions are true, Let's see which all values hold true. Right now, if you talk about the current mask that was there, which was the previous mask, I've shown all the values. Now I want all values which are only satisfying these two conditions. So if I run this, so it is returning the truth values of series is ambiguous, use a empty bool or any. So why we are getting this error? So the error basically it is because we are having one value which is greater than 400 and another value which is greater than or less than 800. So alternatively we are not able to use AND condition here. AND is a logical operator. So this AND will not work out here because I want to compare bit by bit comparison. So I will replace this and I will use this and. Now let's see. So it is able to represent. So I want to compare a bitwise comparison between this particular condition with this condition. So bitwise AND will be used here because logical AND works only on an overall condition, not on the individual conditions in an iterable data structure. So that is why this AND operator, bitwise AND operator can be helpful, and you can see that these are the values which are greater than 400 but less than 800 in this series. Okay, so if you want to filter based on condition, we can definitely use multiple condition. This is a symbol of using the AND condition. If you want OR, you have to use the bitwise OR operator. Now we will be discussing about arithmetic operations in Pandas series. Now we will talk about arithmetic operations in Pandas series. So Pandas series is basically allowing us to do different level of Pandas calculation, like series calculation. Like it can allow you to do scalar series multiplication. All you need to do is multiply the series, like whatever is the series name, multiplied by whatever scalar value you want to multiply, and it will do the scalar multiplication method. Now if you want to multiply the series, two series, you can use the dot multiply method, which will allow you to multiply the series A with series B. Then we can definitely add two series. So if you want to add two series, you can use the plus operator to add the series, and you can also use series calculation. Suppose if you want to add two series where the length of the series doesn't matches, so wherever it is not matching, it will just add it as nan. So I will do one thing, I will create a series and we will apply all this mathematical operations, arithmetic operations over it. So let us create a series A1 is equal to in pd.series, and inside the series I will create np.random.randend. I will specify values from say 10 to 40, 10 to 50, and I am specifying 20 numbers. Okay, and this is a random number, so it is fine, all of the things will be same. I am creating two series A1, and let me do one thing, I will take 10 numbers only to avoid. Okay, these are the two series basically which these are the two series which we are trying to work on. So we will do some matrix addition multiplication operation over this series. So A1 I will multiply this series say with 1000. Okay, and let's see what is the output. So A1 is a normal series with certain values 12 and all, 12, 42, 24, 17. But if I multiply it with 1000, see all the values are getting multiplied. So this is a scalar multiplication which is enabled, and which can be done with the help of your Python uh, series. Okay, now suppose a1 is there and a1 plus a2 is there. Okay, so let's see what is an output of a1 plus a2. a1 the value is 12, a2 the first value is 20, 12 plus 20 we are getting 32. So this operation is also allowed. We can do addition, we can do subtraction as well. a1 minus a2 also is possible. Yeah, we can see that a1 minus s2 I am trying to do. Why it is not giving me any value? Because S2 is a different series, it has different set of values. It is because you can see the indexes are not matching of A1 and S2. Let me show you S2 also. So S2 is a series where the indexes are not matching. So what it is trying to do is it is trying to map the series indexes first. So here in A1 and A2 the series indexes are same 0, 1, 2, 3 and 0, 1, 2, 3. But A1 and S2 the series values are indexes are different. A1 has series values from 0 to 9 and S1 S2 has series A to G. So it will try to map, or it will try to do the operation of A1 0 index with 0 index of S2, but there is no 0 index of S2, there is A index A. That is why it is throwing error, nan it is trying to throw. Instead of that I will use A2, but it will give me value if I am using A1 minus A2, because A1 has certain set of values, A2 has certain set of values, and that is why there is no problem in getting the differences. A1 and S2 A2 has the same indexes. If the indexes are same, so it will not throw me such kind of errors. So that is one thing in using the any kind of arithmetic operation in this Pandas series. So your indexes should actually match. If it is not matching, so it will throw an error. And then we will also use the multiply operation. So A1 is my series, so I want to multiply this series with A2. So let's see what value we are getting. So it is not able to series object has no attribute multiply, but we have seen here there is a method dot multiply. So MRP series dot multiply sales price. So let's see what happened here. I think it has been deprecated. So A1 is a series, A2 is a series. Okay, we'll see what is the other method. So I'll directly try to multiply A1 with A2. So direct multiplication is happening because maybe the dot multiply function is not actually being worked out here. It is not working. So then we will talk about addition of two series. We have seen how it adds two values. So as I discussed, it is able to add only if the indexes are matching. If the index are not matching, if these are two different series, so it will definitely not allow us to do the any operation. So any operation will happen only if the indexes are matching. It will match the indexes. So that is a good thing actually in series, because we do not have to manually make it follow the indexing procedure. So it can definitely help us out to remove any redundancy in data, and also check if there is inconsistency in the two data structures, which is both the series. Now we will be talking about series ranking and sorting. So ranking series. So series, say suppose I have a series and the series values I am giving certain values are there in my series. So I can rank the elements inside my series based on whatever value it is actually holding. So ranking procedure is done based on the highest value given the maximum rank or the lowest rank. Then we will discuss about sort values, how to sort certain data in series. So we will try to discuss about this in detail. So A1 is the series that we are going to consider here, and the operation that we are going to apply is using this rank. So A1 has certain values, and let's try to use the rank function over it. And if I use a1 dot rank, let's see what we are getting. This is my original a1 value, and I will run the rank over here. This is a1, and a1 dot rank, if I work on it, so it will automatically give me rank based on values. So in this series it is giving 7th value as first rank, which means the lowest value is given the first rank, and likewise rest other values are given the rank. We will try to see if there is any additional function over it. So we do not have any additional function. So rank function gives lowest value as the first rank and highest value as the maximum rank. Now we will talk about sort values. So sort values is basically helping us out to sort the data in A1. So A1 is my list, okay, or series. In the series A1, I can see there are multiple values, and I can simply use A1 dot sort, okay, underscore values, and when I use sort underscore values, it will sort the data in ascending order, as we can see. And sort values basically is used to sort in ascending value. If you want to do more operations over it, and if I have say any values also in my list, or if I have any values, so I can position it by using the na underscore position is equal to last. What happens whenever you are using sort underscore values? So in sort underscore values, you can pass in the argument like na position. You can just mention na position is equal to say last or something. If you pass it, if there is any na values, it will go on the end, okay. And there is one more thing, ascending argument. So ascending argument is used to specify if it is ascending or descending. So if you are specifying ascending is equal to true, it will be in ascending order. If you mention it in false, so it will be in descending order. So these are some of the important functions which helps us to arrange the data. So we have seen how we can sort the data in ascending or descending order. So if you want to place your na value at the top, you can put na positions is equal to first, or otherwise you can put it last if you want it at the last. So that is one such method of sorting. Now sorting is very essential because it helps us understand the data in the incremental order, which all information, what is the lowest value, what is the highest value, how the values are distributed across. So that is the reason sorting is essential, and we can sort any series by using the sort underscore values function. Now we will discuss about sorting the index as well. So sometimes it is happening like we do not see in a series with a proper index values. For example, here we will consider a series. I'll create a series A3 is equal to with pd dot series, and the series has certain values, say okay, these are the values of a series, and the index is also not correctly given. So index is equal to index randomly I will create values. I'm just giving some random indexes. Okay, I'm creating A3 with some random. I'm creating A3 with some random indexes, and you can see the values of A3 is kind of having different indexes. Now I can sort A3. So if I want to sort A3, can be sorted by using sort underscore values, considering ascending is equal to false. So if I sort it in ascending order, this is how the series is getting sorted. but the indexes are not in a proper order. We can sort based on indexes as well. So if I want to sort it based on indexes, I can use 83 dot sort underscore index, and if I run it, we can sort the data based on indexes. Now all the indexes are sorted in ascending order. Why we are using sort index? Sort index can be very much helpful if the data that we are going to talk is in sequential order, in a time series time bounded manner. So there we can use sort underscore index, and it's a very essential part to sort the data. It is very essential to sort based on indexes, because sometimes the data is in time bounded structure. So we can use sort underscore index to arrange the data in a chronological manner. Now let us discuss about checking null values in a series. And null values are values which are basically empty in data set. Null values indicate that we do not have any information on that place, and such kind of data is incomplete data, and it doesn't help much in analysis. And that is why it is necessary to understand how and what is the distribution, what is the proportion of null values in a certain set of data. So for that, what we will do is we will use the isNull function to identify null. We can also use not null function if a particular value is not null or not. And let's try it over our series. So we'll use A1 as a series, and in our A1 I will so in A1 we do not have any null values. So let's do one thing, let us create a series A1 with the same set of values. So A1, here we have created A1, or let me do one thing, I'll just create A4 or null values with null, a series which has the name with null, and in this series I will put some values randomly of my choice. pd.series, I can put values 1, 5, 2, 6, 9, 2, 5, 7. So these are certain values in our series, and I will also use null over here. So I can use np.nan none. Okay, let me use none as well. So these are different data in my series. I will run my series with null and see what all information I have into it. So you can see there are two nulls basically, which is at the end. And as I was talking about sort values, I'll talk about sorting the series with respect to null values. If I use sort underscore values, it will sort with null. Okay, it is sorting, and by default it is keeping the null values at the end. And so NA position, if I put is equal to first, so it will sort with keeping NA values at the top. So this is the one that we have discussed. So suppose we are sorting the data right now, and this is our null value. We are going to talk about how we can treat these missing values, or how we can understand the presence of missing values in my data. So with null is my data, and I want to identify how many missing values there. So for that I can use isNull method, and isNull method will tell me if there is any missing value. So wherever I see missing value, it will return true. So there are two missing value, which is at the 8th and the 9th index position. If I want to find out how many missing values are there, I can simply use dot sum as well. So it will tell me how many missing values are there. There are two missing values. What if I want to see which are these two missing values, or what is the missing value index? So I can use this as a mask. I can create a mask, because this is a mask is always in a boolean value, and I can use with null dot mask, with null square bracket mask. So if I do it, so it will give me it is at 9th, 8th index and 9th index. Similar to this, we also have a function called as not null. So not null demo we are going to do. So not null, for that I can do what, I can use the with null function, with null, and I'll just simply use dot not null, not null, not NA. Ambiguously we can use the same thing, and wherever there is no null value, all these values are getting returned here. So what I will do is I will have this not null value. I can also call it out as a mask. I want to see which all values are there which are not null. So I can use that mask over here in the square bracket, and I can find that if I'm using not null, I'm using values from 0 to 7. All these values are not null, and the value at 8 and 9 which was null, we use the is null to get only the null value, and we use not null to get non null values from a set of series. Now we will talk about concatenating a series. Now series concatenation can be done only in a single way, that is row wise concatenation. We cannot do column wise series concatenation, because column wise concatenation can happen only in NumPy array or Pandas data frame, not in series, because series is a single dimensional data structure. It cannot have multiple columns into it. That's why it is a very simple method. We use two methods, basically concat method and append method, to concatenate series. Now in the current version, append method is kind of deprecated, so you may not be able to use the append method, but concat method can be used alternatively to do concatenation of two series. So concatenate method it is to create a new series by appending a series with another series. If you want to stack one series over the other, you can use the concatenate method, and one can concatenate more than two series at a time, so using the concat method. So let's do one thing, let us create two series and let us try out doing the concatenation of these two series. So let's start with doing it. So let me take series 1. Okay, I already have this S1, I already have this S2. Okay, now S1 has 17 values and S2 has 10 values. I can simply concatenate these two series together. So how I can do it? S1, or I can use pd dot concat, and pd dot concat I can put S1 comma S2. So it requires two positional argument, one positional argument as a list, and if I do it, see, it is able to concatenate one over the other, where first it will consider S1 and then it will consider S2. So this is how we can do the concatenation of two series and store it in a new series. So I can store it in a new series as well. So S3 is a new series which stores the concatenated version of S1 and S2. Now we will talk about hierarchical indexing and labeling the data. So if you want to index the data, suppose I have a series like this, series 1 and series 2. So if I want to do hierarchical indexing of series, so I can do it with the help of keys and names. So keys basically represent even and odd, and the names that I want to give to this indexes is category and index. So let's try to understand these keys as well as names of the indexes. So for that let us create a concatenation of the series. I will do this. Okay, and keys we are going to put here as let's say we will put keys as info, or I'll call it as S1, S2, and the names of these keys is equal to, I'm going to give category and index number I'll give. Now we can create a multi-index of our series as well. So suppose this is my series S1 and S2. and for this S1 and S2 I have created two keys. So I want this to be called out using S1. So the first series to be called out as S1, second series to be called out as S2, and index number is nothing but the same index value that we have used here. So 1001 to 2017, and here A to G. So Pandas series indexing or concatenation helps us to concatenate two strings, and there are multiple options that we get with along with concatenation. That is, we can use multiple keys or multi-indexing also we can follow for adding the data. Now we will talk about the append function. Now I'll tell you this append function is actually deprecated in the current version of Pandas, so we will not use it. Although even my Pandas has this older version, so I'll show you. S1 is like this, and I'll show S2, which is holding value like this. So I can use S1 dot append. Okay, even I don't have the append function right now because it is already deprecated. I cannot append it. So series object has no attribute append because S1 series, the append function has been removed. We have already updated this. So append function is not functional right now. It has been removed. And then we will talk about ignore index part. Now what is ignore index while concatenation? Suppose there are two series S1 and S2, or A1 and A2. I will concatenate these two series, okay, using the same approach. Okay, so I am creating two keys S1, S2, and I will concatenate it. So S1 instead of this I will put A1, A2, and A1 and A2 keys I can see 0 to 9 we have values, here also 0 to 9 we have values, index number we can see, and the values also we can see. These are certain values and indexes of series. Now if you talk about S3, you can see the indexes are 0 to 9, and again I have indexes 0 to 9. What I will do is I will remove this entire argument and see what kind of concatenation is happening. I will remove it, and now if you see the indexes, it is starting from 0 to 9, and again it is starting from 0 to 9. Now we have to understand this aspect of your database handling or data handling. The problem with the current way of concatenation is it is not able to recognize, or it is not able to reindex the data. Okay, for example, if I am creating a new data structure S3, so new data structure series S3 should also have a newer set of series indexes, and if I want such kind of things to happen, so I have to do what I have to actually do manually the indexing. I can do what S3 dot index is equal to something something, that I can do. But if I want to do it on the go while concatenation itself, so I can use ignore index equal to true. So if I use ignore index equal to true, the concatenation will happen, and the original list indexes or the original series indexes which were already there will be shifted, it will be removed, and we will have a newer set of indexes here. So this newer set of indexes starts from 0 to 19, and we have already ignored the previous indexes of A1 and A2. So we do not have to bother about the old indexes now. So this ignore index argument is very crucial, because right now we are working on series, but tomorrow when we start with, because right now we are working on series, but if we start on data frame, it will be a very crucial element, because concatenating of data frame is very difficult compared to the current concatenation, because S3 or series will always have single dimension, but data frame will have multi dimension. So it will be very much complex when we will try to do the concatenation, and you might lose some data, you might get more number of observation. So data consistency is also not much followed here, so that we have to take into consideration. Now we will discuss about an important data structure in entire data handling and manipulation part. This data structure enables us to work on multiple file sources or multiple versions of data, which is in tabular structure. So here we will do data frame manipulation, which is a Pandas data frame manipulation. So basically, when we are doing handling of data, so data comes to us in very different order, different versions. So Pandas allows us to store the data in a form of data frame if it is a tabular data frame. So we'll try to talk about the tabular data structure and discuss what are different options that we can do and what are different powerful tools we can use to do the data frame manipulation part. So at the end of this session, you will be able to work on or understand what is Pandas data frame. You will learn data frame creation. You will understand how to read data and various files, understand data, access data frame element using indexing, data frame sorting and ranking, data frame concatenation, data frame joins and merge, reshaping data frames, how to create pivot table and cross tab or summarizations of data, data frame operations, checking duplicates in a data frame, dropping rows and columns, replacing different set of values from a data frame, grouping data frame, and missing value analysis and treatment. So these are certain operations which are necessary when we talk about data frame in Python. Now Pandas data frame is a very key component of data handling or data analytics, because it gives us a very powerful set of data manipulations methods, functions, and the best part is it is actually free and it can handle huge volume of data. So it is very important to actually work on data frames. So data frame, as we saw that in Pandas, first data structure that we have seen is series, which is a one-dimensional data structure. But the second dimensional data structure or two-dimensional data structure that we have in Pandas is data frame. So it is a two-dimensional data structure where the data is arranged in the form of rows and columns, and each rows basically represent an observation and each column should represent an attribute or feature. So column can be of different types. It can have different type of information into it. The size of data frame can alter, can change. Number of rows and columns are kind of labeled over here, and arithmetic operations can be performed on rows and columns in Pandas data frame. So let's try to understand how we can create a data frame in Pandas. So as we know that we are going to work on Pandas. So the first and the foremost thing that we are going to do is install Pandas. So we have already learned how to install Pandas. Second part is importing Pandas. So you can import Pandas the way we have imported in the previous series lecture. So we will try to understand how we will work on Pandas data frame. So the first method we can see is we have created a list called data signs. This list has certain values and we have directly passed this list inside pd.dataframe, and it is going to create a Pandas data frame. So let us try to understand and create similar kind of data frame using a list. So the first part that we are going to do, as we are working on data frame, and this is a Pandas data frame. So we will name the file also as Pandas data frame. Rename it and let's try to create a Pandas data frame. The first part is importing Pandas as PD. Once we import the Pandas library as PD, we will create a data frame df is equal to pd.dataframe, and I will pass a list inside it. We can create a Pandas data frame using list. So the list has certain values, Python and say pandas and say NumPy. These are three values into my data frame df, and let's have a look how does this look. So our data frame has three values: Python, pandas and NumPy, and this is used like this is how we can store a list information into a data frame. The very basic structure of data frame that we are talking about here. So 0 basically, as we saw that there was 0, 0 is basically the name of the column that we have got. Okay. So by default we have not given any name, that's why it is going to consider 0 as the name of the column. Now we will talk about creating a data frame from a list of list. Okay. What if I have list, like I have a nested list, data stored in the form of a nested list. So how I can create a data frame from a nested list? So I will show you in Jupyter Notebook. Then we will have how to create a data frame from dictionary. We'll discuss it, and we'll talk about creating a data frame with customized indexes, and we will talk about creating a data frame with list of dictionaries. If we have multiple dictionaries, how we can create a data frame with multiple dictionaries, that also we are going to see. So let's start with understanding of our pandas data frame first, using multiple nested list. So I will call df using list. Okay, df using list we are going to call. So for that what we will do is we will create df or pd dot data and I can use or pass in a nested list here in here. So I will pass a nested list with certain values. So this is my nested list, and the columns that we are going to pass here is, so I will give some name of the column. So I have two values over here, the first value and second value. Let me do one thing. I will create it without this columns argument, and I'll show you what we are going to get when we are passing two lists instead of one list. So if I'm passing two lists instead of one list, you can see it is giving me a list with 0, 1, 2 as the name of the columns, and the first list basically indicates the first row and the second list basically indicates the second row. So if I want to pass one more value, I'll pass 2, 3 only here, and let's try running it, and it is showing nan wherever I have not entered value, because I have entered inconsistent number of rows. As the data frame expected 3 columns from like each of this nested list, 3 values are expected, but we are passing only 2. That is why the third value is not there, and that is why it is going to be nan. Now as this is the case, now let us try to give the name of the columns. So columns we will give names as that. I want to give 3 columns name. I'll call it as A, I'll call it as B, and I'll call it as C. So you can see there are 3 column names now assigned to each of this column, A, B and C. So we can definitely use this method of creating list, like creating a data frame using a list. Now the second method that we are going to talk about is creating a dictionary, creating a data frame using dictionary. So the second method is using dictionary. We are going to use create a data frame. So I'll call df dict, which indicates that dictionary is used to create a data frame, and I'll call pd dot data frame, and inside it I have to pass a dictionary, and this dictionary should have certain keys and values. So I will pass keys as say names, and the value that I'm going to pass here is, say I'm passing 30 29 and say 42, and I'll add one more value, that is 76. And okay, I am going to give names over here, so I'll pass this as age, and this is my age, and the name I'm going to give is Akash. If we know, okay, and I'll just give some more things about, say, percentage. Okay, so percentage that I'm going to give over here is so these are dictionary actually, so I have to make sure that there is a comma at the end of each separation. And percentage, let me take 78, 76, none, and 96. Okay, so this is my data frame using dictionary, and when I run it, okay, there is some problem. Pandas has no attribute data frame, so we have to make sure that data frame spelling is correct. So data frame spelling is correct, but the F has to be capital. So if you miss it, then you will get error. So F has been capital, and you can see this is how your data frame looks like. This is your data frame by using Pandas dictionary. And we have one more method using dictionary, so you can create a Pandas data frame using dictionary with the same method we have used. So you can also specify the indexes. So here, while creating the indexes are not clear, so indexes is 0, a 1 2 3. So I'll do what, I'll create indexes. Index is equal to, I'll give my custom index a, then I'll give b, then I'll give c, and then I'll give d. So index spelling has to be correct, and you can see the indexes which was earlier 0 1 2 3, now it has been changed to a b c d. So now in this data frame I have indexes a b c d and name, age, and percentage accordingly. So this is our Pandas data frame, and we can also create a Pandas data frame using a list of dictionary. So for that, what we have to do is we have to pass the dictionary like this. So first is the list, outer body is a list, and within this outer body I have a dictionary, first dictionary and second dictionary. So what happens is, according to the dictionary names, whatever are the keys of the dictionary, that will become the name of the columns. Okay, whatever is the keys of the dictionary, that becomes the name of the columns, and values are the values corresponding to that particular key values. So this is how it will help us create a dictionary. So let us try it out using that dictionary approach as well, list of dictionary approach as well. So df list and dictionary. So df list of dictionary, the method pd.dataframe we are going to use, and I am going to pass a list of dictionary. So store 1, we will put it as the value, store 1, the value that we are going to pass in here is 90, 21, 32, 45. So store 1 has this value. In our case it is just one value, so I am passing 3 values to understand why I am giving it, because here I can pass a list also. So this is the store 1, and then I will give store 2, which is going to be, say, 30, just one value I am passing. Store 1, here also store 1 I will just pass one value, 100. Store 2 I can pass and I'll add one more, store 3, and the value of store 3 is 908 or something, and let me create this dictionary df underscore list underscore. So what I have done is I have created a dictionary, a data frame. I have created data frame which has the store whatever keys I am indicating, that becomes the name of the column, and wherever the in absence of key is there, that it will return as nan. So in my case, store 1 I have 3 values here, which is a list. So store 1, the list, the first observation is list. In the second store 1 I am having values 100, that's why I am seeing 100 over here. Store 2, the value is 30, here I am seeing 30. Store 2, again here it is repeating, the value is 76,98, which is a list which is passed here. Store 3, which has which is not present in third, that's why it is nan, and it is there in the fourth column, that's why it is 908.0. You can see that automatically the store 3 has become floating point. If I have mentioned 908 also, then also it is floating point. Why? Because there is no presence of nan, and if it doesn't have nan value, automatically store 3 column will become, if it has nan columns, automatically it will typecast it into floating point number. So this is the difference between the dictionary data frames with the help of using different methods. So you can use different methods to create a dictionary. It depends on what kind of approach and where you are using it. And let us try to understand the type of each of the data frame in detail. So first of all, let us try to understand what is the type of df list dictionary. If I pass it over here, so it shows that it is a data frame, but it's instead of passing this, if I mention the type of say store 1 column, it will tell me what is the type of store 1. It is series. It is telling me whether it is a series or not. It is not telling me anything else. So I can use store 3 as well. So let's see what is the type of store 3. So it is not telling whether the values inside it is an integer, float or whatever. So it just tells me, okay, it is data frame, this is a series, and that's it. So that is the part where we need to see that what kind of information. So every column in a pandas data frame is a series actually. So pandas data frame is a combination of series, you can call it. So now we will talk about how to handle files in pandas using data frames. So we will we'll try to understand how we will read data from various file sources. So the first and the most important part of reading the files from data sources to understand where the file is placed. Okay, so first of all we will learn what is there. So we have different functions. We can read CSV file, we can read Excel file, we can also read a zip file. If the data is stored in a form of zip file, we can read it, and we can also use the method of, if we have text file which is separated by tab also, that also we can read, and if we have JSON file, we can read it. So I will show you some of the methods of reading files, whatever files I have with me. I will just show you how it is done, and similar way it is done for all other files as well. So we'll try to read all different types of file sources. For some of the files, if it is not readed, I would recommend that if you have that file, you can use the same approach for reading it. So first thing, I'll show you, this is my pandas data frame file, and first thing you need to understand about reading file is, a file is read from a drive. Whenever we are talking about file, the file is present inside a memory location in your computer, and your Jupyter notebook is also placed in a memory location in your computer. So these are the two things. You have to connect two files as one unit. Okay, so when we talk about connecting two files as one unit, so we are talking about a kind of establishing a relationship. So if you want to establish a relationship, you need to put something which can connect these two files. Okay, so if you want to connect to a friend, you have to put a request. You need to put a request to connect your friend. Okay, if you want to connect with your mentor or someone or anyone who you want to connect, you have to dial in the mobile number. So what is this mobile number? This mobile number is the unique identification of that person. The similar way, if you want to work on files as well in your computer, both the files are there in your computer, and if you want to work on these files, you have to specify from where this file is actually located, what is the unique identification of this file. So right now my file is present inside downloads. My Jupyter notebook is present inside downloads. You can see the name of the Jupyter notebook is pandas dataframe.ipynb. So my Jupyter notebook is present inside downloads folder, and let's see where is my file present. My file is also present in the downloads folder. So this is my download folder, and the file that I want to read is the big market file. So I'll press Ctrl F and I'll call big. So this is the file that I want to read. Okay, so as I want to read this file, so I need to first of all copy the name of the file which I want to read. So right now I am reading this CSV file first. I have copied it, and you need to understand and see that where this Jupyter notebook is placed. So this Jupyter notebook is placed in downloads folder, and the file is also placed in the download folder. If both the things are there in the downloads folder itself, so we can simply copy it. Like it is possible to copy the name directly, and I can pass the name here itself. So if I want to read a data frame, df is equal to pd.read_csv, and this is the file. So if I use df, okay, if I use df, so pd.read_csv, this is my data frame df, the data file that I wanted to read. Now sometimes the file is not present in my memory location. So right now suppose this file was present inside my memory location, this file was present inside the same folder, both pandas data frame, this Jupyter notebook as well as the file, both were in the same drive. What if it is not in the same drive? What if it is not in the downloads folder, or it is there in some other folders? So assuming that it is there in some other folder, say I'll go on to dataset or documents, and say in documents I have different files. So I want to read a CSV file from my documents folder. I do not have any CSV file here. Okay, we do not have any CSV file here. No worries, we'll go to this desktop or something. We will see if it is there on desktop. Yeah, dataset is there. So in dataset we might find any files here. So we need to find any CSV file over here. So on desktop there is a folder called dataset, and here I have a file called decision tree data.csv. I want to read this CSV file, or for example I have to read this IBM iteration.csv file. I want to read this file IBM iteration.csv. Now this file actually is present in the desktop folder, desktop dataset, and my pandas notebook or my Jupyter notebook is present inside downloads. Let me just do one thing. Let me just copy the name of the file. I'll copy the name of the file. Okay, and I'll use it over here. Okay, this is the name of the file, and now I will read the file again, and instead of this entire address I will call name. So it is showing file not found error. Okay, I am using the same method. Say let me remove this name also. I will copy it as it is. So there is no difference in this code. If you observe these two codes, there is no difference here. Everything is same. Remove this part also, like if you don't want it. but here I am able to read the file, but here I am not able to read. You can see clearly in the first case the file I am able to read the file, but in the second case the file I am not able to read, because the second case the file is not present inside the memory location that I am trying to look. So I am trying to look IBM iteration.csv inside downloads folder, but it is not there in the downloads folder, it is in the dataset folder. So in such cases what to do? So if such instances happen, so what we will do is we will go over the desktop and the dataset folder on your Windows computer, okay, or on your Mac using Finder. I will share the entire screen. So this is my Finder, and on this Finder you will see okay, yeah, on this Finder. So this is my it is kind of Explorer in Windows. As you have Windows Explorer, here I have Finder, okay. On my Finder you can see it is written iCloud, desktop, drive, okay. So on my desktop I am in desktop folder, and in desktop I have a folder called dataset, and inside this dataset folder I have my file called as IBM iteration.csv. Now what I will do is I will come over this file, I will right click, and I will try to copy IBM iteration.csv as path name. So I am copying the path of this IBM iteration.csv, and what I will do is I will come over here and I will place the same path name over here, okay. So if I use the same path name over here and if I run it, I am able to read the file name, okay. Now you can see, even though this file is not present inside my folder, in my downloads folder, I am still able to read it. Sometimes what happens, you are not able to read it, so what you can do is you can put R over here and then you will read it, it will read, okay. Why it is happening? Because the address which I am getting here, it is the same address which Jupyter Notebook is expecting. Sometimes your colons are like this, you are not using forward slash, you may be using backward slash like this. So if you are using backward slash, so in that case you might require R here. So as for safer side, place R before the name of the address or before the address, and then try to read it, you can definitely read it. So this is the approach of reading any file. Now if I talk about any file, I can read any file with this method. So make sure you use the appropriate address structure to read the file. Now we will move on to the second phase where we will learn how to read different other set of files. So I am going on to downloads, and I am on downloads right now, so I will use the same previous method of reading files. Control F and big. So we have seen how to read a CSV file. We'll try to understand how to read a text file. So I'll copy the name of the text file and I'll just place it here. df text is equal to pd dot data frame, okay, and name of the file. Okay, pd dot read underscore csv, not data frame, read underscore csv. Now this is a text file, this is not a CSV file. If you want to see how does this file look like, you can double click on it and you can see this is how the file looks like. The file has, okay, so the file is separated by a tab. You can see this file is separated by a tab. So the data elements of this file is separated by a tab. If you talk about the CSV file, the data is separated by comma. That's why it is called comma separated values. So CSV file, the data is separated by comma. In tabular file, the data is separated by tab. So that's why we need to understand how we can work over this. And as this is a tabular data structure, but the separation here is not comma. So if I use this and if I run it, see how it is giving. So it is giving me everything in a single row, single column. It is considering all of the columns as single column, which is not in our case. In our case, month is separate, store is store is separate, and sales is also separate. So we need to keep everything separate. So what we can do, \t, and here we can put separator sep is equal to, and I can put separator is equal to \t. Now it is going to separate out the data based on tab. So now if I run it, it is going to give me different columns for each of the columns or the attributes mentioned over here. So this is how you can create or read the file, which is TSV file or text separated file. So right now it is written as text only, because the TSV file or CSV file is also a text file. Only difference is it is separated by comma and this is separated by tab. So both are, the base version is text only. So we have read this both of the file. Now we will try to understand how to read an Excel file. So Excel, we all know what is an Excel file. So we will use a function to read an Excel file. So df Excel is equal to pd dot read underscore Excel, and here we can just specify the name of the file. So name of the file is like this, and we will read out this file df Excel, and let's see what we are getting. So we can see we are getting month, store, sales, and all different set of values. So month, this is an Excel file. So what is the problem with Excel file? The Excel file may have multiple sheets. Okay, it may have multiple sheet. So you have to specify the sheet name as well. So for that we can definitely use sheet name is equal to, if you are putting 0, it will show you the first sheet. If it has multiple sheets, so you can put 1. So if that sheet is present in your Excel file, it will show that sheet, otherwise it will not show you. So I will show you one example where I had multiple sheets. Let me check if I have the data. I need to look at, okay, we need an Excel sheet. Okay, right now I am not able to find this Excel file, so we'll do one thing. We will see it at the time of data exploration, where we are going to do data exploration. So we have read this Excel version of data, text, and CSV version of data. Now we will read HTML data structure as well. So I'll do what? I'll go to the big, and this is my data set. I'm trying to read this HTML.csv data set. HTML dataset, sorry, and while I want to read an HTML dataset, so df underscore HTML I'll call it, and I'll just put pd dot read underscore HTML and specify the name of the file, and let's have a look at the name of the file. So if I read it, so it gives me a list of data frame. Okay. So reading directly HTML is doesn't give me the data frame, it is giving me a list of data frame. If you want to see the type of each of it, so let's see the type of each of it as well. Like type of df text, it is going to be a data frame only, n-dimensional data frame, core data frame. Type of df Excel is also going to be data frame. So it is also data frame. Type of df is also going to be data frame. So type of df is also a data frame. And but if I use type of df html, so type of df html is not data frame, it is a list. So as I said, it is a list of data frames. So actually it is a list, inside it the data frame is residing. So what I have to do is, if I want data frame of html, so what I can do is I can use df html is equal to df underscore html square bracket 0, which means I am taking the first element of the list df html. So df html is a list of data frames. So I don't want so HTML is a combination of multiple data files, so it may have multiple data frames within it. So as HTML may have multiple data frames, so when I read that the data is stored in a form of list, and this list can have multiple data frames into it. Right now I have only one data frame into my list. So when I read it, it is stored as a list in my data frame is stored as a list. And when I use df underscore html square bracket 0, so what I am doing is I am extracting the first data frame which was present inside my list when I read it. So what I am doing is, when I run it, so now df html is not going to be just an html file or not a list, it is the type of df html has been changed. If you see it, so type of df html is now pandas core data frame, earlier it was list. And if you see this df html, so this is my current df html. There is a default column which is also getting added here, which is an unnamed 0 column. So it has different things, that a, b and c column names as well. So this is how we can definitely work on data frames and read data frames from different sources. So that is one part. So we have seen Excel, we have seen CSV, we have seen that text file, we have not seen the JSON file. But if you have any JSON file, you can directly do the reading like bigmarket.json, and it should be present, the file should be present in the downloads folder if you want to use the same syntax. If you don't want to, like if the file is not in your download folder, please use this method of putting the address with the prefix of r and put the address into quote single or double. So that we have seen HTML file. Now we will also see this reading the zip file. So first of all I will locate my zip file. So what I will do is first of all let us import zip file. I hope it is there. And with zip file, now in zip file is a function which allows us to break down zip files, and if the zip file has CSV file, it will definitely read that zip file into my Jupyter notebook. So what we are going to do is, we are using the with command, and with command we are using with zip file dot capital zip file and big market dot zip. So with zip file dot capital zip. Okay, and I have to mention the name of my zip file. So in my case the name of the zip file is, so I'll try to find out the zip file name, any zip file which has multiple data set. Let me get it. (2020) full csv.zip. I will just copy this name. So I am copying this name of the zip file, which is a CSV file, and I will paste it over here. This has to be as z. Now as we know that with command is used to handle data in a very structured way. So we are trying to extract each and every zip file from my already existing zip file. Now I will use the first of all I have extracted all the files from zip bigmarket.zip. So in my case there will be a different file. So I am extracting all the files from zip, and I'm storing that as an instance of Z. So Z is the instance which stores all the files. Now with z.open, I'm opening Z, which is a zip file, and inside that Z I will find a file that I want to see, and I will read that file as f. Okay. So first of all, I will just double click on it, see what kind of files it is actually having. I think 2020 full CSV might be the name of the file, so I'll just use the same name. So I'm going to use with z.open, and I have to open the name of the file. So I will just copy the name of the file, which is, or I just use the same file name, Control Z. Instead of zip, I'll remove it. Okay. With z.open as f, I'm going to do, because I want to open it as an instance of something, so I'm using f, and I will use the name of the data frame as something. df zip is equal to pd dot read underscore CSV, and I'm going to read this data source file from f, and header I'm going to put it as 0. Okay. So now df zip is something where I'm placing my file, and I'll use it. Let's see if I'm able to read it. Maybe the name of the file, maybe it is different. I am using df.zip, and we'll see it. So this is a zip file which stores all of the information. So my zip file was there into like my CSV file was present inside a zip file. So if I'm reading a CSV file, this is the method, right approach to read the data or the zip file into our in our pandas data frame. So this is one method of reading a file, a little bit of complex, but not needed. It is not needed for you to memorize it all the time. Like sometimes when you're working online and getting files from different web sources, at that time such kind of things can be helpful, but not necessarily to memorize this. Yeah, but definitely you have to memorize these few of the above commands which are essential to work or import the file in your pandas data frame. Okay. Now we will talk about reading the text. So we have read the text file, zip file. Unfortunately, I don't have the JSON file, so try to read the JSON file whenever it is possible, if you have any JSON file. Now we have seen how to read files from different web sources, and now we will start with understanding the data. So in this session we will see what is data, what are different types of information into it, what kind of level of detail the data contains. So first thing is reading the data. So the first part of you working on a data is to read the data. After reading the data, if you want to understand the first, like if you want to see a very overview of data, okay, what kind of values does it have, so we can use df.head. Head method basically tells you what all information is there, the first 5 observations inside this df. Then we can use tail. Tail method is giving us the last 5 observations of your data frame. Then we have shape, d types, and we also have info to understand more about the data. So let's do one thing. We will try to have a basic check of all this information using our pandas data frame. So df is something that we have already read out, so I will use df text. I will use df text because this is a very easier file. Df text helps me with, if you see, it is holding all my data frame. Sometimes the data is very sometimes the data is very huge, so at that time I don't want to read all of it, like it is very messy at times. So to understand the data, I can do what, I can use head. Okay, head will tell me the first 5 observations. So it tells me like what is the column, what all values I have. If I want first 10 observation, I have to mention 10, and it will give me first 10 observation. But if you do not mention anything, by default it will give you first 10 observation. Now what is the benefit of observing the first 5 observation? So benefit of observing first 5 observation is you will have a reduced space in which you can look at your data, and you can see what all columns are there and what types of information is there. At the same time, indexes, whether these indexes are consistent or random. So we can see a random index, a consistent index we can see here we have, and there is no specialized index. It is, I think it is a by default created index. Month values are there, which is having Jan, which is string data type. Store here also ABC, here it is also string data type, and sales also is there, where we have sales in the form of number. So this is the first method. Then we can also use df underscore text dot tail. So tail will give me what is the last 5 values. So you can see the indexes 20 to 24. These are the last 5 values which holds the information of May month, store ABCDE and sales value accordingly. We can also have a look at the shape of the data set. Okay, how many rows and how many columns are there? So shape function, it is similar to the NumPy shape function. So the shape function helps you to tell, okay, there are 25 rows and 3 columns into my data frame. And then you can also use info function to understand the detailed information about the columns. So the detailed information also we can see month, store and sales. These are 3 columns and there are 25 non-null objects into this data frame. So there are 3 columns with no null values into it. So info will give you the detailed info of your data frame. For example, it will tell you about month, how many non-null values, like 25 non-null values. Store, how many non-null values are there. Sales, how many non-null values are there. We'll take example of one such df-zip function, like df-zip which we just now opened. So this is our df-zip. There are a lot of information to this df-zip. You can see like there are 8 to 7105 rows and 40 columns. It is difficult to understand what is there inside each of this column. So instead of opening everything, you can just use head to understand about this data, and you can read any CSV. I have read this, I have just downloaded this CSV file from kaggle.com. You can get any CSV file from kaggle.com as a zip file, and you can open that zip file here as we have done here. So open this zip file like this and kind of work on it. So right now I have opened this CSV or CSV file which was there in the zip file. And now if I talk about df-zip, so I can see each and every column and its information in a very structured way. Also I can see some nan are there. So let's try to dive deeper into this data. So df underscore zip, if I talk about the tail, okay, so tail of this data, it shows me that what all values are there. So these are last 5 observation in the tail of your data. There are 40 columns and there are 5 rows which we are seeing here. So if you want to just visually inspect, okay, what all things are there, so this is the right way of working or trying to find out your data. Now we will talk about df.d types, okay, to understand what all data types are there. So it will tell you all the columns and the detailed data types of each of the columns. So that you can see integer is there, which stores integer information, and you can see object. So object tells you that the information inside this column is a categorical in nature. So df-zip, if I talk about, so df-zip, it tells me about df-zip, what is information inside it and what kind of information, like object, date mutation, integer, all these different types of informations are there. Lot of different extra columns are there. If you want to understand the data in very detailed way with data types as well, you can use info function. Now info function here you can see it tells us about data frame in detail. So the df-zip data frame, it has 8,000 like 8,27,105 entries, which for which the index starts from 0 to 8 to 7104, and the total number of columns are 40. ID mutation is 827105 non-null values, which means there is no missing values into it. Similarly, we go on down, we have 8270105105, 105, which means there is some kind of value inside these columns. Here we see that there are 5,16,417 observations which are non-null, which means there is a certain level of missing values in my address numeric column. So in this column you will see certain level of numeric missing values. So this is how you can inspect any data frame. You can download any data frame from Kaggle and you can inspect it accordingly. So that is the part of understanding data in a detailed way. So now I will try to understand how to access data frame element using indexes. So there are two ways of retrieving information, like there are multiple ways actually, not just these two ways, but Pandas specifically have these two methods which helps people to understand more about the number of columns and observations, and if you want to index a certain level of data. The two methods which are uniquely there in this Pandas data frame, that is iloc and loc. iloc is basically used to retrieve the information based on index positions or index numbers, but loc helps you to retrieve the information based on the column name or index name or row name. So whatever is the index name, column name, based on that we can retrieve information in .loc or .location. iloc helps us only if we want to extract based on index number. So this is the syntax to get data from this data df sales, and if you put iloc 1, it gives you the observation 1. The value of month, store and sale is the first row it is giving you out. If you mention iloc 0 store, it will give only information about the store, and if you put 3:6, it will give you information about these columns starting from 3 to 5. So it will take index starting from 3. It will show index values at 3, 4 and 5. So accordingly it can give you information. And then if you want certain level of slicing to be done and set to get certain set of information, you can do it using iloc, and you can use all possible slicing approaches that you have done earlier in your Pandas data frame, earlier in your list, or if you have done it in NumPy arrays, if you have done it in series, the same approach we can follow out here. So let's talk about the iloc method in detail, and let's try to understand if these are the only methods by which I can extract any data. So df underscore excel I will consider for here for this analysis. So df excel, you can see there are 3 columns: month, store and sales. Now before going to iloc method or .loc method, let's talk about using the data frame's original indexing approaches. So I can use say if I'm mentioning df excel, if I mention 0, it will give me error, it is not retrieving anything. Okay, so when I'm using square bracket, I have to mention the name of the column. Okay, so if I'm saying month, so it will give me information of month from the excel data frame or df excel data frame. Okay, what if I want only two values, that is month and store? So if I want only two information, month and store, what I will do is df excel, I want say month, I want say store, and if I want only these two information, I can simply use double square bracket and it will give me only 2 columns if I want it. Okay, so this is a method of getting information. Now suppose I want first 5 rows. Okay, I'm trying to get first 5 rows from df excel. This is my df excel, and if I want first 5 row, so if I put is to 5, so it will give me the first 5 row. We can use head and tail methods as well. If I want rows from 3rd to 15 or say 15, So if I want rows from 3 to 15, so here I can get rows from 3 to 15 as well. If I want only month and sales for these 3 to 15 column, so I have to mention in double square bracket month, and I have to mention say sales for these columns. So I can see month and sales from 3 to 14, and this is how we can definitely extract information. So this is the basic approach of extracting information. If you want a particular month only, like if you want only the month if you want only a column, that is store. So if I want only store, so if I use only single square bracket, it will give me store information. Now if you talk about type of this df excel store, this is nothing but a series. Okay, you can retrieve the same set of information by using dot store. Okay, if you use dot store, you can get the same set of information, and type is also, if you talk about the type, it is also series. It will give you the same information. You can use square bracket and you can call it out as store, and if you use dot, you can also call it like you will get the series only. Now if you want this column only but as a data frame, so only if you want only one column but that too as a data frame, so you can use df excel square bracket, and store is, suppose if you want store, you can use store, and you can put double square bracket around this store. Okay, like which means, so if I use double square bracket, it will give me data frame version of it. So I can simply call type of df excel store, and it is called out as data frame. So this is the approach of getting the data like in the series format and data frame format. Now we will move on to the actual methods of pandas in a systematic way, like iloc and loc approach. So this is the way of extracting information from any pandas data frame, but we also have something called as iloc and loc. So let's talk about iloc particularly for df excel. So df excel dot iloc, if I talk about, so it will give me all observations. So suppose I want only month and store, so I cannot put like this. If I put like this, it will throw me an error, because iloc basically requires the index number of that column that you want to extract. So I want a 0th column, so I have to put 0. When I put 0, it is not giving me all the month details, it is giving me only the month, store and sales detail for the first observation. If you talk about df excel, if you see the df excel, if we talk about df excel, so Jan A 21080, it is nothing but the first observation. So we can see if we are putting square bracket 0 or comma 0, if we are putting only 10, okay, so it will give me all these values like Jan A and 21080. What if I put 0 comma 0? Okay, if I put 0 comma 0, which means it gives me from df excel 0th row and 0th column, which means Jan month. So that is why we are getting Jan over here. Okay, so iloc is a very efficient way of handling indexes of data or retrieving information based on index positions. Sometimes we are not aware of getting information, like we are not aware of what is the name of the column, or we are working on an iterative basis on a certain data set. So if that is the case, we basically go on to use the indexing approach. Sometimes it is very mechanical in nature, where we are retrieving information on a certain set of interval basis, or some certain index level informations we are trying to get. So index location is a faster way of retrieval information in such cases, where we do not need to get through the name of the column, because column names can be anything in several instances. So index location basically helps us out with this. And now in index location, if I want say all of the data from the 0th column, so I can use like this. Say I want all of the information from the first 2 columns, so I can use like this. It will give me information from the first 2 columns. Suppose I want information from 0th column and the second column, only these two columns I want. So that also I can do, like month and sales. If I want, I can get information for month and sales. Let me put head over here, so I'll get only the first 5 observation. What if I want only want the information for store and sales? So I have to put 1:2, and it will give me information of store and sales. If I want, say, from 10th observation to all of the data, if I want from 10th observation onwards, so I can put 10:2, and it will give me all of the information starting from the 10th observation, and it is giving information for store and sales only. Okay, so this is a very efficient way of handling data in Pandas data frame by using the iLoc approach, where we do not have to memorize the name of the location, or what is the name of the location, what is the name of the column. We don't have to deal with that. We just have to use the iLoc approach and directly get started with it. So that is one thing. Now if we talk about this function in general, like the Excel function in general, so we are actually sorry, if we talk about this iLoc approach in general, so iLoc approach helps us to retrieve the information, like 10 whatever number of columns we are putting. If we want a particular subset of data, iLoc is very much helpful out here. Okay, if we are using only one index, so it will give the data in a form of as you can see, it is giving only the data in a form of series. If you use a square bracket, it will give the data in a form of data frame. So that is the difference in iLoc. It is similar to what we have seen just now, but here the specialty is you don't have to mention the name of the column, you have to mention the index position of that column. So that is something which is we have to keep in mind. So that is iLoc approach of extracting information. We can see iLoc with respect to different way of getting information from different rows to columns. So we have use that in our Jupyter Notebook code as well. Now we will talk about LOC method of extracting information. Now LOC method of extracting information is a bit different method, because in this method we have several things to consider. Like, it's not just the name of the column or index of the column. We can definitely reassign or get the values based on some condition as well. For example, we'll start with, say, this dfxl. If we talk about dfxl dot head, I'll just use dfxl dot head. Say I want to retrieve information for the column month. I know the name of the column. Okay, so I can use df underscore xl. As we can use direct approach also, but .loc method has its own benefits. I will tell you. .loc method, if I mention the name of the column, so I have to first mention, there are two parts in LOC. Basically, all rows I have to specify, and the name of the column I have to specify. So it is month. Tell me all, give me all months of all the months in present inside dfxl data frame. So in the dfxl data frame, wherever is the month column, give me all of the information. So that is what we are doing here. We get it. If you want it, like, you can put here square bracket, you will get the data in the form of data frame as an output. So that is one thing. And suppose you want two columns, like if you just want month as well as sales, you have to specify the name of the columns actually here. So you can specify sales like this, and it will give you information for a month as well as sales, both of the values. So it is very easy actually to get this data. But there is a very important part when it comes to LOC method. So LOC also supports, suppose if you want indexes also, suppose you want a particular index value, say if you put here square bracket, or if you put here square bracket, and if you mention few indexes, say 7th index, 8th index, and say 15th index, and that too it will give you. So for index 7, 8 and 15, it is going to give you values. Okay, so if you want all of the columns for these indexes, you can put it like this, and if you will get all of the columns for this indexes. So these are the methods, are key differences in LOC method and iLoc method. But there is a very important thing about LOC method. For example, dfxl I am considering, And for this df excel, you can see month, January, February, and all different months are there. What if I want only the month of January? Okay, I want month, okay, equal to Jan only. Okay, so this will give me information, like it will return true or false wherever the month is Jan. Okay, I can call it out as mask, because mask holds true and false values. I can use this mask over my df excel, and I can just simply call in this mask, and it will retrieve me information. Okay, it is not retrieving any information for me. Okay, I have to remove df underscore excel, and square bracket mask I have to put directly instead of parenthesis. That is the mistake that I have done. So if I put df underscore excel mask, and it is giving only for the month of Jan. What if I want for a different month as well? I can put multiple condition, and it is the same approach that we have used so earlier. So the same approach we are going to use. Suppose I want for month of I want it for the month of March as Jan as well as say March. Okay, so if I use it, I have to put an bitwise operator. So bitwise operator, it will give return true if wherever we can see the month is Jan and March. So it is not possible to have Jan month and March month both in a single observation. So and will not work out. If you run it, see, it will return an empty data frame, because everything will be false in this case, because it is not possible to have 2 months as same. Like either it can be Jan, either it can be March. Okay, so it cannot be like, even if I change the name also, or let me just use or here. So if I use or here, it is returning true for Jan month and March month. So rest of the month it is not returning, and you can see it is giving data for the month of January and March. So that is the best part. You can use conditional way of you can use a conditional approach of getting data, but you can use it using the .loc method also. You can put it in the .loc. You can put the mask here, and you can mention all the columns that you want. If you want all these columns, you can put like this. If you want specific columns, okay, if you want column from say month, and so month onwards you want all the columns, you can put, okay, you want month as well as store. So you can get the data for month and store for these 2 months, and wherever whatever months that you want. Okay, the best part of having this is you can assign some another data frame to it also, and it will acquire the same information here. I'll show you how we can do item assignment or value assignment also. So suppose there is a mask for say here we have, and I'll create a mask for the month of Jan. Okay, and store, I want store is equal to C. Okay, so for the month of Jan, and the store has to be C. I'm using AND operation. So wherever the month of Jan is there and wherever the store is equal to C, I want to see that data. So you can see the month is Jan and store is equal to C. So wherever the month is, as we see the month is Jan, store C, wherever it is there, I want to change the value of a column, that is sales. I want to change the sales column for it. So at that point, wherever the sales columns are there, I want to change. So for this, let me just put all of the columns. Okay, so right now for the month of March, for the month of Jan, and store is equal to C, the sales value is 22369. Okay, so I want to change this value based on this condition. So based on this condition, I want to change the sales, and I have to assign it a value as 45,000. Okay, and if I run it, and if I run this again here, earlier the sales value was 22,369, and if I run it, you can see the sales value has changed. And if you want to see it in the major data frame as well, dfxl, you can see for the month January C, it has automatically made the changes as sales as 45,000. So that is the best part. You can use conditional operation over here, and reassign a certain value or change or update a certain value based on certain condition using the LOC approach. So LOC is very handy in dealing with changing different data values and getting new data values out there. Now we will talk about sorting of a data frame in how we can sort a certain data frame. So data frame sorting is a very important part because sometimes we want to rearrange the data based on certain values. So that we can do with the help of sort underscore values function. This is the same function which we have used in our series, but in series we had to we can directly use it, like we do not have to mention any observation or any column name. But data frame is a combination of multiple series, so we need to specify based on which column I want to sort this entire data frame. So sort underscore values, and inside it I can pass in the name of the column, that is sales, and it will definitely tell me like how I want to sort this entire data frame. So we can have a look at this data, and we can sort it in the ascending order or descending order by just specifying the argument ascending is equal to false or true. And we can sort it based on multiple conditions as well, like we can specify, okay, first sorted by sales and then sorted by store. So you can sort it based on different conditions as well. Like if you want two level sorting, like based on two columns, you can do it based on two columns at a time. And sort underscore values, you can sort the data based on store and sales, that also is possible. So we will try to have a look at this sort data method. So say this is my data df excel, and I will sort this data based on say if I'm sorting it based on month. So you can see it is month wise getting sorted. First is April, then Feb and Jan. It will sort it based on alphabetical order of month. And if you want to sort it, you can see March, Jan, March and May, and like that. If you want to sort it based on store, it will do it with respect to store. So the store A will be first, and then store B, and then C and D alphabetically it can do. If you want to sort it based on sales, you can do it. And first month, like in the month of January A, it is the least sales, and the month of February C store, the sales value is 48, which is the maximum. So you can sort it based on month as well as sales. You can sort it in descending order as well. You can mention ascending is equal to false, and it will sort it in the descending order. So you can see Feb C 48624 is the value which is highest, and you can see the decrementing order of your data. So this is the benefit of using sort underscore values. Sort underscore values can be compounded with multiple level of hierarchy. Like if I can mention two columns at a time, say I'm mentioning, first of all I'm mentioning store here to understand it better. So first sorted based on store and then sorted based on sales. So first it will sort based on store, so it will take all the stores E, D, C. So it starts in descending order. I will take it in ascending is equal to true to take ascending order. So first it will take ascending order of store. Within that A store, if you want to rearrange this data, so it will arrange based on sales now. So it will then see which is the lowest sales. First it will arrange store in ascending order, all of the stores, and then it will arrange within that stores which one is the lowest value. It will go at the top with respect to sales column. So two level sorting is done using sort underscore values over here. So this is the benefit of using sort underscore values. You can sort data based on indexes as well. So if you want to sort the data based on indexes, you can simply use a dot and sort indexes. You specify it, it will sort the data based on indexes, like the way we have initially observed our data. That also is possible. So these are some of the methods of sorting the data using the sort underscore values. Here we can see an expression where we are trying to discuss about sorting the data based on a certain condition. Like if you want to get all the rows where sales is greater than 40,000, so here we will extract first all the data where the sales is greater than 40,000, and then we will use a sort dot index to sort that data based on the index values, based on descending order of the index or whatever order that we want. We have to specify ascending is equal to true or false accordingly. So this is the approach of sorting the data in a data frame. Now we will talk about ranking in data frames. So here we will talk about a data frame first of all. So we will use dictionary method to create a data frame. So in this data frame we can see there are 4 columns. First is name, verbal score, quantitative score, and qualifying as yes or no. Name contains all string data type. It has string information in the form of names of people. Then verbal score has numeric information on a scale of 151, 152 like that. Quantitative score comes around 158, 87. This is also a numeric value. And qualify is a categorical data with yes or no. So this data frame, we are going to use the ranking function, or we are going to create ranks of our pre-existing data. Okay. So let us understand what is ranking. We have already used the rank function in our previous sessions. Ranking is used to allocate rank to a particular data based on certain values. So we are going to use the rank data frame. So here we are going to rank the data frame by values in the column verbal score. Okay, we are going to rank according to the verbal score, and we are going to use the method as minimum. So if the verbal score is same for 2 or more observations, then the minimum method assigns the minimum rank to all the equal scores. So here it is, if you can see, verbal score has certain values, say 151, 152, 151, 156, 100, 145 and 155. If you want to assign the ranks to each of these values starting from the lowest one, so lowest to 100 is the lowest, so therefore the rank is 1. Then if we talk about anything above 100, it is 145, so here the rank is 2. Above 145 there is a value 151, so 151 has 2 occurrences in this data, that is why the rank is given as 3 and 3. After 151, any other value we have is 152, but we do not see 4th rank, we directly see the 5th rank. So here we are using the minimum method of ranking. So when we are using the minimum method of ranking, it will give the minimum rank to the occurrences of 2, if 2 values are occurring at a same value, and 2 items have same value, it will have the same minimum ranking. And we will skip the next rank, and the next value will get the rank 5, and then we have 155 as the value, we get 6 as the rank and 7 as the rank. If there are 7 items, so here using this minimum ranking method, there will be 7 items or 7 ranks being returned, irrespective of how many times any value is there. It will try to skip that many times the number of observations or number of ranks from that particular data. Now we'll talk about the another instance of rank. Here what we are going to do, we are going to rank the data frame by the values in verbal score only, but here we are going to use the max method of ranking. We have seen the min method of ranking, but now we are going to see the max method of ranking. If the verbal score is same for 2 or more observations, then according to the max criteria, the maximum rank is allocated to both of the repeated values. So rest all of the values are same, but as we are using max method, so the value for the rank for 151 is 4. We do not see any rank 3. Ideally we should have a rank 3, but here we do not see a rank 3 because 4 is the rank which is allocated to both of the values, because we are using the max ranking criteria. So that is about ranking. Then we will talk about the dense ranking approach. Now here it is a bit different. Okay, this method does not skip any rank like the min and max method. Here it basically assigns the rank 3 to to verbal score, which is 151, and 4 to the next verbal score. So basically rank 3 is assigned to 151, as we can see, and as in our minimum method, it has skipped the rank 4 and it has given the rank 5, but here it is not skipping, it is giving the rank 4. So here there is a difference between this method of ranking. It is a dense approach of ranking where we do not skip any ranks, and that is why we will have the number of values. If we have 7 values, we will not get 7 ranks, we may get 1 or 2 less based on the number of repetitions happening. Then we will use the another method of ranking, that is the average method of ranking. In average method of ranking, it assigns the average rank to the equal ranks. For example, here we have 151 which is getting repeated twice. So as it is getting repeated twice, so it will have 3.5 as the rank. Why 3.5? Because ideally, if we see this ranking approach, so 151, the first 151 should have the rank 3, and the third 151 should also have rank 3, but there is no rank 3. So basically there is no repetition. Ideally with the minimum approach, it should be rank 3. If it is a maximum approach, it should be rank 4. And in Python, if we are using the average approach, so the rank 3 and 4, as we have used in the previous ranking approach, in the dense ranking approach, now we will not see that particular approach. Here we will skip the rank 4 and we will take average of the rank 3 and rank 4. So considering the first occurrence as 3 rank and next occurrence of 150 as 4 rank, so whatever is the average of 3 and 4, that is going to be assigned to the rank wherever the values are same. And we are not skipping any rank here, and we will move forward with the next rank. Basically 3 and 4 was supposed to be there, but 3 is replaced by 3.5 and 4 is also replaced by 3.5, and after 3 and 4 the next rank is 5. So this is the approach of average ranking. So now let us try to implement this all ranking in our Jupyter notebook. We will try to have the same data frame. We'll try to have a shorter version of the same data frame, or we may use our pre-existing data frame which is there. So let's have this df excel. So what I will do is, okay, we'll create a new data frame also. So df is equal to pd dot data frame, and in this data frame we will use the same data frame, name, verbal score, and qualify. Like I will use only 3 columns, name, verbal score and qualify. So name and I will provide the list of names. So here I will give only 4 to 5 names. So I will give A name, B, C, D. There are 4 values, and we have verbal score, so we will put verbal score, and here also in verbal score I will pass only 4 values, say 10, 20 and 20 and 30. I am just trying to repeat the rank for values for B and C to see how the dense ranking approach actually works. And these are the 2 columns. I will use only these 2 columns to create a data frame. Now we have created this data frame. Let me add one more data point. So I will add E with certain value. Here I will add 40. So I have added 5 data points, and here we have the values. Now we are going to start with the basic ranking approach, that is the min method of ranking. So I want to give the data column verbal score. I want to give the ranking based on the verbal score method. So in df I will be using verbal score column, and on this column I will use the rank function. So now as we are using rank, so there are different approaches as we have discussed earlier. As we have discussed earlier, As we have discussed earlier, there are different approaches. So if you run this, we have to put the method is equal to, so you can use the min method, and if we are using the min method, you can see there is a min method. According to the min method, the ranking is given, the minimum ranking is given wherever the values are repeating. So here the values is 10, 20, 20, 30, 40. So minimum value is given. I will do what, I will just remove this. I will put 101, I'll put 120, I'll put 120, I'll use here 230 and here 340 or something, because ideally I do not want to put it on a scale. So I will do what, df, I will create a new column and I'll put here as minimum ranks, and we will visualize our df. So according to the min ranks method, if we see this min ranks method, so we are giving 101 as the rank 1, 120 and 120, these are repeated values. So minimum value 2 and 2 is repeated. We do not have rank 3 and we directly have rank 4 and rank 5. So this is the minimum approach of ranking, where we give minimum ranks to the repeated value and the next possible rank is skipped. If suppose I have 3 values here like 120, 120 and 120, and in this case what will happen is, we will try to see what kind of ranking it is giving. So if we see this, so 101 will have rank 1, but 120, 122, 120 has rank 2, 2 and 2. But we do not have rank 3 and rank 4 because 120 is repeated 3 times. So we will take the minimum of 120 rank, that is second rank, and we are not taking third and fourth rank, we directly take the fifth rank. So that is why the rank 5 is coming out here. So as many times this 120 value will get repeated, the value or the ranks will get skipped. So n number times, suppose it is repeated 3 times, so n number n minus 1 ranks will be kind of skipped. Okay, so these are the ranks which are skipped. So here we have skipped 2 ranks, that is the rank 4, rank 3 and rank 4. Now we will use the max method of ranking. So in max method it is quite different. So if we talk about the max method, in the max method I can see the rank 1 is being assigned, and after that 2, 3 and 4 was supposed to be there, but we do not have 2, 3 and 4 because 120, 120 and 120 is repeated 3 times. So it is repeated 3 times, and ideally if I go by ranking, standard ranking procedure, so there should be rank 2, 3 and 4. So the maximum rank is 4 for this value. So maximum rank is getting allocated to each of this value, that is 4, 4 and 4, and we are skipping again, we are skipping the rank 3 and 4 or 2 and 3 here, and directly we are coming over the rank 5. So these are the 2 standard method, that is minimum and maximum method. Now we can go by the dense method as well. So we will see the dense ranking approach here, and if we go by the dense method, it uses the dense method of ranking. Why? It will just check what is the value. So here it will assign the rank 1, and if we have 3 values repeated, it will give the rank 2, 2 and 2, but the next rank will be 3, it will not be 5. It is not going to skip any ranks, because as per the dense method, no rank can be skipped out here. So that is the dense method of ranking. And now we will talk about the next method, which is average method of ranking. So if we do not specify anything, accordingly it is going to take the average method of ranking. So we'll do one thing, we'll put it out here, and we will put average. Let's try it out, and here also average ranks. So according to the average ranks, the average of values, so if we talk about this values, the value 120, 120 and 120. So the value average of 120, so this actually by normal ranking method, if I go to rank it, so I will give this one rank. Here I was supposed to give 2 rank, but this value is repeated 3 times. So ideally if I go by the standard ranking procedure, this has to be 2 and 3 and 4, and this has to be 5. So it will take the average of these 3, because these are repeated, it has the same value. So it will take average, and the average of 2, 3, 4 is coming out to be 3, and that is why the rank 3 is assigned to the values which are repeated. Say if if I am trying to remove these values, say I have 140 out here, and let's see what changes we can see now in the ranking procedure. So we can see different level of changes in the ranking, and we'll directly have a final comparison. So if we go by, if we have only two values which are repeated, so say name and verbal score are repeated. So according to the name and verbal score are the two columns, and we'll try to give the ranks for verbal score based on verbal score. So verbal score is 101. So according to the min rank, 1 will be there, and 120 is repeated twice. So it will have the rank 2 and 2, because it is a min ranking method, and it will skip the rank 3 and it will have rank 4 and rank 5. Max ranks is similar to min ranks, but only thing that is different is it will just consider the maximum rank. So the maximum ranks which was supposed to be given for 120 and 120 was rank 3 and rank 3, rank 3, 2 and 3. But the maximum of 2 and 3, the rank is 3. That is why the rank 3 is assigned to wherever we see 120 values. Dense rank is where we do not skip any ranks. It is similar to the min ranks. Everything is similar, but the next rank which was supposed to be 4 is not 4 now, it is 3 and 4. So it is not making any skipping of any ranks. And when we talk about average rank, it is again similar to the minimum or maximum ranks. The approach and everything is the same. The skipping part is also same, but the only difference is it is going to take average ranks of the two ranks which were supposed to be there. Suppose here it was 2 or 3, so average of 2 and 3 is 2.5. So that is why it is assigning the value 2.5 as an average rank out here. Now we will talk about data frame concatenation, and that is a very important part in analytics if you are working on data, if you are working on any analysis, because all of the time what we have to do is we have to combine multiple data sources multiple times, like in a single unit, and make it as a one and do some analysis over it. So when we have such kind of approaches, we need to understand how we can concatenate a data. So data frame concatenation, Pandas data frame can be concatenated based on two approaches, because it is a tabular structure. It can be concatenated one below the other, or it can be concatenated side by side. So we will try to understand each of the methods, and in a very detailed way, in a very detailed and structured way. Okay, so there are two methods as we know, that is concat and another one is append. But the concat method is right now working. Append method is out of bound. It has been deprecated. It is not working right now. They have removed. So we will not go with the append method. We will go with the concat method. You can try the code also. It will not work, because already in the current version it is going to get deprecated. So here suppose there are two data frames. We will do what? We will create our own data frames, and we will try to have a concatenation done of these two data frames. So we'll skip this part and we will see how this concat works. The concat works where we have to pass the two data frames inside in a form of list. So we will see the concatenation of two data frames, three data frames, and we will try to understand all approaches relative to concatenation of data. Okay, so all possible twists and turns when we talk about concatenation, which is given out here. So we have to pass in a list all the names of data frame that we want to concat, and it will give you the final concatenated version of it. So that is one thing. So this is vertical concatenation, where we use the axis equal to 0. By default, if you do not specify any axis, it will consider axis equal to 0. And the index number, as you can see, it is giving new indexes. It is giving or assigning new indexes to the data points. So that is a bit of a catch here. So we'll try to understand with respect to the indexing approach as well. We have seen it to some extent in series. It is similar to the series approach, but a little bit of different, as we are going to do the concatenation of columns as well. So we need to understand both perspective, that is the row perspective as well as the column perspective of concatenation. Here we have the append method, which is now not available. It is deprecated because already it is doing the same task that which concat is doing. So maybe that is the reason they have just removed it. So that is another thing. And This is here we are doing concatenation by column. We'll try to understand both the methods of concatenation in detail and try to compare the append and concat method. Right now we do not have to compare it because this is not at all working, so we'll just skip this part and we will move on with the concat. Maybe in the future version we may see this append method being brought back by Pandas community. So right now we'll focus on the concat method of data frame creation. So we'll talk about, first of all, I'll create a df data frame. This is my df data frame, and I will definitely use this here. So this is my data frame, and I'll call it as df1, and this is my df1, and I will also create a df2. Okay, df2 with same observations, not not same as observation. I'll put p, I'll put q, r, s, p, q, r, s, t. I'll put some values. Okay, I will add one more value here. If I'm adding one value in here, so I will add that value. I'll assign none or something over here. Okay, so this is my df2. So df1 has 4 values, 5 values, that is a, b, c, d, e. With certain verbal scores, and df2 has certain values out here, and we will try to do some concatenation. First of all, I will show you the basic level concatenation. Ideally the data is in front of you, so I'll show you the basic level concatenation. So I will use df3, which is a concatenated version of df1 and df2. So pd.concat we are going to use, and the same basic approach df1 comma df2, a very simple approach, and we are going to specify right now x is equal to 0. See, by default if you do not specify, the x is equal to 0. Let's understand what is the indexes of this data frame. So if you see this indexes, the indexes is 0, 1, 2, 3, 4, and for df2 also the indexes is 0 to 5. So these are indexes of both the data. Let me do one thing. I will give the indexes as well of this data. So df1 dot index is equal to we have 5 values, so I will put np dot a range, and I'll create values from say 11 to 16, so that it gives proper indexes. So I need to import np, import numpy as np, and let's see. So these are the indexes. I have given some customized indexes 11, 12, 13, 14, and here also I will do the indexing, but here I will give the indexing as different. Indexing is equal to 101 to 106, and here I'll call it as df2, here I'll call it as df2, and let's see the difference. It is showing some error because we have 6 values here, so I'll put 107, and let's now see. So the indexes, as you can see, for both of the data frames are different. Why I have customized the indexes? Because I can put the index here also, but I didn't want to mess up the data. That is why I directly put the indexes out of it. I can assign the indexes like this also for any data frame. Now 11 to 15 are my indexes here for A, B, C, D, E, and 101 to 106 are indexes for P to U, all values out here. And we will now do the concatenation part of this data frame. I am trying to concatenate df1 and df2 with x is equal to 0. We have seen it yesterday also how this concatenation worked and what was the problem that we faced. So if I talk about df3, so df3 if I put x is equal to 0, it is giving me a concatenated version of my data frame where I have names concatenated below, like name correctly concatenated one below the other, verbal score one below the other. Like once the data frame 1 is done, this is the part of data frame 1 and this is the part of data frame 2. So these are the two concatenated version of data frames. Now as these two data frames are concatenated very correctly, we can also see the indexes are also concatenated. So sometimes when we do the concatenation, there is a problem of indexing. Okay, so let's understand what exactly is this problem all about. This will happen, the index problem will happen when we are doing concatenation column wise, where I am putting axis equal to 1. So that is a different story. I am not even reaching at this axis equal to 1 part. I am just trying to focus on the current axis equal to 0. I will make a shift in my data frame again, like this is my original data frame df1. I am not going to do any changes to df1. I will do what, I will add one more column in df2. So df2, the column has say ranks or something. Let me just assign ranks, and the ranks that I am going to assign is, say, randomly I am giving any value. So there are 6 values, 1, 2, 3, 4, 5, 6, and here also 1, 2, 3, 4, 5, 6. There are 6 values here. And if I talk about df2, this is my df2 with 3 columns, and df1 has only 2 columns. Now let us try to concatenate this particular data, because here in df1 I have 2 columns, df2 I have 3 columns, and there is no consistent alignment of the data. The shape of df1 is different, the shape of df2 is different. So if I run the concat over this data, what will happen? That is what the question is. So I will run the concat using axis equal to 0. See, I am not even touched the axis equal to 1 as of now. I am concatenating vertically. So when I do this vertical concatenation, it is allowing me to concatenate. It will allow you to concatenate. It will not throw error, because it is going to add a new column below, like it is going to add a new column based on df3. So whatever number of columns are there, if the shape of this data is, say, like there are 2 columns here, if we have 3 columns here, so maximum number of columns are intended when we do the concat. So it will not throw any error if there is a difference between this 2 data frames number of columns, and still it will add that new column which was missing in df1 and present in df2. It is adding that column, and wherever it is finding that the value is not present, like for example, in data frame 1 we do not have rank, so there it is assigning none, and wherever in df2 or wherever the values were present, it is just putting those values in front of it. So that is the basic kind of difference between the concatenation part, and we need to understand if there is more number of columns, it will ideally deal with the concatenation in that approach. Now we have seen the concatenation of these 2 data frames in a very clear and concise way, and what I will do is, we have understood the axis equal to 0 concatenation. Now I will do what, I will create the same data frame again, df1, and df2 I will just make some changes in the name of the data frame. So this is my df1 and this is my df2, just to demonstrate what is the concatenating with respect to axis equal to 1. So in df2 if I am talking about df2, so I have a problem with the name, so I will call it as department or something. I will call it as department, and instead of verbal score I will call it as say rating or something. I am just giving some random names, and instead of rank I'll give ratings, and instead of rating I'll call it as cost or something. Okay, department, cost and ratings, I'm just giving out random names. So this is my new df2 and this is my df1. Now when I talk about concatenating the data frames with respect to axis equal to 1, so I'll use the df3 approach only, and all I need to do is I just put axis equal to 1. So when I put axis equal to 1, what we will do is, you can see
recording stopped.
Now if we are doing axis equal to 1 concatenation, so if I do it, let's see what will happen. So you can see it is concatenating the axes, like how it is going to happen. So there was name and verbal score present inside df1, but it was not inside df2. Okay, there was department, cost and rating which was in df2, but it was not in df1. So this is my df1 portion, this is my df2 portion. It is accordingly concatenating the data. But ideally what I wanted is, I wanted to concatenate this, this was my data, and next to this data I wanted to concatenate this part. So this has to go over here. I wanted this, it like this kind of concatenation was supposed to happen, but it has not happened. Why? Because the concatenation actually works based on indexes here. The way it was happened in the concat is equal to 0, where it consider the column names and accordingly it assign the null value. Here also it will consider the indexes and accordingly it will assign the null values. So when we are doing this index concatenation, it will consider the indexes as well. So here we have only 5 data points and the indexes are different. So if you talk about df1, so indexes was different. Here the indexes 11, 12, 13, 14, 15, and here the indexes are 101, 102, 103 and so on. So that is the reason it will just create a new row for concatenation. If you want everything in a single row, what we have to do is, we have to simply pass in one command, that is ignore index equal to true. So if we put ignore index is equal to true, now we have a concatenated, okay, okay, let me see. So now it is concatenating with respect to columns, but it is ignoring the indexes or the column indexes. Now you can see the difference. It is concatenating with respect to different indexes in the column. If I put ignore index x is equal to 0 here, it will concatenate and it will ignore the indexes of rows. So whatever axis you are putting, if you are putting axis 0, it will forget the row indexes and re-index from 0 to 10. If you are putting axis equal to 1, it will forget the column indexes and it will put the indexes 0 to whatever value it is. Okay. So first what we have to do is, we can do what, we can put a common index for both of the data. So I will do what, I will remove this indexing part and let the data frame itself decide whatever index it has. So I have used it, and now for df3, so we have to make sure first of all the indexes are consistently aligned. It should have the same index value as we have for departments or the second data frame. Data frame 1, data frame 2, both should have same indexes. So now if we talk about x is equal to 0, and if I put x is equal to 1, and I'll remove the ignore index part now. Now if I put x is equal to 1 and if I remove the axis indexing part, so it will index now based on the common index values also. So if I use df3, you can see there is a difference. So 0, 1, 2, 3, 4, the indexes were there for data frame 1 as well as data frame 2. For data frame 2, there was no index wise, that is why it is just assigning nan over there. Rest other values are as it is, and it is going to just put all the data accordingly. So that is the difference between indexing with x is equal to 0, x is equal to 1, ignore index is equal to true, so ignore index is equal to false. By default it is false. You can keep it true if you want to make consistent indexes for rows and columns according to your requirement. So that will just re-index your data accordingly. So that was concatenation. As said earlier, we do not have any approach of concat, like there is we do not have to compare append and concat, because append is right now not there. We have concat. Concatenate is used to concatenate multiple data frames together. You can pass n number of data frames in this argument, like you can have, like I have df1 and df2, I can have, say df or something like this, and it will concatenate one more set of values. So you can add more and more data. If I put df1 again df1, so it will have df1 again here in front of it. So that is the basic difference of concatenation. You can add multiple data frames as a single unit in a single line of code. You do not have to do any programming, any for loop or any kind of complex mathematical or programming stuff. You do not have to go through. You just have to simply call in all the name of the functions, all the name of the data frames out here, input it inside the concat framework, and it will do the concatenation. So that is the best part of using Python and Pandas for programming or doing and handling data, complex data. So this is the reason most of the people prefer using data frame. So now we will talk about joins. Joins method combines the data frame rows from one or more table based on a certain key. Now these key is similar to the what we have seen, the primary key and foreign key constant in SQL. If you have seen, it is similar to that context. So the index of the first data frame should match to one of the columns in the second data frame. That is the key concept out here. So it should have the same values basically returning. So there are different types of joins that we can perform here. That is the full outer join, inner join, left right join and left join. We'll try to understand each one of it in detail. Now if I talk about outer join, so outer join if we are performing, so it will concatenate both the data frames, or it will join both the data frames as a single unit. Considering the key column, so whatever key column, so wherever there is a match between the data frame 1 and data frame 2 key values, and it will just place it as a single row, and wherever it is not matching, it will just simply call it out as a unmatched data or unmatched value, and that is why it will just skip the next value or it will just put nan in front of wherever it is not matching. So it is similar to full outer join. We will try to understand it with the help of an example. Very interesting topic. Then we have inner join. Inner join basically considers two data frames, suppose, and it will just throw out only values if it is matching, like the key values are matching. If there are two cases like data frame 1, data frame 2, and there are two keys, so if the value is present in data frame 1 as that key, and in data frame 2 also the data value is present, so it will just concatenate both of it. Then we have right join and left join. So right join will basically consider all of the observation from the right table and only the matching values from the left table. Wherever it is not matching, it will just put nan over there. Then it will then we talk about left join. It is opposite of right join, so it will consider all of the observation from the left table and only the matching observation from the right table. So we will try to understand each one of this with the help of joins in data frame. So it is very powerful Python because it allows you to join two data frames together. So we will create our own data points here, and we will perform the joins. So I'll not read any data frame. We'll create this data frames, both of it, and here we will perform the join. Now in order to join the data frames to get the order details along with customer information, the syntax is quite a bit interesting. Why? Because inner join requires, if you want to do the join approach, it requires you to set a common index. If you do not set a common index, it is difficult to do the join. So what we have to do is we have to set something as index. So index is a value which is present in data frame 1 as well as data frame 2. We all know that in df customer 1 customer id is there, and in df customer 2 customer id is there. In both the data frames customer id is there. So this is the key to connect in both the data frame. This is the key to connect. So if you want to do the join approach, first of all set index. We have to set the index as customer id in data frame 1. We have to set the index as customer id in data frame 2, and then we will apply the join approach. So then we can use the join. We'll try to break down this entire thing into a single in a very small proportion, and try to understand what actually we are trying to achieve here. So let's do it. We'll do the join approach. So let me take a df1 data frame. I'll create a data frame and pd.data frame, and here I will just pass in certain values, say a, or key I will put, and the values for this key is 101, 102, 103, 104, 105. These are the values in this key, and next to this key, say I am putting some values, names I am putting, So say name is A, name is B, name is C, D. So there are 5 values, so I will put 5 names. This is my data frame 1. Let me run this data frame 1. Okay, it requires this symbol. Okay, by default it has to be like this. So this is our key and names. I will create another key, and where I data frame 2, where I do not have keys, so I will have keys. So for each of the key, what is the department? So these are the keys which are present, and for these I'll just try to remove 103 to understand it better. 103 here, and from here I will try to remove 105. Okay, and instead of name I'll put just departments. So department is say sales. I'll put IT. I will put finance, research, and accounts. Okay, so see, if these are the data frame 2 values, there is something missing. 1, 2, 3. Okay, we need 4 values, so let us remove this last one. And here also I think we need 4 values, so we have to remove this last one. We'll do it. So we have ABCD over here with certain values, and we have 102, 104, 105 over here, but we do not have 103 here. Okay, so we have a very correct version of data with us. So if you see this data, we have 101, 102, 103 and 104. Here we have 102, 102, 101, 102, but 103 is missing. Here we have 104, and we have additionally 105, but we do not have 105 here. Okay, so this thing we have to keep in mind before starting with the join concept. Now we will try to implement the join, which is this. So if you want to perform join, you have to make sure that the key has to be same. Like key is the customer, the index has to be the key. So for df1, we will do what? We will use set index, and I want to set the index as key. Okay, and this is my df1. So we have to set index as key, and I will put in place equal to true. Now what is this in place equal to true? It will do the permanent changes. So right now when I worked out, when I run this, you can see there is no index is same, like index has not changed. When I use in place equal to true, it will make changes in the original data frame. So now if I use the in place equal to true, so key has become there's 101, 102 and 103 and 104. Similarly, I will do it for df2. Again, there also I will put df2, and now my index has become key 101, 102, 104 and likewise. Now if I try to join it, I will try to join it df1 dot, I'll use the join function. I can join df1 with df2. Now I am not using this customer ID and join and everything. I am directly using the join that I want to perform. So I am using join on customer ID. I have to I have to specify I want to join on. Okay, there is a catch over here. We need to put the key. Let's see if it is able to join it on key, and how is equal to inner. So there is a bit of a catch. Let me put inner join. So it is not allowing to join because it is requiring a positional argument other. Let me see what is that other. First join, then it is df customer 2. Okay, it requires df customer 2, df2. Okay, so df1 join df2 on key, and how is equal to inner. Okay, So if you see this, when I'm trying to join this two values, so df1 has 101, 102, 103, df2 has 102, 10, 101, 102, 104 and 105. When I perform inner join, it will just put all the values which are repeated in both the data frame. So 101 is there, here also I have 101, 102 is present in df1, it is present in df2, that is why we can see in the join 102. 103 is present in df1, but it is not present in df2, that is why 103 is not here. 104 is present here and 104 is present here, that's why we can see 104. Here we do not see 105, here we have 105. So we can see that as per the inner join, it should be there in both the table, then only the join can happen. So that is the difference of join. We need to put we need to have that particular value here. So I will call it out as inner join. Now we'll talk about outer join, or first we will go with left join. So I'll talk about left join. If we run a left join, let's see what is the difference that we are going to get. So I am calling out df1 as my left table and df2 as my right table, because syntactically, if you see, this is the left side of my code, this is the right side of the code, or if I'm trying to talk about left to right, so this is my left version, this is my right. So df1 is my left table and df2 is my right table. So it will consider all the values from df1. If you see, all the indexes from df1 will be there in the resultant. So this is my df1 102, 101, 102, 103 and 104. We can see all of the indexes from df1 will be there, and all of the values also from df1 will be there, abcd. But department is not from df1, it is from df2. So department is a part of df2, that is why it will only consider values which are matching from departments table. For example, 101 was matching, so it will put 101. 102 was matching, so it will put 102. 103 was not there in df2, so that is why it is returning nan. And 104 is there, so it will return 104 value as well. So when we talk about creating, or when we talk about putting values like this using left join, so left join will always have it will try to return all the information from the left table and only the matching information from the right table. So it will try to match, it will not consider the information which is not matching. So 105 is not present in 101, okay. 105 is present, 105 is not present in df1, so it doesn't matter, it is not considering it at all, because it is a left join. On the other hand, if we do the right join, it will consider all the information from the right table but matching information from the left table. So on the other hand, right join if we are doing, so you can see the key is 101, 102 and 104 according to the left join or the left table. The keys are there, indexes are there, and from right table it will pull all the keys. So 101, 102, 104 and 105, these all values are there in right table df2. If you see, df2 has all these values. It will consider all of the values from right table, and from left table wherever I don't see any match, it will put nan. So there is a match. 101 is present in left as well as right table, 102 is present in left as well as right table, 104 is present in left as well as right table, 103 is present in left table but it is not present in right table. That is why 103 is skipped, because in as per the right join, it is not bothered about what is there in left join, it is bothered about all values present in the right table. So all values of the right table is there. Sometimes some values will not be there in the left table, like some right table values will not be there in the left table. So right table we have 105 as the index, which is not there in the left table as name. We do not have any name for 105 in the left table. So it is just putting nan out there because that information is not available. So this is the key difference between the left join and right join. Now the last join that we are going to talk about is outer join. So if we talk about outer join, so outer join is a complete join, like it will consider left table as well as right table both. So this is the part of left table, these are the keys of the right table. So it is considering all of the keys and values, okay. Now 101 is present in left table, so it is putting 101. 102 is it is present in left table as well as right table. 102 is present in left table and right table. 103 is present in left table, but it is not present in right table, but it is considering it here also. 104 is present in left table, it is not, it is also present in left right table. 105 is present in right table, but it is not present in left table. So if you try to compare it, so in the left table I have ABCD 4 names, and for A the department was known, which is sales. For B the department was known, which is IT. For C the department was not known because its ID was 103 and there was no department for 103. If you see 101, 102, 104, 105, there is no department 103. So there is no department for 103. That is why for C there is none. Then we had D. For D the department is 104, which is finance, but there was a value such as research or department research, for which we don't know who was working there. There was no name for 101. If you try to see, for 105 we don't know what is the name, we don't know, it was not present only. So that is why we are getting none there. So right join is a combination of both right as well as, sorry, full outer join or outer join is a combination of left and right join both. So that is the join concept we have seen. Now we will talk about the merge concept. Now merge is a method of concatenation of data frames based on one or more keys. You will find merge very much similar to joins. Okay, if the column for join is not specified, the merge method uses the overlapping column names as the keys. So merge is very interesting. It is going to use the, or you may find the same output in merge as well as join, but there is a key difference because in joins we have to specify a index as the keys, but in merge we do not have to specify whatever is the index. So I'll just skip this data frame. We are going to use our own version of data frame. So considering this merge syntax, so let us consider this merge syntax. In merge I am not going to call out which column to consider as common. I am directly putting in merge I do not have to call out or consider anything as key. I can simply merge pd.merge data frame 1, data frame 2 and on customer ID. It will automatically realign the data accordingly. Okay. So here we can see a simple syntax. We have different merge method, that is outer, inner, right, left and inner. So these all indexes are there. We'll do one thing, we will try to use the merge out here for our df1. So df1, this is our df1 and this is our df2. There is a problem with this. I have set a specified key as the data value. So what I will do is I will create indexes or IDs. Okay, I'll call IDs is equal to df1 dot index. Okay, so what I want to do is I want to reassign IDs as key only. So that I am doing. So here also I'll do the same. So this is my df1 and it has IDs. This is my df2, it also has IDs. Now I will do the merge or merging of these two data frame. Okay, and I will use reset index. Okay, or reset index over here, and here also I will use reset index. I'm using reset index, and now I have these two data frames, df1 and df2. So let me see if I have the same. Okay, in place equal to true, I have to put in place equal to true to make permanent changes, and here also I will put in place equal to true to make permanent changes, so I can see a clear difference in my data frame 1. So this is my data frame 1 and this is my data frame 2. Okay, I'll drop the column key here and I will specify the axis is equal to 0. Okay, sorry, 1. I'll specify the axis equal to. So these are the two columns that are there in my data frame, and here also for df2 I'll do it. I'll delete the column. So now I have two columns, and the index is 0 1 2 3, and here the index is 0 1 2 3. It has the same indexes. Here we have ABCD as the name. Here we has IDs 101 to 104. Here we have indexes IDs as 101 to 105, but 103 is not there. Same data frame. We will use the merge operation here. So as we are going to do the merged data, so I'll use the merge is equal to pd dot merge, and I will apply the merge operation as given in the syntax itself. We have to simply pass in the two data frames. I will pass in df1 comma df2, and on I have to specify, it is very crucial. So on id IDs. So let's see what is the merged version of the data. So as you can see, this is the merged version of data. Now I had the data frame 1 like this. Data frame 1 had three values, like all these values 10, like 101, 102, 103 and 104. Here we have 102, 102, 104 and 105. If I am not specifying how I want to merge it, it is going to take default inner join method. So according to inner join, it will receive, or it will throw values which are common in both. So here the 101, 102 and 104 are common in both the tables. That is why we are getting so merged inner join data frame. So I'll call it as inner. Here I have not set the indexes as anything. I do not have any indexes. And you can see there is key x and key y. What is key x? Key x basically tells us the this key is from index this table, and this key y is basically from this table. So this is how the indexing actually works. This is our inner join method. Now we will do the left join. For left join, I have to specify how is equal to left, and the output of the left join is very interesting, similar to it, like it is similar. So it will put all the data from the df1 and matching values from df2. So in df1 I had 101 to 104. It will all keep all the values, and in df2 it has 101, 102, but 103 is not there. That is why it is skipped. 104 it is keeping. 105 it cannot keep because it is left join. So it is only bothered about all values of left table, which is x table. Similarly, we can do it for right table, and we can use the right join. Now it will show all the information from the right table and matching information from the left table. So you can see all the indexes of left table is there, but from right table we do not see 103 because it is not bothered about the left table. You cannot see the 103 key from left table because it is not a part of right tables. It is bothered only about the right table values. So all the values of the right table and matching values from the left table. If it is not matching, despite it is there in the left right table, it will throw nan for the left entries out there. And then we have full outer join, for which I can specify the outer command, and you can see if I put outer join. So according to the outer join, it will combine both of it, considering both left and right aspect of data. It will put all the information from the left table, all the information of the right table. Wherever it is not matching, it will put nan. Now we can also merge the data based on indexes. So if you do not want to merge the data based on a particular key column, so we can use the merge with the help of index. So for that, the syntax is similar. You have to pass in the name of the data frames, first and second data frame, which you want to merge it, and you can put left index equal to true or right index equal to true based on the indexes available in both of the data frame. We will get the output. So we'll try to have this merge index is equal to true data frame out here. So let us take this code and put it out here, and I'll just remove on is equal to IDs because now I have to merge the two data frame based on indexes. Let me just have the data frame first in front of you. So I'll just put the data frame. So this is our data frame df1 and then df2. I'll just run both of it. try to understand what is happening in both of it. So when I'm mentioning that I have two data frame 1 and data frame 2, we can see data frame has 0, 1, 2, 3 as values here, 0, 1, 2, 3 as well. So when I do a merge with respect to index or so, I can consider either the left index or the right index. So if I consider the left index equal to true, let's see what happens. Ideally in our case we have the indexes are same, so it will have a complete join. So if I put left index is equal to true, okay, right index is equal to true, okay, let me put right index is equal to true, okay. So if I put left index and right index equal to true, I have to specify actually both the indexes here. So left index and right index equal to true, it will do a complete join as such. So you can see 0, 1, 2, 3 index is here also in the left table and in the right table as well. So here the key doesn't matter, like based on which key I am trying to do, it is not considering key as a common point of interaction. Let me put false out here and let's see what is the difference. It is not allowing because it is just going to merge the two data based on the left as well as right indexes. So it will consider the common or commonness between the indexes. Let me add one more observation in df2. So to do that, df2 dot like concat pd dot concat, I'll do one thing, pd dot concat, I will add one more observation, pd dot concat, and I'm going to add with df2. With df2 I am going to add a data frame, pd dot data frame, column name is key, it will have the same column name. I'm adding a new observations. The value that I'm passing as key is 106. Then the another column name is departments. So I'm going to pass departments as say IT or something again, and I will add one more column, that is IDs, and the column IDs will have a value as 106 or something, 107 or something. I'll just put 107 out here, and I'm just putting a concatenated version. df1 is equal to concat my df2 concat my original df2 with df2 with this data frame. This is the new data frame that I want to add here, and while doing this concatenation I need to put both the data frames into a square bracket, and I have to put the axis as equal to 0, and let's do it. Some sort of problem, pd dot data frame key value IDs key value. What is the problem? pd dot data frame, okay, so it has to be a function within a function, it has to be there. So I have added my df2. You can have a look at the df2 now. So df1 is clear, df2 I am just having. So in my df2 I have one more observation, that is index 0. I will set the index of the last row. df2 dot reset index I have to do in place equal to. So if I do it, this is my df2 with resetted indexes, and I have to drop level 0 indexes from my df. So I'll drop, okay, I'll comment it out. I need to drop 2 columns. So I'll drop level 0, I will drop index, and axis I will specify equal to 1 because I want to drop the columns. And now this is my df2. So in my df2 level 0 index, even after dropping it is not there, so I have to reassign it. df2 is equal to Now this is my updated dropped version of df2 where I do not see those columns. So this is my df2. I have an additional observation, that is 106. df1 I have observation 101 to 103. So like the indexes are 0 1 2 3. Here the index is 0 1 2 3 4, and when I use the merge with left and right index, let's see what we are getting. So we are getting 0 1 2 3. We are not getting the indexes of df2 even though we have specified it as true, because the indexes are not present in df1. So the index which is not present, that will not be added here if we are putting reset like if we are putting left index is equal to true or right index is equal to true. So that is the index based matching of or merging of data in your data frame. Now let's try to understand the difference between merge and join. Joins, merge basically is used to join or combine one or more columns of the second data frame. On the other hand, joins are joined by the index of the second data frame. Merge basically by default it performs inner join, but join by default performs the left join. Merge basically returns error if one tries to merge more than two data frames simultaneously. Joins, on the other hand, joins multiple data frames based on the indexes that we are specifying. Now we will talk about reshaping the data frame. Now reshaping of a data frame is essential based on whatever information we have. So considering a data frame which is here with certain name, salary, gender and age, we will consider our own data frame. So to reshape a data frame, we have something called as melt. Melt method is used to change the data frame format from wide to long. So what happens in a melt data frame? So suppose we have a column called as gender. So gender has male, female and male, female, like that. So when we do the melting of data frame, so here we are melting a data frame, and the column variable that contains all the columns except the identifier and value contains the value of corresponding column will be present out here. So here if we talk about the data frame, it has name, salary, gender and age. We are trying to melt the data based on gender. So when we melt the data based on gender, so we will use df emp dot melt id whereas we are going to put id here, which is gender. And when we do the melting of this data frame, so you can see that for gender female, the name is Dima, and likewise, and last female we can see the name is salary, and salary is given out here. So melting is used to transform the data in a structural way. Let us try to melt the data based on a certain value as well as a particular key. So if you try to melt the data based on age, so we can see that there are two genders, basically male and female, and the variable that we are going to consider for melting, that is age, and accordingly the age value for different ages is already given out here. So whatever is the value of age, it will assign the particular age value to the particular data. So why we are using melt is, let me just show you. This is my df1 or something, or let me take or call in the data that we have used very recently. So I will use this df dict, and we'll use df excel. Let's see the df excel data frame. This is our df excel data frame. I will take shorter version of it. So I will do what? I will take dot ilog first 15 observations and all columns, okay, and df shortened I will call. So what I'm doing is I'm just creating a shorter version of data frame df, and I will just pass it over here. This is my data frame df which is shorted, and now I will apply this melt option over here over this data frame based on the month column. So df shortened dot we are going to use the melt approach. And in the melt I am going to pass in this month. Okay, so I have to pass in id vars is equal to month. Okay, so let me do it, and you can see the shortened version of data frame df. So if you talk about month January, so variable it has considered as store, and value it has considered for that store. So January, there are 5 occurrences from 0 to 4, and here also you can see January 0 to 4. 0 to 4 January store ABCDE is there, and then again January is there, and the sales value for the store is shown, and it will also, if there is any more column, okay, it will accordingly give me the data. I will do what? I will take only 10 observations. Okay, so this is the shortened version of my data with 10 observations for Jan and Feb month. And when I use it, when I use the melt option, so Jan store and combination values. So Jan, for Jan the store it is taking store as the column, and for that store variable what is the value of sales, it is trying to throw it out. Similarly for Feb store, and it is again throwing out value. Jan, now Jan and store combination is done. Now Jan and sales combination is needed. So Jan sales combination is all sales value for Jan sales are given out here. So melting will definitely melt your data or mold your data based on all possible set of combination that you want to provide. It is very useful if you want to do kind of cross connections with your data. Then you can use the merge operations or merge values here. Then you can use the melting option here. You can also specify based on which value you want to merge. So basically, if you specify id of merge is that month, and if you specify value of merge, that is, say if I am talking sales, so now it will not consider, or it will not show me all the possible combination for month and store. It is just taking sales only. So for Jan sales all values, Feb sales all value. So that is it. Like, we do not have to worry much about it. So that is the best part of melting the data. Suppose if you have not arranged the data is not arranged in a correct way, in a consistent way. So in such instances, this can be very much helpful, and it can give us out a consistent format of data aligned. Now we will talk about summarizations of data, that is using pivot table. Pivot table is a very handy tool to summarize a huge structure of data. A very huge data can be easily structured with the help of pivot table. Pivot table we use directly from PD. We have the function or method into PD, and we have to specify based on what we have to arrange the pivot values. Okay, so the first approach we are going to do out here is we will take our big market data only. So df excel I'll take. Okay, this is our df excel, and we will apply a pivot table over this df excel based on January month. Okay, based on months. So based on month and based on all different values, so we'll use pd dot pivot table, and using this pivot table I have to just specify which data frame I'm talking about. So I'm talking about df excel. So I'm talking about df excel. Now in df excel, based on what I want to do the pivot action to be performed, I want to do it based on month, and I want to see the sales as value. So the next argument that we have is index that we have to specify and values that we have to specify. So index we have to specify as, say, month, and if I do like this, let's see what I'm getting. So it is not doing, it is not implemented error, because it requires summarization as well. So I need to specify based on what. So values I'll put is equal to say the sales values, sales of the column. Now if I'm not specifying any aggregated function, it is going to give me sales as you can see for month April, Feb and all this months. I can just simply remove this and let's see what we are getting. So it is fine, it is giving me sales, month wise sales. Let's try to consider the Jan March month, and if let us see if we have any 34377.6 values in Jan month. We do not have any such values. So ideally it is doing what, it is taking average of the Jan month sales, and we can also specify aggregated function is equal to so if you want to use say sum, so you can do it with the help of sum. It will give you sum of sales. If you want minimum, okay, so it will give you minimum of each of this. So minimum value for Jan month is 21080, and similarly for Feb we can see the 27 whatever the value it is, the minimum value it is going to give us 23 or something. So this is how the pivot table can be implemented. It is a very easier approach of arranging the data in a shorter version. Then we have we can see aggregated function we have used. Then we have something called as cross tables. So cross tables are similar to pivot table, but it computes a cross tabulation of two or more categorical formations. So let's understand what exactly this means out here. So suppose this is my data, it has categorical columns, that is car and color, and these are two categorical columns, and sales values accordingly. So if I want to do the categorical summarization with respect to color as well as car, and try to identify the sales value or the sum of sales value respective to the two categories, that is car and color. So we can definitely use the cross tab approach. We'll try to understand what is this cross tab here directly. So we will use pd dot and we can use cross tab, and we need to specify which data I'm talking about. I'm talking about the DF Excel, and here I need to specify two important ideal cases. So I want to see what I want to see in DF Excel, month and store wise sales. So I want to put month on x-axis or in the rows, or store in the column. So I'll put month in row names, and I want to put column names is equal to sales. So if I do it, you can see something is missing. I have to put it inside. Let me see. Okay, something is wrong here. PD dot cross and columns, it is asking columns. Okay, call names or columns, it has to be call names. Let me just do one thing. I'll put columns. And okay, we need to see the official documentation. Let's try it out. Index, it is asking row names, column names, it doesn't ask. Index columns, let me see the official documentation. Maybe there is some kind of changes they have done. Say we have cross tab. Okay, so we'll put index is equal to month and columns is equal to sales. Now we will talk about cross tab as another way of aggregating data using in Pandas. So basically we have seen how to aggregate the data using pivot table. We will try to understand cross table here. So cross table is similar to pivot tables, and it computes a cross tabulation of two or more factors. Here we have a data frame with different values such as car, sales and color, and you can see the data frame here. We will be using the old DF Excel dataset in which we had the customer detail and all. And if you want to do the summarization of data, so what we have to do in cross tab is, first we have to pass in the column that we are going to talk about. So the first column for summarization that I want to be it on rows is my car. So car will come on rows, color will go on columns, and row names I'm going to put it as car. Whatever name you want to put, you can put it, and color name, column names, that is color, you can put that name. And this is how the output is. So what it is doing is, it is going to give the count of cars and colors, because we have not specified any aggregated function. If you specify any aggregated function, so it will do the aggregation, but make sure that it has the values as well. So this is the syntax for aggregation in cross tab directly. So let's try to understand cross tab in our pandas data frame. So we will first of all do what we will call pd dot cross tab, and in pd dot cross tab I need to pass in two columns. So this is my df excel for which I want to create the cross tab. So I want to create month and store wise cross tabulation. So I will put df dot month as my rows and df dot store as my df dot store as my values. So these are the two things. First is on rows I want month, on columns I want store. And now I will put the indexes, or I want to summarize the data. So I will put some row names also. So row names is equal to, I want to put it as month. So whatever month I am just putting, whatever I am trying to put, or month names or something. And column names I want to put column names as stores name, something like that. And if we do the cross tabulation, now see what is happening. It is trying to take month from the column, okay, in this month table from the df okay, I want to put df excel, I have to put df excel, I'm taking df is a different data frame if you remember. So I'm taking df excel now, and now let's see. So it is throwing an assertion error, because there is arrays and names must have the same length actually. So there is a problem. So we'll do one thing, we will call ag func. So what I will do is, I will replace it by month, I will replace it by store to just reduce the space in the code part, and ag func I will put say aggregated, I am going to use mean as my aggregator, and values I am going to put it as values I want to put values from df excel for sales. So it is showing an error, that is assertion error. So this is my x, which is month, this is my y, which is store. We'll try to understand this error as well. So row names is equal to month, column name is equal to store, aggregated function is fine. So let's try to understand this assertion. It is raising arrays and names must have the same length. Considering df excel month, let me just see. Okay, let's see what is here. So df cars, here also car. Okay, yeah, this actually needs to be passed inside a square bracket. We'll do it. And column names is also going to be in the square bracket. And now it works. Okay, so the problem is it is a bit of complex syntax over here. First we have to pass which column you have to put on x-axis or on the rows, which column you want to put it on this particular columns, and this actually summarize the data based on aggregated of sales value. So whatever is the sales, it is taking aggregated of it. So the aggregation of April A sales for the store A is 26073. The mean value it is taking. If you put sum, so definitely it will give you some value of April sales. We can use minimum, maximum, and whatever aggregator we want, we can definitely use it out here. So this is the difference, like this is the difference between pivot table and cross tab. We need to understand. Now we will talk about data frame operations. So data frame, there are different type of data frame operations like checking duplicates. So here we have a data frame that is insurance data frame, and we can definitely read out this data frame and check the duplicate observation using duplicated method. What we will do is we will use the duplicated method to check the duplicates present inside a data frame. So let's try to add or we will use our own original data frame, which was dfxl, and into it I will just add some duplicate rows from the pre-existing data frame. So we will try to apply this over our df data frame. So let's try to understand it. So firstly, this is our dfxl, okay, and in dfxl you can see all different values are there. I will concat some information from the dfxl itself to dfxl so as to create duplicates. So this is duplicated values. I will just call it out as a new data frame. Duplicated values is equal to pd.concat, and inside it I will pass dfxl, and along with dfxl I'm just adding dfxl itself, but I will add few observations of it, and I will just add say first 10 .ilog, first 5 observation or something, or I'll do what, I will add alternatively two observations from, okay, I'm adding two observations, or I'll take a step of 5 and I will add, and I'll take all columns, and I'm trying to concatenate this based on x is equal to 0, and I'll just turn it off. This is my df duplicated. Let me see how does this look. And one more thing I have to do is I have to ignore the index as true, ignore index is equal to true, so as to avoid the indexing problem. And this is my duplicated values. So you may find some duplicated entries into it which is added at the end, like Jan, Feb, March, April, May. I have taken one observation from each of the month and added it as a duplicate. So this data will have certain duplicacies. If you see the, so if you see the first Jan A 21080, you can see this value which is repeated here. Then you will see Feb A 27573. So Feb A 27573, it is a duplicate. It is present in the row number 5 and also in the row number 26. Similarly, all these duplicates I have intentionally placed in my data frame. Now we will see that if there are how we can check out this duplicate data or the presence of duplicate data in a data frame. So assume that this is a new data frame that you have received from someone and you need to find out duplicates. So you can use the method called as duplicated, which will help you find out duplicates. So it will return true and false if the duplicate is present. You can see that at the end it is saying that these values are duplicate. So true, it is returning true for these last 5 values. So considering the value which is repeated next, which means, so this is the first value, occurrence of that value, and this is the second occurrence of the same value, which means second value is considered as duplicate. We can use a keep command to specify anything as a duplicate. So if I put keep is equal to first, so it will consider the first value as the original value and it will consider the next value as duplicate. If I put keep is equal to last, so it will consider the first occurrence of the data as duplicated and the last occurrence as the original occurrence of data. So this is the key difference between duplicates and duplicates. using first and last command. Now we will try to understand one more command, that is keep is equal to false. So this will mark all the duplicate as as true. So if I put keep is equal to false, whichever values are duplicate, it will be considering this as duplicates only when we put keep is equal to false. So even if this value, so this value is repeated twice, which means both the values are duplicates. Now if I am putting keep is equal to false, if I am putting keep is equal to true, only the value which is second, we do not have any true, we have option called as first and last. So if we put first, it will consider the first value as the normal value and the second value as the repeated value. By default it is first only. So that is the difference between first, last in a duplicated data. Now suppose you want to see which is that duplicated data, so you can call it out as a mask, and the value which is occurring first time is not a duplicated data. The value which is occurring last time, so the values 20 with the in row number 25, 26, 27, 28 are considered as duplicate. But if you put last here, so the row values will change, so the first occurrences of the data are considered as duplicate. So that is the difference between the keep is equal to first and keep is equal to last. So that we have seen keep is equal to false. Also we can keep is equal to false. If you put keep is equal to false, so all of the values are considered as duplicates. You can see duplicated keep is equal to we have to put false as a boolean value. So when you put keep is equal to false, so all the values are considered as duplicate, considering the 0th value as duplicate and this 25th value is also duplicate, 5th value is duplicate and this 26th value is also duplicate, 10th value is duplicate, and again this 27th value is duplicate. It will return everything as duplicate if you keep is equal to false. Now if you want to see the duplicates based on any two columns also, that is also possible. So say I want to check the duplicacy based on two columns. Okay, so now I will use my original data dfxl and I'll try to see that how many duplicates are there in this based on two entries, that is month and store. So or I will use my duplicated new data frame, duplicated values, to see if there are duplicates inside my this data based on a particular month. So I can use duplicated and inside it I can specify the columns for which I want to check the duplicates. So I can specify the name of the column, say age, gender, only these two columns I want to consider as duplicates. So I can put what I can put say month. So considering month, okay, only, so it will tell the first value is not duplicate, the rest other months are duplicate, because if you just see this data or duplicated data, so the first occurrence is considered as normal one and the rest other occurrences are considered as duplicate. If I want to see based on month and store, so I will hardly see these values as duplicated. So Jan, the value 25th index, the value at 25th index is considered as duplicate because it is repeated twice, here also and here also. So the second occurrence is considered as duplicate because by default keep is equal to first that we have kept. That's why it is considering the second occurrence as duplicate. So this is the key difference between duplicates using two columns. You can consider two columns for analysis and based on these two columns only it will consider duplicacies. So that is also a good part in finding and identifying duplicates in your data. Now you can drop the duplicates also. Suppose you have duplicates in this duplicated values, so you can drop it also. So you can use drop duplicates function and it will drop the duplicates. You can specify if you want to drop it for these two columns. So if any two values for are matching based on month and store, you can drop it based on month and stores as well. Like you can just specify it here And you can also specify which value to drop, like the first value to drop or the last value to drop. If you put keep is equal to first, it will drop the last value, and if you put keep is equal to last, it will drop the first value. So that is also available. You can just see the duplicacies have been removed, which means earlier the duplicates or df duplicated had value from 0 to 29, but right now I have 0 to 24 only, which means there are only 25 values, and the rest other are considered as duplicate and has been removed also from my original data frame. So we have seen this approach of duplicates and removing with respect to subset. If you can consider a subset based on which you want to remove it, so this can definitely help us. If you want to remove it based on a particular column that you can specify here. If you want to remove all of the occurrences which are duplicates, all of the things, like if it is repeated, any value which is repeated twice, repeat all of such values, you can put keep is equal to false. You can put keep is equal to first if you want to put or delete the next value or the second value, that is also possible here. Now we will talk about dropping rows and columns. We have already used dropping the rows and columns in a data frame. So we will try to use the drop method to drop the rows and columns from a data frame. So first thing what we will do is we will find out a data frame. So we tried reading a data frame yesterday, the one which we read with the help of the with command. So with command df zip, if you remember, let's open this df zip, and now we will try to do a bit of analysis over this data. Now let's try to understand the dropping of rows and columns. So what is this drop command basically used for? Drop command is used to drop the rows and columns that are not required for analysis. There are certain scenarios where you don't need certain columns, and you can definitely use your drop command over there. We can drop the unwanted rows and columns using the drop method, and however doing so does not delete the rows or columns from the original data from the data source. To remove them permanently, you have to put a command called as inplace equal to true, and by default the value passed to inplace is equal to false for safety purpose. If in case you by default run it, so it should not run it, or it should not remove from the data frame. So by default, if you want to remove it permanently from the original data frame, you can use inplace equal to true. So dropping can be done for rows as well as column. You have to specify what you want to drop. Okay, so let us try to drop certain values from your original data frame here. So this is our df zip data frame. So say if I want to drop something from this data frame, so I can simply pass an index. So I want to drop the indexes, say 0. Okay, I have to drop the index 0. So if I use drop, you can see it has removed the 0 index, and by default the x is equal to 0. If I want to drop multiple indexes, I can put like this, square bracket 0 and 3, 4, 5, 7, 8, 9, and I'll do what? I'll take this index as well. I will drop this index as well. So this index, and I will drop one less index. So I'm dropping last two indexes also. I'm dropping 0, 3, 5, 7, 9, 8 and these two indexes. Let's see how it actually goes. And when I do it, you can see the 0 is gone, 3 is gone, 5 is gone, and the last two values which were 827104 is also gone, and 827103 is also gone. So you can drop rows from this data. You can also drop values also from the data, like columns from the data. So for dropping the columns, you have to just mention the name of the column. Suppose I want to drop this ID mutation. So ID mutation will be dropped from this. If I run it, see, it is going to throw me an error, because by default there is no column, no row ID mutation here. So by default it is trying to drop a row. If you want to drop a column, you have to specify the axis equal to 1, and it will then drop it. You can see ID mutation is gone. And if you want to drop multiple things, you can just pass it inside a list, and you can just pass the names of it. um, say if I want to drop the date mutation as well, so I can put date mutation and it will drop it. Now even if I drop it, you can see that df zip doesn't show it in the data. Like in the data it is not dropped, it is still there. So if you want to make a permanent drop, you can put in place equal to true, that we discussed earlier. Any changes if you want to do permanently in your original data frame, you have to use in place equal to true. And then if I run it, and if you can see that now it has dropped from the original data frame as well. It has dropped from the earlier it was not dropped, but now you can see it is gone from the original data frame as well. So that is the power of using the drop function. Drop is a very essential tool to drop any values. We have seen how to drop indexes, we have seen how to drop columns, we have also seen how to drop multiple columns. Now we will talk about replacing values. How we can replace a certain values from your data. So here we can see there is a data out here with certain values, that is northwest is written, and we want to change it to north and space west. If you want to do such kind of cleaning process of your data also, so that is quite possible in Python using pandas. So for that, what we will do is we will switch back to our original data frame, and I will take df excel right now, not the one that we are talking, or right now this data doesn't look much of the consistent one, so I will just skip this data. We'll take df excel, and say I have this all data arranged in front of me. So I can also use replace function to replace certain values. So I can replace, say suppose, so I have to specify to replace what values I want to replace. I want to replace a, I want to replace b, I want to replace c. I'm just going to replace these all values in my data frame. So in my data frame the names are a, b, c, d, e. So I'll just replace these all, and I want to replace it with values. So you can see value, I have to specify which value I have to put. So for a I want to put say alpha, or okay, alpha, and store name, I'm just giving some store name, then I will give some name as star, second name as star, then I will give the same third name as galaxy, and fourth name as vision, fifth name as 1 2 3 4. I need one more name, and that is beta or something. I'm just giving a random name. So I want to replace these all values with this value. So I can do it in my data frame if I run it, and you can see it is replacing wherever the presence of a was there, it is alpha now. B, it has replaced with star, and everything has been replaced. So that is the change, that is the use of replace, very essential for data cleaning and sometimes for label encoding. But if you see that again, there is no permanent change to my original data frame. The permanent change is not happened. So in order to make a permanent data frame change, you can reassign it like this to the original data frame, or what you can do is you can use in place equal to true at the end. Like if you can put in place equal to true, so it will definitely make changes to the original data frame. And now if you run it, see the data frame name is same, and the changes has happened entirely in this data frame. So that is the difference using replace. Replace helps us to replace multiple values, single value. This is the syntax if you want to replace a single value from your data frame, and you can put that value. If you want to replace multiple value, this is the syntax. We have seen the multiple value syntax to replace certain values. And you can replace for a particular column also. Suppose you want to make or replace to a particular column. If I use directly the replace, so wherever it will see that like a is there, it will try to replace everywhere in the data set. So if you want to replace only to specific columns, okay, so df excel, if you want to replace in month only, say if it is month, from month I want to replace from month, wherever I see to replace is equal to say Jan. I want to replace this Jan with value January. So if I see Jan anywhere in my data frame, by default if I am running over the entire data frame, it will make changes in the entire data frame. But if I want only for a specific column, for any specific column I want to make changes for say a month, so in month I want to replace Jan by January, so that I can do using this proper syntax. So wherever you can see Jan, it is being replaced with January in this data frame. If you want to see it properly, you can have a visual like this. So Jan has been replaced by January. So by default this changes can be happened, but I am not making a permanent change in my data frame. So even though I have shown this, my data frame has not changed because I have not used the in place equal to true command. So that is the difference. So we have seen how to replace data frame in a particular data frame. Now we will also learn about inserting certain values in a data frame. So you can insert values also in a data frame using the dot insert command. Like suppose I want to insert a column. So this is my dfxl and I want to insert. So I can use insert command, and I have to specify in the insert command, I have to specify a few things like where I want to insert. So I want to insert at third position something. So this is my 0th index, 1st index and 2nd index. I want at one index. So at one index I want a column called as the name of the column that I want to add over here is okay, or cost or something. Okay, so I can insert a new column called as cost here, and I can assign some values. So say if I am assigning by default, if I am assigning some values like np.nan right now. So in my df excel you can see the value has been inserted, cost column has been inserted, which is having right now nan values. You can put np.array and you can get all the like if you want 25 values, you can put np.random.rand int if you use it, and say I want 25 values starting from 10 to say 2000 to 3000. I want say 25 observations. So that cost already, so now cost is already there, so I cannot insert it again. So that is the difference. So we'll skip this part, nothing to worry. You can use the syntax if you want to assign value at the time of creating or inserting a new column. So right now it will not run because cost is already there. This is the syntax you can follow. What we have done is we have inserted a new column called as cost here.
Recording stopped. Recording in progress.
So we have inserted a cost column, and we'll try to understand like the process of setting some values in this cost column. Say I want to change the cost or I want to wherever I see the cost as sales value is less than say 2 or less than 25,000, I will put it as cost as low. And if the sale is greater than say 25,000 or greater than or equal to 25,000, I'll put the cost as high. I just want to put such kind of analogy for this cost column. So let's do it. dfxl. So in dfxl I can use the loc method, and in the loc method first I will specify two things. First is the condition over here, so I have to create a mask first of all. So let me create a mask. Okay, so df xl if the sales value is less than say 30,000 for now. Okay, let's try to find out if the values for sales are in dfxl. It's not df, it is dfxl. So wherever the values are less than 30,000, I'm putting okay. I'll put it as low, and for the values where wherever the values are greater than 30,000 or greater than equal to 30,000, I'll put it as high. So you can see a lot of true and false out here, and this is my mask 1. Okay, mask 1. So what I want to do is, based on this mask 1, I want to see in my df excel this values. So I'll do it. So these are the values where we can see the cost is less than 30,000. So I want to put the sales. If the sales is less than 30,000, I'll put the cost as low. Okay, that I want to do. So I can use the LOC method, and in the LOC method, the first thing I will put as the mask as the condition. So if you run it, see, it is giving me the same output. And now I will specify which column to change. So I want to change the cost column out here. So wherever is cost there for this particular data, if I use C, if I run it, cost is right now returning as nan. So I want to put this cost as low. Okay, wherever I am seeing mask or wherever the mask value is true. So wherever the cost or the sales value is less than 30,000, I'll put the cost as low. And if you see this Excel now and df excel, you can see it is a combination of low and nan. Similarly, we can do it for higher values, and what we can do is, instead of less than, I will put greater than equal to. If it is greater than equal to 30,000, we will put the mask df excel mask 2. Wherever mask 2 is there, I will put it as high, which means if the in df excel, if there is any chance of having less than 30,000 sale, it will put it as low. If it is greater than equal to 30,000, it will put it as high. You can also see some nan values out here, like here for 23851, which has to be actually low. I don't know why it is high, despite considering it as low. Let's run this again. Mask 2. Okay, it is not happening for certain places. It is returning nan only because maybe the data is not correctly in the correct format out here. That is the reason it is not doing. Let's do one thing. Df excel dot is now. Okay. Or df excel, if there is a nan in cost column. Okay, this is my nan. I'll try to analyze this data here itself. So these are nan, and I will use this nan to see what all information is actually nan, why it is nan. So you can see cost is nan in this cases. So wherever in this data the cost is nan, I will definitely replace it with unknown. So let's use the LOC method dot LOC. Wherever nan is returning true, then put cost. Okay, cost is equal to unknown. I'm just doing and trying it out, and we'll do it. And wherever the nan is returning true, let's see if it is cost is unknown. So I have set the cost as unknown. So this is a method of changing the cost values based on a certain condition. You can change, you can put any condition as such. So right now these are not consistent. It is showing nan, so I have put it as unknown. So these are the two things. We have already applied this method of using nan. Now we will talk about grouping data frame. So grouping data frame is very essential in order to aggregate it. So in order to group the data set, we use the group by function. So group by returns a group by object, and it is this object describes how the rows are split. What are the aggregated functions that we can apply? That is min, max, agg, that can be applied to the group by object. If the group by returns a single columns of result, then the return object is a series, and if the group by returns more than one column of results, then we will call the return object as a data frame. So this is group by, very interesting group by. We will try to understand it. So one by one, it is used for summarization as well. So what we will do, we will create a group by instance, dfxl dot group by, okay, and we will group it by say cost column, okay, and let's say I'll store it in the gby as my instance, and gby, you can see it is a pandas core data frame for group by. Now what is this gby? So let's try to see what is there. So for I in gby, I'll print I. So it has multiple data frames based on the group. So I have a group that is low, high group, then we have low group, and then we have unknown group, okay. So we'll try to one by one analyze all these groups and see what exactly is this group by all about. So first we have this data frame for high, then we have data frame for low, and this is the third data frame which is for unknown, okay. So group by helps us to identify and understand more about the data based on groups, and the groups can be created based on the categorical column that you have. Now we can see different groups here. We can use group by to kind of get a particular group. So for example, I want to get unknown group, so gby has different function as well. So you can use get groups or get groups, and you can specify which group you want. So basically I want the unknown group, so we will specify that yeah, we need an unknown group, and this is the unknown group. Now we can store this unknown group as a new data frame, df new or something, or we can analyze this data frame separately. So this is my unknown group, that is df new, and it is based on only the unknown category. Now we can also analyze this data more in detail, like by using info or something, and understand what is the values inside this group by object, like this df new data frame obtained by group by. You can also use group by to summarize values. So if you want to find minimum, maximum or something like that based on this group, so you can use gby. So I can use gby like this, and I can use say min, or if I want to take minimum of say cost column, so I'll use or minimum of store based on cost, or if I want only the minimum, I can put minimum like this, and it will give me minimum for each of the column. If I want specifically for store, I can put store out here. It will give me minimum for each of the store, okay. So right now it is giving me low cost, low, high for the store, and this is how I can get minimum for each of the column. If I want only for store, so I can put store here like this, outside or before of it, and it will give me minimum of store column. So this is how we can definitely use aggregation using group by. This is the aggregation using group by. If you want sales, you can get sales value as well, like square bracket sales, and it is giving me high, low, cost, and sales with respect to the group cost, high, medium and low. So whatever we put in the group by, we can definitely get aggregation done for it. Group by can be used directly over a data set by specifying by based on which I want to group by the data and the column. So for example, I have this df excel data frame, and if I want to do the group by based on say store, so df excel dot group by, I can directly specify I want to group it by store, and I want to compute sales minimum value. Say I want to find minimum values based on store sales, okay. So sales figure for stores, If I want the output in this is the output that we are getting here as a list. Sorry, it is a series. So if we want the output as a data frame, we can just put it in the double square brackets, and the output is also in a form of data frame. So that is the difference in group by. We can directly use it also whenever it is needed. You can group it based on multiple columns also. For example, if you want to group by store as well as say one more value I want to put here. So I want to group it by with respect to store as well as month. Okay, so I can group it with respect to store as well as month. I have to just specify that new column. So first it will group based on store, and then it will group based on month. So alpha April, the total value is this. Alpha Feb, the total value is this. Like that, the minimum value basically we are trying to find. So right now we have only one occurrences, that is why it is giving a very long data frame. But this is how we can do multiple value summarizations as well. Now if you want to do summarization or group by based on a certain value, so you can group it by a certain value, and you can use the aggregation function like this to get a aggregated value. Okay, so for example, you want to put the aggregation of sum and minimum based on claim and blood pressure. So if you want to put two columns, you want to find the sum and minimum of claim column and then blood pressure column separately. So you can definitely use this method. We'll try to understand this method in detail. So in our case, we had a very simple data frame. We'll try to grab out a complex one which we have imported. So let me okay, let's take df excel. This is df excel, and in df excel I have 24 values. I will add a new column, say sales, and then I will call it out as rent or something. Say I'm also specifying the rent amount is equal to np dot random dot rand int. I'm just giving some numbers from say 45,000 to 75,000, and I want 25 numbers to be there. So I'm creating 25 observations randomly for rent column, and I'm creating a rent column here, and these are just a random values that I'm trying to generate. And let us try to group this data based on say store, and store wise let us try to find out sales and rent. So I will group it with respect to store first of all. Dot group by, and I'll specify that I want to group it with respect to store. Now we can use the ag function. So what is this aggregated function? Aggregated function requires a dictionary, and in this dictionary you can specify the key as the name of the column from your original data frame, and in the aggregated part in the list you can pass which summarization that you want to use here. So we can use ag, and inside this ag function I can specify a key. I want to do aggregation based on say store as well as cost. Okay, so I can do, sorry, I want to do this aggregation like we have done here for claim and blood pressure. So I want to do the aggregation based on sales and rent. So first of all I will put rent here. So rent I am putting, and the values that I want to put find out here is, so we are going to find out sum and minimum here. So right now I will find minimum and sum to keep a constant syntax, and along with that I can also summarize it with respect to sales. So I will use the sales part over here, and I have to mention which sales value that we have to pass in here. So I want again minimum and sum, not to do any disturbance out here. And when I run it, you can see for it is grouping with respect to store, and while it is grouping with respect to store, it is giving minimum and some value for rent. You can find minimum and max values as well based on whatever aggregator that you are interested in, and based on that it is giving you minimum and maximum values for alpha, beta and all, based on the rent as well as sales figures. Okay, so such kind of summarization is quite possible using group by and ag combination. So we have seen the group by instances. Now we will talk about missing value treatment. So what is a missing value treatment? Missing value treatment is very essential when we are working on any data, because whenever there is a missing value in data, it will add inconsistency to the overall structure of the data. At the same time, it will not give more information from the data. More machine learning models are also not accepting data frames or data structures which doesn't have any value into it. So it is difficult to do calculation when the entry is itself missing. So in order to deal with it, we have to do with some missing value treatment. So let's try to understand the missing value treatment in a data. So we can do it with the help of isNull function. So we'll try to explore all the functions. So say I am using df underscore zip as my data frame, because this data frame has a lot of missing values into it. So this is my data frame. I can do what I can use is null. Okay, if I use is null, it will return true and false wherever the null value is present. I can use is null, I can use is na, like both of it actually returns the same thing. It will return the same thing. If I want to count how many null values are there in each column, I have to put just dot sum. It will give me number of missing values in each column. You can see it is counting how many missing values are there in each column. There are a lot of missing values in this column. In all of this column, suppose you want to find out proportion of missing value. Sometimes we want to remove missing value from the data, or we just want to remove the data frame itself or the column itself. So if you want to remove entire column, so you need to identify what is the proportion of missing value in that column. So for that, what we do is we divide it by the shape of the data. So we divided by the number of rows of this data. So shape will give me the number of rows. Shape will have two parts, that is row and column. So I want the first part, which is row. That's why I'm putting square bracket 0. So it tells me, okay, what is the proportion of missing value in each of the data. I want to see the percentage of it, so I can multiply it with 100, and you can see it will tell me, okay, how much percent missing value is present in that column. So you can see value or foncier has 1% missing value, but address and numero and address suffix has a 37% and 95% missing value. So these are huge amount of missing values. Some columns has 100% missing value, which means these are not at all useful for any analysis. You can directly remove this columns by using the drop syntax. So this is how we can find out missing value. Now we need to see if there is any column which has missing value. So for that, we have df insurance, like whatever is the data frame name and the number of columns. This will give us all the columns, and in that, if you want to find out any missing values in that column, so let's try to see if there is like we need to find out from df zip which all columns has missing value. So we can use df zip square bracket okay, dot columns. So when I use dot columns, we will get the list of columns. So out of this, I want to find if there is any column which has missing values. So for that, the syntax is df name of the df data frame dot isNull and dot any. So I will use dfz and dot isNull. Okay, so if there is a isNull or any isNull values there, so it will definitely return true, and these are the columns which has missing value into it. Okay, these are the values which has missing value into it, and that basically helps us. So we can, if you want to see values which are not missing value, let's try this. And these are the columns which doesn't have any missing value. You can verify this column numero disposition. So numero disposition, that is 0% missing value. Nature mutation has 0% missing value. So if you use this tilde symbol, this is an bitwise negation symbol to negate all the entries. If it is true, it will return false. If it is false, it will return true. So this can be utilized to find out missing value columns if there are any missing values in any column, so we can use it. We can also use the approach of df insurance.isnull.sum greater than 0. Like if the percentage is greater than 0 out here in this code, then also it is considered as presence of missing value. So you can simply use greater than 0 here also, like it will return if there is a presence of missing value in that data frame. Now we'll talk about understanding how to treat this missing value first of all. So see, if you talk about this missing values in this data frame, so there are a lot of columns which has missing value. So we need to identify which all columns are greater than, like if you have more than 10-20% missing value, which means that it is of no use. Like if 20% missing value is also fine, but if it is more than, say if it is more than 30 to 40% missing value, we need to remove such columns. Okay, so if you want to remove such columns, you have to drop it. You can use the drop syntax to remove it. So you can visually see which all columns have missing value more than 30%. You can remove it using the same drop syntax that we have used. You can drop all of the columns at once also, based on your area or based on your understanding. You can put like this, greater than 40. So these all columns, wherever the missing value is greater than 40, you can just put a mask of it. This is a mask, and you can put, or you can just use this mask out here, and you can see it will give you all the columns where the missing value is greater than 40%. And if you want the name of the columns, you can put index out here, and it will give you the name of the columns which are having more than 40% missing values. You can directly drop these columns. You can copy this, okay, and you can simply use this syntax in the drop syntax, and directly also you can copy. So that is first approach of treating missing values. But right now we are not interested in treating missing value by drop method, because drop is a very easy method, and we can do it directly as well using your normal syntax of dropping or visual inspection. Now we will talk about treating missing value with filling it with some values. So you can treat missing value by filling it with say mean or any other value. So here is the syntax to treat missing value with mean value in a particular column, that is age. So say I have a numeric column out here, df zip. I'll take, so this is my df zip, and into this df zip I can see lot of different columns. So code commune, I'll take the column as code commune, and I will treat missing values in this column. So now there might be some missing values in this column, okay, like in this code commune you may see some missing values. So if you want to see if there is any missing value, let's see code commune, how many percent of missing value. It is 0%. Let's see something else where the number of missing values are less, that is surface terrain. We will take surface terrain. It is categorical, nature, culture. Let's take code type local or something. Yeah, code type local has missing values, lot of missing values into it. So we'll try to fix missing values out here. So we can use the fill na method. And what is this fill na? Fill na will basically fill this data with certain data that I want to pass. I can pass anything. I can put 100 out here, and it will fill missing value into it with respect to 100 wherever the missing value is there. I want to treat missing value with respect to mean, so I will put mean here. And as I'm putting mean here, I have to make this permanent changes in my data set as well. So I can use in place equal to true, and I will show that right now we have 0, 1, 2, 3 as missing values. And if I run this, let's see what is the change that going to happen. So I'm using fill na, and in fill na I am putting the mean, okay, of code type local. So it will fill the missing values with mean or the average, and it will replace in the data frame itself originally. So it will put I'm putting in place equal to true, and when we run this, you can see that the wherever the missing value was there, we are getting average 1.9796227. So this is how you can treat missing values in a data. Now we will start with a new module on data visualization. So visualization is a very important part of analysis, doing any exploratory analysis. So here we are going to use data visualization using Python. So at the end of this session we will learn about Matplotlib as a library. We will learn about plot styles and settings, what is line plot, what is multi-line plot, what are subplots in Matplotlib, what is a histogram, what is a box plot, pie chart and scatter plot. So we will try to understand each one of this in detail and get into how we can apply it for analysis of our data. Now data visualization is an important part in analysis. It is used to represent the data in pictorial or graphical format. First step of data analysis is visualization. Always it is the visualization that we are going to start with. It allows us to get the intuitive understanding of the data, how actually it should be, the data visually appears, and it helps to visualize the patterns if there are any in the data. So visualization using Matplotlib. So we have a library called as Matplotlib, which is used for visualization purpose. Matplotlib is a very useful and powerful library. It is also a basic library, but it has more. It is more effective and easy to use. It helps us to create graphical representations of data in Python. So, Matplotlib is a Python's 2D plotting library, and it is usually in the PyPlot sub package of Matplotlib. We will find all the visuals. It provides a MATLAB like way of plotting, and it also provides a simple way of plotting the various plots like bar plot, histogram, scatter plot, all these different kind of plots we can plot here. It is also useful in plotting hierarchical structure that nest Python objects to create a tree-like structure. So plots in Matplotlib have hierarchical dependency of data. Like it will have, first we will create the chart. We can have multiple layers of charts on it, or multiple layers like title and all of it in hierarchical structured way. We'll try to understand it in detail. So if you have not installed Python using Anaconda, if you have not installed Python on Anaconda or Jupyter Notebook, if you are working on some other web browser like some other Python IDE directly on Python only, so you have to install it on the using the command conda install matplotlib, or you can use the pip install matplotlib to install. So we can install Matplotlib using conda or pip command on your terminal. So if you have if you are using Anaconda, so definitely you don't have to install it. But if you are using it on some other web browser, you need to install it using the pip command, which is given here. Now we will talk about like if it is in Jupyter Notebook, you want to make the installation, you can use the factorial symbol like we have done it for NumPy and Pandas, and that also allows you to import or install. Now when you want to create visuals using Matplotlib, so at that time you have to import Matplotlib sub package, that is PyPlot. So we are not going to import Matplotlib directly, we are going to import the sub package which is PyPlot, which will enable us to create visuals. So here we can see a different set of like this is the anatomy of a Matplotlib chart actually. So this particular thing that you can see here is an title in Matplotlib, and title usually is at the top, as you can see. Then here we have major tick, this is the major tick, then you have minor tick, then again this is a major tick, this is a minor tick, major tick, minor tick, like that. Then you have y-axis label over here, so this is your y-axis label, again minor tick label for x-axis, major tick, minor tick, major tick, minor tick. So these are ticks basically indicating the data on y and x-axis. This is the label y-axis label. This particular lines that we are talking here are grid line. this portion which line represents what, it is a legend. Then these are the two lines of that plot based on data. These circular parts are markers. You can use different set of markers in a Matplotlib chart. So this is how anatomically a Matplotlib chart is actually there. These are different components of a Matplotlib. It's very clear to understand, and slowly you will get to know what exactly these all refers to. So now we will talk about different charts that can help us to create a plot. So we have plt.plot. Plt basically is a instance of pyplot. So we can use plt.plot to create a plot. Plt.show is to explicitly command required to display the plot object. So whenever we are whenever we are creating a chart, so suppose I have created a chart, show will be used to display the output, which means it will close the canvas of your plot. So whatever is the plot you have started, it will end that canvas. Then plt.x label, y label, these are basics to put labels over your x-axis and y-axis, and plt.title is used to put title on top of your chart. Now we'll try to understand about plot styles and settings. So the style package adds supports to changing the plotting styles. So you may have different plotting slides as per your convenience. There are number of predefined styles, okay, and to see the list of predefined styles you can use plt.styles.available. Let's first get started over Python Jupyter notebook, over our Jupyter notebook, and let's see what all styles are available. So first of all, I will import the libraries. So here we are going to start with Matplotlib, but before Matplotlib you will require data to get this imported, okay. So we will import NumPy as NP, and then we will import Pandas as PD, and then we will import Matplotlib dot pyplot as plt. Now let's understand. See, if you want to plot anything, first you need data. So that is why these two libraries are needed for handling data or creating data. Now we will talk about plt. Plt is an instance of pyplot which is there in Matplotlib. I cannot keep on typing matplotlib.pyplot every time I want to create chart. Instead I will use the alias that is plt. And here as we want to print all styles available, so we will use the plt.styles, plt.styles dot available, okay. If we run it, let's see. So it shows that solarize, light 2, classic, test patch, MPL gallery, MPL. So this is Matplotlib gallery, no grid, classic, dark background, fast, 538, and all different types of plots or styles are there, which is available here. Now we will talk about different components of a Matplotlib chart. So you can see this the list of styles that we can see here. So if you are using a Seaborn dark grid, so you can use any kind of grid, any kind of style by simply using plt.style.use, and automatically all the charts that are going to be followed will be follow the Seaborn dark grid style for creating this chart. Now you can see different multi-line plots. So here is the multi-line plots, here is another version of multi-line plot, and this is another. So these are different with respect to different line styles or different plot styles. So Matplotlib enables different plot styles for visualization. Now the Matplotlib also has RC params that can be used to set the global parameters, global settings. So matplotlib.rc command can be used to modify multiple settings using keyword argument. So you can use how you can do the customization on this clicking on this link. You can simply go on Matplotlib page and you will find customizing.html in Matplotlib, and you will find what all different RC parameters are required to customize the settings. So Matplotlib also requires, you can set RC parameters like what is the lines width that you want to specify, what kind of line style you want to keep it consistently throughout your charts. Matplotlib .rc lines, and what is the line width and line style. You can use it multiple parameters at the same time. So we will try to set these parameters in our Matplotlib as well. So for that, let us import. Now we have imported matplotlib.pyplot as plt. We have not imported matplotlib as mpl. So we will first import matplotlib as mpl. Now we will set both the parameters mpl dot. Okay, we are going to set some global rc parameters. So I am going to set mpl dot rc, and in the RC I am putting lines, and the lines that I am putting, the line width is equal to 4 and line style is equal to dot like this. So line width, let's put 4. So line width we are putting 4, and line style we are going to put the same that is it is given. So line style, so we have set the line width and line styles for our chart that we have to create. You can use the above two for setting the respective line styles which is given here. I am using the last one to set the respective line style. Now we will start with the plotting. Now we will start with the plotting of line plot. So line plot is a simple graphical representation of data where we create a line by connecting each and every data points, and try to establish a relationship with the data points with the help of a line. So we will use np.arange. We will create a data set first of all, and then we will use the plot method to create a plot. So first of all, let's create a data set. So let's take indexes, or say months. I'll take months is equal to np.arange 1 to 12. I'll take 13 because it will just show me 13 values then, and these are my months 1 to 12, and I will put 12 values as a list. I'll create a list of 12 values, and we'll try to plot this over plot option. So let's put it as sales, and okay, so I'm putting starting with the value 100, and here 200, then 103, then 204, 105, 60, 107. I'm just putting randomly some values, 208, 09, 120, 211, and 312. So this is our data. So this is our data, sales as well as monthly data. Now we will use plt, matplotlib.plt. So plt dot we will use plot. Okay, and in this plot I will mention two things. What first is months. So I want months on x-axis, and I want sales on y-axis, and I want to first of all let's see what kind of output we are getting. So this is the output that we are getting in a form of line plot. Now I am getting a very dark kind of line because I have used the line style as this. So I can change the line style line like this, and I can put line style like this, and if I do it, now changes in the line has happened. Okay, so it depends on what kind of line width you are specifying. You can put 1 here, and then you can get different kind of line. So I'll put 1. Now plt.plot month and sales I have put, but you can see there is a message which is a list of address of this chart. So whatever chart we have created, there is an object created at this memory location. And now let's try to understand this visual in a very detailed way. We will set the color and marker also for this chart. So I'll set color So color we will put it as say blue or say green or something. And marker, as we know, marker is equal to, say if I am putting O. So if I am putting O, the marker is becoming like this, and you can see it is a chart, but there is no label as such. So I can put plt dot x label, and on x label I can put months, and plt dot y label I can put on y axis, I can put say this is sales or something. So you can see the labels are also getting added. I can use plt dot title to get to put some title on top of my chart. So I want to put a title indicating month versus sales or monthly sales. So plt dot title, I am getting monthly sales. See, my canvas is still open out here in my kernel, so I will just close it by using plt.show, and the canvas is closed. Now I do not see any message out here, and now we can clearly see a chart which shows me different information of month-wise sales. Now see, I can also change this marker to say star or something, and accordingly the star will become the marker. You can put something else. We'll try it out if it is working, because there are limited markers that we can put. You can see limited markers, it creates a triangle, upper triangle, and if I put some percentage symbol, if I'll just see if it is working. There might be a marker available or not. Yeah, there is no marker for percentage symbol. Yeah, but there are some basic markers which are available. You can use. Hash is not available, O is available, so I'll use O only. So whatever markers are there, you can definitely use it. If you want to see what all markers and what all details are there, you can click here and as shift enter, and you can get all the details out here for different parameters, like what all values you can put for each of the parameters. Like for markers, what are the line style, whatever you want to put, you can put it here. Now this is our PLT or plot that we have created, the first plot, which is a line plot. Now we have already added the title, so we see how we can add a title. So in that function title, we have to specify textual information only as a string in double quotes. If you put something else without double quotes, it will not take it. So it requires string output only. You can also put x label and y label, as we have discussed, and x label and y label also expects string input only, then only it will show us the information. Now there is an additional command, that is plt.grid. So what is this grid? So grid, let's try to explore the grid in detail. So grid basically is this square box which is there in background. So we can use grid, we can use the line style as per our requirement, line width as per our requirement, and color as per our requirement. So let us try to create this grid option as well in our Matplotlib chart. So let's add a grid, plt.grid, and inside this, if you put a grid empty, so you will get a grid like this. But if you want to change the style of the grid, so you can use a lot of different things are there. You can use line styles. So line style, you can specify you want like this or something. Okay, so you will get the line style like this. You want to change the color, line, if you want to change the width, so line width you can use is equal to say 1 unit. If I put, so I'll get line width like this of 1 unit. The width has increased, you can put 0.1 and it will get a very fine line. So based on whatever you want, you can put that line width. I am putting 0.7. And then color, you can also specify, say if you want the background colors to be orange. Let's see if it is available. So orange color is available. You can see the width. So grid helps us to, so grid can help us to track the data points with respect to x and y coordinates on a perpendicular axis. So we can specify grid also as per our requirement. Now we'll try to understand about multi-line plot. So For this we will take the insurance data that we have. So let us get this data. Now this data is already there in my drive. You know already how to import this data sets. So this is okay, insurance.csv. So let me Control F. Let me name it as insurance.csv. I'll use the same name, and this is our data frame df. Now let's try to create a visual around this data frame. So we will first of all, what we will do is we will group the data with respect to day of month. So df, where is the, yeah, so df will group it by day of month. So we have grouped the data with respect to day of month as it is asked, and we will try to find out unique days from this data. So df, whatever is our data, group data, we will find out the unique day. So for that, first of all, we have to store this into a group by instance. So I'll create a group by object, and from gby so from from gby we will try to find out day of month values. So gby will put day of month. Okay, we need to run it. Day of month, so it is giving day of month dot, we want unique values, so we want unique from day of month, so it will give us unique days. So these are the unique days from date of month. And let's try to create a chart using this style Seaborn dark grid. So we'll use this style to create this chart. So let's try to understand first of all what is happening here. So first we will read the data, CSV data, group by the data that we have already done, group by the data with respect to mean values, and for each of the days, day wise mean we are going to find out, and we are going to plot day wise mean or average scores for age, BMI and blood pressure for each of the data. So we will first group by the data with respect to the means and find out means and store it day wise mean, and we will find out and put age, BMI and blood pressure in a single plot. Now see, we are trying to put multiple lines plots in a single chart. Okay, so we are using multi-line plots, so that we can do here simply. So let's clear it out, and let's try to create a chart. So let's do one thing. So GBY is day of month, and we are going to group by with respect to day of month, and we'll first find out mean. Okay, we are going to apply day of month wise mean. So for that we will use group by instance and day of month. Day of month. So it is giving us mean with respect to day of month. So let's try to understand first of all. The line style will create plt dot plt dot style, and we are going to use. So first of all, let's get all the line styles that are available. So we are going to use Seaborn, whatever Seaborn dark grade or any kind of 538 or something. Let's use 538 for our use case. So we will activate 538. We don't know what is 538, and then we will start grouping the data with respect to the information. So we have grouped the data with respect to day of month, and we are going to find out days with respect to day of month. So days is equal to GBY day of month. So we already found out GBY day of month, and we will find mean of it. So if you see days, it will have days of data and month wise information like day of month for each of the data. So now we have already used day of month here. Now we will use plt.plot to create chart based on this analysis. We will use the plt.plot. We are using multi-line plot over here. So let me just use all of this code here. plt.plot I am going to use for months, days. So on x-axis I want to put day of month, so days I will put, and on y-axis I want to put on days I am putting, and on y-axis I am using group by age and mean. Okay, so we are going to group it by whatever is the group by, and I am putting age and mean with respect to age. Let's draw it. So you can see I have changed the 538 as my line style or style of chart. Now this is with respect to age. Say I want to also put it for color, I will put blue, and I want it for BMI or something. So we can create it for BMI as well. So you can see two charts are there based on this, and you can also have another charts, like we can also put BMI we have already put, and we can also put another date information. For example, I'll put blood pressure or something. So let's put blood pressure. So ideally it should not happen, like you cannot put all these things on a single scale. On x-axis something is there, on y-axis something is there. So we cannot put, but this is the way to create multi-line plots. So that is what we are exploring here.
Recording stopped. In progress.
Additionally, if you see that it is not quite good to compare month, like these different charts, you can see one is blue, I have to change the color. So I'll put red or something. So these are three different colors, but how a person who is trying to see your chart will understand what does this red line indicate, what does this blue line indicates and all. So for that, what we can do, we can put label is equal to, so suppose this is age, so I'll put label as age, and again here if label is equal to and we can put BMI. So here is BMI, and label is equal to we have to put blood pressure, and even if I run this, it will like it is quite obvious it is not visible because we need to put legend as well. So we will put plt dot legend, and according to the labels that we have given, it will identify the legends, and that's what, like you can clearly understand blue line indicates what, and red line indicates what, and green line indicates what. It is not good to actually represent three different features which are on a different scale to put it on a single chart, but yeah, this is how we can use line chart for sure. multi-line chart for sure. Now we will talk about using multi-line plots. So we have okay. So we have used multi-line plots here. Now we will talk about using each, like if you want to use each line that represents day-wise average claim by gender. So for that you can use chart only for that specific information. So we can group the data with respect to different information. So here also what we are doing is we are grouping the data with respect to day of month and gender, and we are going to find out mean of claim. Okay, so it will group the data with respect to day of month and gender, and the values that we are going to get on y axis are with respect to the claim, the average value of claim, and that we are going to use and that we can plot using the plot on the function. Now we have a plot function as well, which is used to create charts. So let us try to create this chart. So we will use subplots. Now what is subplots? We will try to discuss it in later after in the upcoming session. We are going to discuss it in the upcoming slides, but let us try to talk about subplots, and we'll use it for now. So fig comma ax is equal to plt dot subplots. We'll discuss subplots in detail, and say in subplots we have to mention what is the figure size, that is 7,4. So we can use fig size is equal to say 10,8 or something, and we are going to create a chart for data. And right now we are going to use style of ggplot. So we will use plt dot style dot use, and we are going to use ggplot. Okay, and now we will arrange our data based on how we are going to want it. Okay, so we want to group by the data with respect to day of month and gender. So we will use our data, which is in, so we'll use this arrangement of data only here, but here we are not going to group it with respect to day of month only. We are going to use gender as well. So we are grouping out the data with respect to, we have created this plt dot size, and we have created this figure. That's why we are getting this empty chart as such. So we have grouped by the data with respect to gender, and now we will try to find out the mean with respect to claim. And now we are going to get the mean with respect to claim. Okay, we have already grouped by the data with respect to day of month and gender, and this is our group by instance dot mean claim dot plot area. We'll see not implemented error. Let's try to understand what is this error about. Okay, we will try to understand our DF first. So claim has certain values. We are going to group by with respect to gender and day of month. Day of month is here, gender is here, and we are grouping by the entire data with respect to this. So let's understand this data frame. एक second.
Recording stopped.
Now we will talk about subplots in Matplotlib. So let's try to understand subplots. So the Matplotlib subplots methods provides a way to create one or more subplots in a figure in a single chart. When number of rows and columns are passed inside it, it returns a tuple of figure comma axis. Figure comma axis represents a single figure and arrays of axes, that is which all axes, what all chart that you want to create. The figure is used as container to hold all the subplots, while axis basically represent a single chart within a subplot. Basically, if it is a subplot, it is a combination of multiple axes and each axis will hold some kind of charts on it. So here we can see a simple example of figure comma ax or subplots. So we will create a subplots for our data, or based on the data that is given in front of us. So for that, simply what we are going to do is we will call out figure comma ax is equal to plt dot subplots, and we are going to pass in the size of the subplots. So subplots is of size 2 by 2, so we are going to create 2 by 2, and we will try to create so you can see a grid of 4 by 4 or 2 by 2 is created. Now over this grid we will create chart. So first grid, this represent 0 and 1, and this represents 0 and 1. Now let's try to create chart one by one on each of the grid. Okay, we can create any chart over each of the grid. So we will use our insurance data, or let us use this insurance data, and we will try to create day of month. We'll create a chart of day of month and claim. So we'll group by the data with respect to day of month, and we'll create claim average claim with respect to day of month. So group by, I'm going to group it by day of month, and we are going to use claim average. Okay, we are going to create claim average. This is our group by data. So average claims with respect to day of month we are going to create, and we will try to create chart with respect to the same. We are not going to use the same data set which is given here. We will try to create different versions of chart on it. So this is our data. We will use plt dot plot, and on plot we will use the index of group as x-axis, and we are going to use group value as y-axis. Now if I try to draw it, see a single chart is created on this final axis, which doesn't look good. So what we will do is we want the first chart over here, second chart over here, third chart over here, and fourth chart over here. So I want to place this on 0 0 axis. So I'll do it with the help of ax. Okay, and on ax I have to specify the axis. So 0 0 is my axis, so my chart is positioned on the first. Now if I want to create chart on 0 1 axis, so 0 1, and right now I'll not take group, I will take square root of the group values that we have received. So this is the square root chart. We can also use, if I want to draw it on 1 comma 0, which means the third chart, so I can put like this, and I'll take square of this values. So I'll take power as 2 or something, and you can see the square of the values is here, and we are not able to see any distinguished difference. So what we will take, power 4 of this data, and over axis 1 comma 1 I want to create. So this is the chart we can see. We can give different colors for each of the chart. So if you understand clearly that subplots enables us to create a multiple charts in a single unit, all you have to do is just pass in the set of values or chart, whatever chart you want to plot, you can plot it. You can use scatter also, like scatter plot if you want to create. Definitely you can use scatter plot like this. So last one is the scatter plot which comes on the last axis, and finally you can use plt dot show to stop the show, and it will basically show you the chart. Okay, so this is the peculiarity of your axis. You can define whatever axis you want to put. You can if you want to specify some text for a specific axis, you can just put the name of the axis, and on that axis let me put on that axis we can put dot text or something, or we can use, or suppose if you want to set title dot set text, you can use dot title, and you can give any name, and you can give that name will be set on that particular axis. So whatever axis you want to set, say any title, you can accordingly give names to each of it. Now we will discuss about a chart, that is histogram. Histogram is a very important chart in analysis or in creating visuals. So let me create. Histogram is used to represent a distribution of numerical data. It is helping us to estimate probability distribution of the data, as well as it is used on a single axis. So we will try to use histogram. So each the histogram is a systematic representation of bars indicating how many times a particular value is repeated. So it is also called as frequency distribution chart or frequency. It is derived from the frequency distribution table. So here we have a distribution of histograms. So we will create an histogram here so we will copy the chart for this chart we will copy, and we will place it here. We want to create a histogram, so we will call plt.hist, and all we have to pass in here is df, say claim. I'll put claim into it, and we want to create a histogram. Over here we do not need marker because histogram doesn't require marker. Color we will specify, and I don't want grid also, I'll remove it. So you can see the histogram is created and it shows the data accordingly. Now histogram basically helps us to show the numeric representation of data, and that is what we are getting. You can specify any color like this, and accordingly the color will be changed, and that's how we can create histogram. Now I am getting grid because I am using the ggplot visualization axis or style, so I can change the style. We can use any style that is there, like classic also we can use, plt.set titles, and whatever like set style, you can set whatever style as per your understanding, you can create it. Now we will talk about histogram in detail by understanding few components of it. So histogram has certain components, that is x limit, y limit, x text, y text, x label and y label. Now each of these are important to create chart. So first of all, suppose I am creating a histogram for insurance data frame and for claim information. So we are creating information, we are creating an histogram, that is fine. But what if I want to set the limits? Right now it is by default taking some limits of x and some limits of y, which is accordingly by default it is taking based on the values which is given. But what if I have to specify certain limits like lower limit and upper limit on my axis? So that also we can do with the help of x limits, and similarly you can do it for y limits. But right now in histogram we do not read y limits. We also have something called as x ticks and y ticks. So x ticks and y ticks basically helps you to create this chart ticks. These are the ticks that enables us to clearly see what kind of information is there. So these are x ticks and y ticks, and then usually x label, y label that we are definitely using. So let's do one thing. We will modify our current histogram accordingly. So we will use plt dot xlim, and I will remove this labels as of now. X label I will put claim, and this is count. Okay. On X limit, I want df claim minimum value, because right now 0 is the limit, but I want to put minimum value as the my X limit. So dot min and df claim dot max, okay, as my X limit. So you can see the X limit is starting from 0 and maximum is maximum value. Similarly, you can have Y limit, but I don't want it. We can have X ticks and Y ticks. So what is this X tick? So plt dot X tick, suppose I want. So plt dot X ticks, I can we can have X ticks as per our requirement. So you can specify the font and color of the X ticks. So we will specify the font. Font size we can specify is equal to say 2 or 14 or something, and we will specify the color. Color is equal to say blue for this X ticks, and there is some problem, we do not have color. Okay, so color of this X ticks has become blue, and this is similar to that. We can use Y ticks as well. All you need to do is you just have to copy this and you just paste Y ticks, and Y ticks you can give color red or something, and you can see the Y ticks are coming in red, and you can see a colorful chart is being formed here. So that is some specialty of histogram. You can use a histogram as a multi-line chart also. So for that, what you need to do is see. So the simple method is by using df insurance.hist, you can directly use histogram like this. It will automatically create histogram for different numerical values or different information into it, or you can use GCA, that is get current access, and into it what you have to do is you have to create figure, and we have to create access. Access is equal to GCA, which is get current access, and df insurance.hist, if you put AX is equal to the access withdrawn from the figure dot GCA. GCA will automatically create your chart like this. So these are the two methods. So we'll try to do a histogram for all of the data which is here. So let's do it. So we'll create df.hist. So if we do it, you can see multiple histograms are created. Now what happens with this histogram is you can see what are different histogram values are there, but what if we require a specialized kind of analysis or specialized way by using GCA, where we want to also locate the axis of this charts that we have created. Maybe you want to customize the axis. So in that case, what we can do is we can use figure comma figure is equal to plt dot figure. So we are using plt dot figure to create figure of fig size 8 by 8. I'll create 8 by 8 or 10 by 10. So figure size we are specifying. Axis is equal to fig dot GCA we are going to use. GCA allows us to create axis. Now I can utilize this axis for some specialized analysis that I want to do. So we will use the same chart df.hist, but axis that we are going to specify for this histogram is going to be the axis that we have drawn from GCA. So axis is equal to axis, and then finally plt dot show to see and visualize the chart. And now you can see a very clearer chart we can create, and now we also know the axes. Here we have not clearly understood the axes, but here we can definitely know what all axes are there for our chart. So these are the two methods by which you can create multiple histograms in a single sheet, and you can compare it. Okay. Now we will talk about box plot. So box plot is a very important tool to visualize your data, numeric data, to understand the distribution of data. It gives us different values such as minimum, maximum, quartiles and median value, how it is distributed across. It also tells us about outliers, if there are any outliers in the data. So let's try to create a box plot, a basic box plot on BMI. So let's try to create a box plot. So as you can see the syntax here, in the syntax first plt.boxplot is a function which helps us to create a box plot, and we all have to do is just simply pass the name of the column. So we will simply use this same histogram code here, and I will just put it here. I will remove xlim, ylim and all of it. I will remove x label, y label. All I have to do is box plot of say claim, and that's it. This is histogram basically. For box plot I have to just write box plot, and that will do the work, and it doesn't require color argument because box plot is a box basically. So here as you can see it is creating a box plot for claim. We do not see much over here, so what we will do is we will change the style. Let me just change the style. Okay, so df claim doesn't allow us to create much of the box plot. We will do what? We will create insurance. From the insurance data frame we will use BMI or something. So yeah, BMI, it is giving me box plot. Why it was not giving for insurance? Because the data was left skipped, or maybe there is some problem with the system. But let us try to understand with this box plot for this BMI column. So for BMI the values are, the lowest value is somewhere close to 15, or the lower quartile or the lower fence, and the highest value is more than 55 or something, and the upper fence value is close to 46, 47, the lower fence is 14 somewhere, and this is the upper fence value closer to 45, 46, and these are all set of outliers which we can see on the chart, and this orange line indicates the median value, and this box basically indicates the distribution of our data. So it's a very simple chart to create visual, and if you want to use show flyers is equal to false to view a box plot without outliers. So if you want to exclude the outliers, you can put show flyers is equal to false. So let us try that as well. So we will put show flyers is equal to false. So now you will not see any outlier, you can see data without outlier. So we need to see outlier, that's why we have to remove it. Okay, so outlier is the only thing why we are drawing this box plot. So if you want to compare multiple box plot on a single unit, so you can definitely compare it by simply calling in that data in our as an extra additional argument. So it is not claim, this is BMI. I'll change the title, and suppose I want it for BMI as well as say age or something. So I'll put the age over here, and it will give me outlier for BMI as well as age. Okay, there is some problem, let's see. So box plot for BMI and then for age, and we are going to use the same approach. We are going to use the same approach which is here. All we need to pass in is this two values in a single list, and now you can see the both of them on a single scale. Like the first part is our BMI, second part is age. Now if you want to give x ticks, y ticks also here, so you can give it according to the x ticks which is given here. So we can use plt.xticks, and we can definitely pass in the ticks based on the data which we are giving here. So the first tick is for a claim, and the second tick, first tick is for BMI, and the second tick is for age. Let's use it. So you can see BMI and age are also, we can give it with respect to this X ticks.
Recording stopped.
So we have seen how to create a box plot and multiple box plot on a single frame. Now we will talk about bar plot. So bar plot is a visual where we can represent the categorical data as the bars, and the length of the categorical data can be any aggregated value proportional to that bar. So proportional to the bar size we can have the aggregated value. So here we can create an bar chart for visualizing the smoker versus non-smokers in our insurance data set. So we can use this bar chart, we can use horizontal as well as vertical bar chart as well. So let's do one thing, we will create a bar chart using so we will first aggregate the data. So this is my DF. I want to aggregate the data with respect to say gender wise blood pressure I want. So DF dot or I want gender wise count of people. So DF dot gender dot value counts can definitely give me the count of gender wise values. So I can store this information as X. Now this X represents two things, these indexes and values. I will use this indexes and values to create a bar plot. So right now we are using the bar method, dot plot method, which is a pandas plotting method. So we can use dot plot x dot plot, and inside it I can just mention kind is equal to bar, and it will create a bar chart based on number of male and female. This is the first method to create, and we can use plt.show, and you can add title and whatever you want to create this chart. The second method that we are going to use is by directly using plt.bar method. So we can also create bar plot by using horizontal. We can create the bar plot like this, which is vertical. You can create horizontal bar as well. So you have to just mention bar h over here, and you can get the horizontal bar where the size of this bar is proportional to the number of female and number of male which is there in our data. So these are the two methods by which you can create bar chart. Now we can also we can create horizontal bar chart, then we can also create a bar plot using PLT. So using plot Matplotlib also. So that is what we are going to study, plt.bar, and inside it I can put on x axis I want the name of the people, so x dot index I will put, and on y axis I will put x, and this will create a bar like this, and I can add a lot of different things like title and all, you already know it. So I'm just going to skip it. This is our bar plot, a simple bar plot. We can add a lot of different to this bar, a lot of details to this bar plot also. So this is a very simple approach of creating a bar plot. Now we can also use bar plot like this, like stacked bar plot also. Before that, let us draw a horizontal bar plot. So plt.bar h, we can try it out, and all we have to do is reverse this, because on x axis now I will have x values, and on y axis I will have x dot index. Let's see. So this is the horizontal value. So I have to specify x is equal to something, and on y axis I have to specify height is equal to x dot index. Let's see. Sorry, width is equal to x dot index, and y is equal to x as the values. Sorry, y is equal to x dot index we will put, because this is an horizontal one, and width is equal to x. So this is the method to create horizontal bar using PLT or Matplotlib. This was earlier which we used the Pandas internal plotting, and this is using PLT we can do it. Now we can also create chart which is stacked column chart using this approach. So suppose I have two data, that is Python marks and R marks, and I want to show this as an x-axis or using a bar chart. So what we can do is we can create a bar chart like this. So let's try it out using this. We can create this column chart to compare the Python and R marks. So for that, let us create a bar chart. Or let us first do one thing. Let us do it over our data set itself. So this is our Python marks, this is our R marks. We are using plt.bar, and the index has to be same for both the bar charts. Height is equal to Python marks and width is equal to 0.35, and similarly we are doing for the another one which is for R. So these are two different things. Only thing is we are going to take the indexes of this chart starting from 0.35. So let's create this bar chart out here. So df is our data, and what we will do is we will compare two values for our df. So here it is numerical information. So I will find out first of all df dot group by. So first is our x, which we already have calculated. So gender wise count, and I will create y, which is df dot group by, and I want to group by gender. This is our df, we are group by gender, and I want gender wise suppose claim. Okay, so I will create gender wise mean claim. Okay, let's see how does this y look like. So on x-axis I have gender wise. Okay, I'll do one thing. I will use, this is for sum or minimum, this is for means of claim, and I will take medians of the claim. Let's see if median works out here. So median claim values and mean claim values, and we'll create a chart for it. Okay, so we will use the same approach that we have used. So plt dot bar we will use, and on x-axis I will put mean dot index, and on y-axis I want the size of the bar or the height of the bar. I'll call height is equal to mean. Okay, so this is my first chart that I am going to put, and width we are going to specify it as width. So if you remember, we have created the bar width out here. So if you remember, bar width is given as 0.35. So we will give the bar width as 0.35. So bar or width 0.35, and label we will put it as, say this first chart basically represent mean of claim. Okay, and this is my first chart. Okay, something is missing. Okay, mean we have not defined yet, and the same thing I will do for median. Okay, now if I use median, so it will overlap my chart. So there are two charts which are getting overlapped, but I don't want it like this. So I want the height to be median plus 0.35. Let's try to understand what will happen. The height we have adjusted to median plus 0.35. but the median actually we are going to extend the x-axis by 0.35 units. So that's what we will do. We will put height as it is, and here plus 0.35 we will put. Okay, so right now the indexes are male and female. It is not numbers. Like in the case above, it is numbers, but in our case, the indexes are not numbers. So what we will do is we will put indexes as numbers. So we will put two things, that is 1 comma 2, and here also we will put 1 comma 2. Okay, and let's see how this chart looks like. So it is not able to concatenate the value 1 comma 2 with 0.35. So let's try to understand how we can do it. So the
Recording stopped.
pause एक minute. Now we will try to understand how we can create a column chart. So here is an example to create a column chart. So firstly, we have Python marks and R marks. We are going to compare the Python and R marks using a column chart. So first of all, we'll create an index because we have 5 values. I want to compare 5 values, so I will create an index of 5 values, and then we will create a bar chart to first show the Python marks, and for that we will pass x as index, whatever index we are passing, and height as whatever value of marks that is there. So based on that the height will be decided, and then we have plt.bar to again to create the second line of chart for R. So first blue one basically is for Python and orange one is for R. Now we created. Now let's try to understand this code in a bit detail. So we are using the indexes on a scale of NP arrange from 0 to 5. So the code starts from 0 to 5. That's why the index will also have the same values 0, 1, 2, 3, 4, 5 here. What we are doing is we are creating the first bar at suppose at the 0th index or 0 plus 3.5 index. So after 3.5 I want to create another bar, which means if this is my first blue bar, so after this blue bar I want this orange bar. So for orange bar which is for R, so I have to add on x-axis 0.35 units. So this, because when I create another bar it will be drawn on top of this, so I don't want it to be drawn on top of it. I want it to be drawn after 0.35 units so that I can simply compare it, and that's what we are going to do in this plot. So we will modify the data, and later on then we will use this x label, y label and whatever it is, and we will use the xticks approach also. What is this xticks? We will I'll tell you to put the labels as such. Okay, so what we will do is we will try to create this chart for our data which is on this insurance data. Okay, so first of all what we have done and what I have done is I have grouped the data based on mean values. So this is the mean value, and after grouping the data based on mean, this is female and male values, mean average values. This is the median of male and female in this data, and D of group by. I want to compare the mean values with the median values for each of these data points. So I have calculated this value. I will create an np.arange for xticks. So np.arange will be equal to length of my any mean or median. So whatever is the length of mean or median, based on that np.arange will create an array. I will call this array as an index. Now we will use this index to create a plot. So plt.plot, we will use plt.bar basically, and on this bar I will put the same index, but the chart that I want to put, or the value that I want to put, is the mean value. So I will put mean value here. Mean value basically indicates the height is equal to mean, and for each of the values, each of the indexes, the height will be taken as mean values here, and I will put width of this chart is equal to 0.5 say, and I'll just put it like this, and this is my first chart or the first bar that we are getting here. Now as this is my first chart, I want to draw another chart for median. So if I draw it for median, you can see it is creating, but it is creating on top of it. So I wanted the chart to be created, the orange one to be created after this blue one is done. So what I will do is I will put index plus 0.5 units. So now you can see it is creating, but we can see there is a lack of distance between it. So first of all, I will just give the label of this chart, and the label of this chart is first for mean values, and here the label that we are going to pass is median value. Okay. So we have created this chart with an index of 0.5, and you can see how this chart is getting created. So far we have used this value here, we have used the equal width, we have used the equal height, and we have used the equal height, but here I want height as median, that is why the height of median is over here. Now we will use plt dot xticks, if I put 1, so see how it is creating chart. 0.1 it is creating charts like this. If I am putting 0.5, so it will create charts like this, and based on that, so it depends on where I want to position this chart, it will automatically get positioned. Now this is the height of the chart, this is the width of the chart, and this is the height. I can try to increase the height of this by say 1.0 or something. Let's see, say if I increase the height width of this chart, so it appears like this. So I will keep it as it is, constant. Now the most important part is xticks. So xticks is to create this set of values. So what we will do is we will take ticks is equal to index into 0.35 by 2. Why we are taking index into 0.35 by 2? I am going to position these labels on my x-axis. So in order to position these labels on x-axis, I have to specify the coordinate of x-axis. So this is ticks are going to be placed at index plus 0.35 divided by 2, which means whatever is the index of this, whatever is the starting point of index plus 0.35 divided by 2, if I keep it, it will give me automatically the same indexes. We will try to use it here as well. So this is my x-axis. Let me put 0.35 over here, here also 0.35 as the width, minimize the space issue. So this is our chart that we are going to create, and on x-axis ticks position I have to mention. So I will put whatever is the index as it is shown here. Ticks is equal to index plus 0.35 divided by 2. So ticks is equal to index plus 0.35 divided by 2. If I keep it, so this is the position of my ticks, but I want to give some other labels. So whatever labels I have to give, A, B, C, D, whatever it is, I will give it. So labels is equal to, I am going to implement it, the labels given by median or mean or whatever one of it. So I will use median dot index as my label. So I will get the same index. So this represents female and this represents male. So at the end I can put plt dot show, and you can add the title part as well to create this chart. So you can see this is the chart that we can create, which is a consolidated bar chart for column bar chart comparing two values. Now we will talk about stacked bar plot using Matplotlib. So here also similarly we are going to use, but if you remember the mistake, the one thing that we created last time, so it is the same thing. We are not going to do anything different. The only difference we in this chart is going to be where the only difference that is going to be for this chart is this is our column chart, and if I want to create a stacked bar chart, so I will remove this index plus 0.35, and this is going to be like this, and I will remove this, and this is how my chart can be placed. So this is our column chart, bar chart, stacked bar chart to compare two values. Okay, now I can also put plt.legend to clearly indicate what is the color and what does each of the color represent, and here also we can use plt.legend. So legend is position anywhere, as you can see. You can change the position of the legend as well. So we can see the legend values also. So that is this is how we can create stacked bar chart. Now we will move on to the pie chart. So pie chart is a circular graph that divides into sections displaying the numeric population proportion of information for each of the category. It is used to display the univariate data, and each section of the pie plot, or basically the wedge of the pie represents a single unit. So this is our pie chart, and we will try to create a pie chart based on the information which is here. So what we will do, we will take a region wise count of data, and we will create a pie chart based out of it. So let's create a pie chart. So plt or df region dot value counts. So this is the information. So I will use regional counts is equal to df. Okay. So this is region wise value counts of my data. Now I want to create a pie chart for it, so I can use plt.pie directly, and I have to specify what are the values that I have to pass. So I will put regional counts like this, and if I put it, it is saying that regional count is not defined. I'll run it. This is the pie chart, but this pie chart is very empty. It doesn't show much of the information. So I have to put labels also. So labels is equal to regional counts dot index. I will put dot index. Let's see, and it will grab out the regional but indexes, but it is not giving me the proportional representation of it. For this I can use auto pct is equal to, and in the quotes I can use percent 0.2 f percent, and this will give me proportional representation of each of this condition, each of this data in my pie chart. And we can use plt.show to create a pie chart directly without giving the instances or objects of this each of these wedges. So percent, so let's understand what is each of this component. Labels will give us the labels. Auto PCT is used to put this label of proportional calculation. So auto PCT, it will automatically calculate the percentages and put it as a labels on my pie chart. So percent 0.2 ff basically indicates how many floating point numbers you want. If you put 4, so it will give you 4 decimal points after it. If you put 1, it will give you 1 decimal point after it. F basically indicates floating point number. So this is the general syntax to create a pie chart. Now there is an additional to this pie chart. Let's try to understand. So here if you want to add custom colors to this pie chart, you can get the color from the CM. So what is CM? CM is a color matrix. So basically you can import a CM or the color matrix from Matplotlib, and you can set 2, 4, 6, 8 as color codes, and automatically the same colors codes you can just replicate here in your argument. So it's a very simple thing to do. Actually we can do it in our system as well. So let's call out import from Matplotlib import cm, that is color matrix. Now I will use cs is equal to cm. Now see, I have to create color matrix of set 1. So there are different sets basically. So cm dot, you can specify set and you can specify 2 comma 4 comma 6 comma 8 like this, and color you can use the same color palette, color is equal to cs, and it is getting okay color. There is no argument as such for color, so the argument that we have is colors, not color. So I will use colors, and you can see automatically the color has been changed. You can use say 1 comma 4 comma I don't know whatever color, so color will automatically change. You can change the color like 15 if I put. So different color will be getting based on the set that you are specifying. So here I have specified any value and the same set of values I am getting over here. So that is additional thing. Now there is an additional part, that is explode. Sometimes you want to show a particular wedge and or highlight a particular wedge. So at that time you can use explode. So what is explode? Let's understand. We know how to create a pie chart. This is our pie chart. In our pie chart there are 4 parts: first, second, third and fourth. So I want to explode and show the second part. So what I can do is I can put 0.1 as the explode parameter. Now this, there will be a gap of 0.1 unit here after the first chart gets created. So this is our first chart, suppose first wedge. So for a wedge of for this wedge 0.1 unit explode or a gap is kind of created. So that's how we can do it. So we can use explode in our pie chart as well. All we need to do is add an additional command, explode is equal to, and you can just put 0.2 comma 0 comma 0 comma 0. So 4 values we are passing and it is creating a unit. So you increase this value and automatically the size or the gap is also exploding. So it depends on our use case how much we want to give. So I want to give only a small proportion, 0.01 also. If you give it, a small difference is created. You can see a kind of acceptable value difference is created. So this is how you can create pie chart using Python. You can also create a donut chart as we can see here. So all you have to do is over your pie chart you have to just create a circle with the same center, xy is equal to 0 comma 0 on top of your chart. So suppose this is our data and this is the data, we consolidate the data, we create counts of it, we create the pie chart. So till here we are created. All we have to do is we have to just add a single circle at the center point. So you can use circle is equal to plt dot circle xy, radius we can give as per our requirement, and color is equal to white we have to give because the background color is white for this entire chart. So color we have to specify white. You can use plt.gcf and you can add artist circle. So let's try it out in our Jupyter notebook as well. Circle is equal to, so we are going to create a circle which is of the size radius 0.4 and color is equal to white. So let's do it. Okay, I'll put color white and I have to also specify the xy coordinates. So xy coordinates we have to pass it inside parentheses as we have seen. 0 comma 0 is the center point of my circle, so that I have to specify 0 comma 0. Okay, now it is showing Matplotlib pyplot has no attribute called circle. Let us see if we have circle over here. We have circle with CS capital. We will use C capital, and you can see I'll remove this exploding part for now because I don't want it. Okay, now see the circle I have created, but it is not visible on our chart. So in order to make it visible, we have to call GCF, and you have to add that circle to your existing circle. So plt.gcf we have to call in, and inside it we have to pass plt.gca add artist circle. So plt.gca dot, so add artist, so we are going to add the circle that we have used. So we have used the add underscore artist circle we are going to add, and let's try to see how this add artist. So you can see a donut chart is creating. All we have done is we have added a circle on top of our chart. You can reduce the size to 0.3 units and we can have a clearer vision of this chart. It now looks like a perfectly donut shape chart. So this is our donut pie chart we can create, and then we can also try to understand what is a scatter plot. So scatter plot is a systematic representation of data where we can compare two numerical values on a scale of x and y axis. So one numerical value can go on x axis, another numerical value can go on y axis. So scatter plot can help us out here. So in order to create a scatter plot, there are different versions of scatter plots. Basically it represents the correlation between two numerical entities. So we have positive correlation, negative correlation and no correlation. So based on that we can get a scatter plot. We'll try to create a scatter plot between BMI and claim to understand the data better and see if there is any relationship between BMI and claim. So very simple, plt.scatter, and we can pass df BMI and df, let's say take age over here, and if you create this chart, this is the scatter plot of age and BMI, and if you want to take claim or something, BMI and claim, so that also is possible. So if you see on x-axis if it is a BMI, on y-axis the claim value it is done. So I'll do what, plt.x label, I'll put BMI and plt.y label, we'll put claim and we'll just use plt.show. So this is how we can create a scatter plot. Scatter plot helps us to visualize the data better.
Enjoyed the session? Don't forget to like, subscribe and let us know what Python topic you'd like us to cover next.